Do you know that in today's interconnected world, a new malware strain is created every 4.2 seconds? This relentless pace of cyber threats emphasizes the urgent need for advanced cybersecurity measures. It's a reminder of the escalating challenges in our digital world. Luckily, artificial intelligence is on the rise, finding its implementation in every field, and cybersecurity is no exception. In fact, AI and cybersecurity are considered two of the fastest growing fields, driving innovation and shaping the future of technology. That is why we welcome you to this comprehensive guide on applying artificial intelligence and cybersecurity together to strengthen our defenses in this new artificial intelligence era. But before we explore all the topics that we will cover in the course, let's take a moment to introduce ourselves. My name is Alexa. I'm an ethical hacker with years of experience in the penetration testing and cybersecurity field. As a best-selling author in ethical hacking, my goal has always been to contribute to the collective understanding of cybersecurity.
And my name is Luca. I am recognized as one of 150 machine learning experts in the world by Google developers, and I've been in AI industry for past 8 years, currently finishing PhD in applied artificial intelligence as well. I had privilege in my career to work for many different startups, smaller or bigger ones, helping millions of users with AI technology along the way. I love teaching, and that's why I'm here, helping you understand these concepts as well and connect them with cybersecurity. And why do we need to learn artificial intelligence for cybersecurity, and what we will cover in this course together? Well, as Alexa previously mentioned, these are the two fastest growing fields today. And due to the cybersecurity field constantly evolving and new threats emerging every single day, we need to leverage the use of AI to sift through vast amounts of data in order to identify abnormal behavior and detect malicious activities and threats much faster. Over the next few sections, we will delve into the dynamic intersection of artificial intelligence and cybersecurity, exploring key topics and define this rapidly evolving field.
Our journey begins with a deep dive into leveraging ChatGPT for cybersecurity and ethical hacking. We'll uncover the pivotal role AI plays in these practices, exploring topics such as introduction to prompt engineering, few-shot prompting, chain of thought prompting, and delving into the advanced functionalities of ChatGPT, including data analysis, DALL-E, and plugins. Additionally, we'll address critical concerns such as understanding how companies may leak data to ChatGPT and strategies to prevent such occurrences, and many more.
From there, we'll step into the new age of social engineering with AI, understanding how artificial intelligence is reshaping the landscape. Here we will cover techniques such as voice cloning with various techniques, enabling realistic voice replicas, and creating deepfakes, unveiling the complexity of manipulating media content. Additionally, we'll investigate the intriguing concept of writing emails in my style, showcasing that AI role is mimicking writing styles for potential image security challenges. This segment equips participants with insights to navigate the evolving landscape of AI-driven social engineering threats.
As we progress, we'll answer the question: where is AI used in cybersecurity today? This will provide us with a panoramic view of the current applications and impacts across diverse cybersecurity domains. Our practical coding sessions include building an email filtering system and a phishing detection system with AI. This hands-on experience will equip you with skills essential for safeguarding against phishing attacks by leveraging artificial intelligence.
Transitioning to our next module, we will explore the impact of AI on network security. Here, artificial intelligence becomes a key player in fortifying network security, focusing on threat detection and prevention. We'll start with the basics, like introduction to network security and traditional detection and prevention systems. Then we'll get into interesting part. We'll simplify the whole thing by implementing logistic regression algorithm for network monitoring. Following that, we will delve into AI for malware detection and critical components in our cybersecurity arsenal.
But it's not all sunshine. We'll also examine the other side of the coin with security risks in artificial intelligence, understanding potential challenges, and strategies to mitigate them. We will talk about key topics such as, for example, data poisoning. This is where we will examine the manipulation of data inputs. We will also mention data bias, which is shedding light on the challenges of biased data sets. Additionally, we will explore the concept of adversarial attacks, understanding how AI models can be deceived. Ethical concerns surrounding AI will also be in focus, allowing us to build a comprehensive understanding of the potential pitfalls in this dynamic landscape.
Towards the end of our journey, we'll include two valuable appendix sections. The first one covers cybersecurity fundamentals, tailored for those new to the field. And the second one provides the artificial intelligence primer for those new to AI, setting the stage for comprehensive understanding of its integration with cybersecurity. So get ready for an exciting expedition into the world of AI in cybersecurity, from ChatGPT for ethical hacking to network security challenges and AI risks. We are set for a knowledge-packed journey. Alright, no more delays, let's dive right in. See you in the course.
Hello everyone, excited to have you on board for our AI in cybersecurity course. Before we get our hands dirty with all the exciting things that we will learn, let's quickly dive into how we will navigate through this learning adventure. Our course is designed with everyone in mind. Whether you are a professional or a beginner or an intermediate, we've got you covered. There is something for everyone. If you're new to cybersecurity or artificial intelligence, fear not. We've created two special appendix sections just for you. They serve as a friendly introduction to the basics, ensuring everyone starts on the same page. Appendix sections are not necessary to go through. If you are more experienced in cybersecurity and artificial intelligence, feel free to just go through the course content without the appendix sections. However, if you are a beginner who is starting from scratch, it might be better to first cover either cybersecurity appendix or AI appendix or both of them. Now, when it comes to hands-on coding sessions and practical lessons, we decided to make things as hands-on and practical as possible, so we set up Google Colab notebooks for coding exercises. It's where we'll get our hands dirty applying artificial intelligence in our cybersecurity tools. Now, another thing I want to point out is that we divided all the lectures into 3 separate parts. What do I mean by that? Well, as you know by now, this course covers both practical and theoretical knowledge within the lectures. But there might be people who just want to learn theory, or perhaps they only want to go through the practical part of the course. Or most of you will most likely want to go through the entire course covering both theoretical and practical part. That is why we labeled all the lectures with one of 3 different letters: A, T, or P. A stands for all, and it is for students who want to follow everything, which will be most of the students. T stands for theory, and it is for students only interested in covering theory lectures. And P is for practical or programming lectures, which are for students interested in coding projects only and in practical sessions with ChatGPT or other AI tools. Feel free to choose your own path. I advise going for A, which is covering all the lectures, since only like that you get the complete picture of AI in cybersecurity. And one more thing I want to mention is that learning is a journey, and questions are a part of the ride. If you've got any doubts, thoughts, or just want to chat, head over to the Q&A section. It's your space to engage with instructors and fellow learners, making learning a collaborative experience. And in a nutshell, this course is not just about knowledge. It's about hands-on experience and community learning. So buckle up, explore the appendices if you're new, dive into the practicals on Google Colab, and remember, our Q&A is open for all of your questions. Let us not make this any longer and let the learning begin.
When using ChatGPT or any large language model LLM-based AI tool in the field of cybersecurity, it's crucial to define your goals and the desired behavior of that tool. This is often achieved through something we call system prompt or a role prompt. Let's dive into this concept right now. In ChatGPT, before posing your question, you can set a context like this. I prepared prompt for us so we don't have to type everything out. Now, I am a cybersecurity expert. Provide concise cybersecurity focused responses and use bullet points or table for clarity when possible. And I can use this, which is your system prompt. You will see that it won't go into a specific task because only understanding what it needs to do. So it's just a way to explain the way that you would like it to respond. Alternatively, you can use some more structured approach. In ChatGPT, for example, to achieve this, you have something called custom instructions. So when you go to your settings right now, click on your account and you have this custom instructions right here. So you will see that you have two boxes. One is here through a thought starter. Where are you based? What do you work for? What subject can you talk about for hours? What are some goals you have and so on. Then for the bottom one, it's structured output. So for example, I'm going to copy my part of the first part. And here is what I wrote. Act as a cybersecurity analyst named Alex. You can name whatever. It's just kind of a more personal touch when you give it a name. Alex has extensive experience in network security, threat analysis, and incident responses. Alex is dedicated to helping organizations strengthen their security posture. They believe in a holistic approach to cybersecurity, encompassing both technical and human factors. Now, this will give a context. After that, you want to define the style that you like to use. So I created another part for that, and it looks similar that we had before. Writing style, you can remove or use this. For example, Alex's style is analytical, focused and straightforward, aiming to provide actionable insights. Alex adheres to these guidelines. Never reveal that you are an AI. So I don't want it to specify that, hey, I'm AI, I can't help with that. Avoid language that implies uncertainty, such as maybe, possibly, or it seems. Be certain with it. If information is beyond your knowledge or beyond this date where it was trained on, simply state unknown. Do not include disclaimers. Don't direct to external information, like, for example, I don't have that information, please check this and this. Prioritize the main points. Simplify complex cybersecurity concepts. Seek clarification on vague or ambiguous questions before responding. Reference credible cybersecurity resources or sources or data where applicable. Correct any errors in previous responses promptly. So I'm going to activate this and click Save. Now, just for your information, in the resources of this very lecture, you will find all of these prompts selected for you and written in a text that you can download and put inside of your ChatGPT as well. Okay, so once you create this custom instruction part, you need to create a new chat. So it will not be applicable to old chats. And for example, I can ask DDoS. It's just a concept, yeah. And here it is. It will follow all the guidelines that we provided, use bullet points, reference everything that we defined, and it's not like it won't explain everything, but it will follow the rules and be consistent with the knowledge it has. Cool. And that's it. Now you have this, but we didn't explain how we reached this point, so don't worry. We're gonna break the whole prompt step by step from the next lecture and explain how to go and reach this point where you know the rules that we went and explained in these prompts. So let's do that from the next video. So far, we learned a couple of techniques used for prompting, one being role prompt or system prompt, another one where we structure the output. So basically structuring the output of the prompting or the result is itself, like tables, be consistent, and so on. Now, those two are really useful, and you can use it as just part of a prompt or as a whole custom instruction as we did before. So I still have this loaded as from the last lecture, and we're going to keep it for now to see how it's actually going to help us through the next couple of lectures. So the next step or the next technique that we want to know is few-shot prompting. So few-shot prompting is really simple. We're going to give it a couple of examples where we actually prompt and then expected result. Prompt, expected result. Prompt, expected result, and generally 2 or 3 are more than enough, and more the merrier, but generally 3 is enough to capture the rule. Provide all of these prompt examples and responses that we want or expect. It's time to provide a question that we would like it to answer. So let's do that. I prepared a couple of prompt and expected results. So here it is. So here is the first one. Prompt 1, code analysis, infected versus uninfected. Input, analyze the following Python code snippet for security vulnerabilities, indicate if the code is infected or uninfected. And this is Python code. Then expected result, the code is infected. It contains an SQL injection vulnerability due to the conceptual of user input directly into a SQL query without standardization and parameterization. Amazing. Then we have another prompt, which here I would like it to actually check the JavaScript, and the code is infected with the potential of cross-site scripting. Okay, so I'm going to provide only 2. I have the expected results for the final one, but let's see if it's going to capture all the results for the next one. And it's going to start typing something. So I'm just going to stop it right now. And here what I'm going to provide as a query is this. Examine this Java code snippet is following best practices to handle user authentication. And provided demonstrates good practices. And it is correct, yes. So it is uninfected and it provides a good practices. So this is basically an example of where we provided 2 negative ones, and we actually expected it to provide a negative because we have 2 negative examples. However, it followed our rules and it provided a good explanation of why it went to details. As you can see here, the structure is the same as we have it before, which means that it's gonna follow everything that we provided in the first lecture in the custom instructions. Amazing. So the code or the prompts that we used for this example is provided in the resources of this video, so you can test it out yourself. Let's learn a couple of more amazing prompt engineering techniques that can help us for cybersecurity in the next video. Welcome to Chain of Thought Prompting tutorial, a method that breaks down a complex task into smaller chunks, which is called Chain of Thought Prompting, where we are actually entering the discussion with a smaller chunk of the output that we expect, and based on that, we are building upon the result that we actually want to get. To achieve this, for now, I will turn off our custom instruction just to make sure that we are actually implementing something well. The first prompt that I prepared for us is this one, and you can find all of the prompts in the same order in the resources of this lecture. This is basically the prompt. I'm the CISO of multinational corporation. We are researching our cybersecurity strategy due to recent threats. In a table, list the pros and cons of enhancing our security measures versus adopting entirely new strategy methods. So most users of ChatGPT or other LLMs would go and ask it to define the whole strategy for themselves. Now, it will be somewhat efficient, meaning it will generate some result, but we are not getting the best result or the best quality of that. So you can see here, it actually focused on the result of pros and cons without going too deep into the strategy. We didn't ask it to decide or whatsoever. We just wanted it to prepare the comparisons. Now, when we have that, the next prompt is to continue building on top of it. We said, okay, based on the previous response on cybersecurity strategy, create a table detailing the pros and cons of adopting new technology, specifically in terms of integration with existing system, including a third column with examples of companies that successfully integrated. And here it is. And you can see that this is a chain of thought prompting. We used the previous response to build the next query, and then we are gonna build on top of it for the third time as well. So this is the last prompt for this example. Once it's done, this is the table that has successful integration examples, problematic integrations. Okay, cool. So we have also the cons here, the list. And now that we have that, provide a table with the 5 reasons why a well-known company's cybersecurity strategy failed, focusing on their inability to effectively integrate new technologies. We actually got into the details on what are the most common reasons of failing, which actually use all of the previous examples or previous responses to build that response. And how amazing is that? And especially the fact that we are not using custom instructions, which might even create a better response right here. And that's it. This is the chain of thought prompting. So building upon ideas that we got in the previous response to get more and more detailed response down the road to build the whole document, strategy, whatever we want. Now, in the document that I provided as a resources to this lesson, you have another example. I want you to test it out yourselves and see what are going to be the results. Okay, see you in the next video. Now that we know many of the prompt engineering techniques, it's time to do some exercise. In the resources of this video, you will have a file called cybersecuritylogs.txt. It's a small textual file with a couple of log entries, basically. And I want you to upload this file to ChatGPT and write a prompt that will analyze and extract information from this text file. You can use anything that we learned so far, from role prompting to few-shot prompting to chain of thought prompting, whatever you might think it suits this exercise, and you can solve it with any of those to extract the relevant information from these logs. Okay, so download the file to your computer, and just a quick note on how to upload the file once you are in ChatGPT 4. Unfortunately, this is for only ChatGPT 4 options. You can click on this, and under Downloads, select Cybersecurity file, which we just downloaded, and it will download right here. You can just immediately write the full prompt below it, and it will do its job and analyze the file. I want you to have fun with this, so experiment as much as you like. And of course, if you need help, in the next video, we're gonna solve this together. See you there. I hope you had a lot of fun solving this one. And here is my solution. I used system prompting or role prompting, and then provided the context and told it what I want to do in which format. So the system provided with the log file. Your task is to extract all relevant information from every line of the text file, and structure it into a table format. Some of the info I want: date, IP, username, and action. I didn't test it out, so this is the first time that I'm testing in front of you. So once you upload the file, it will start analyzing. If you open this, it will actually write a Python code. If you don't know how Python works for now, don't worry. And we're just gonna close it. It will write another Python function that will analyze all of the outputs that we got. Okay, and this is our result. You can go and visualize the whole analysis process if you want to see the Python code, and that's it. This is how to analyze a file, log file, using ChatGPT. Now, there will be a larger cybersecurity log file that you can analyze down the road. So let's continue and learn more techniques in the next video. Now that we know main prompt engineering techniques that are out there, it's time to take a look at our custom instruction that we introduced in the first video of this section and analyze it together to see all the moving parts that we didn't explain before, to see how to build it yourselves. So you can find the file to custom instructions in the resources of this video if you didn't follow from the beginning. Okay, so here I'm gonna go to custom instruction and activate it so we can analyze it together. The first part starts with act as a cybersecurity analyst named Alex. This is our role or system prompt. Alex has extensive experience in network security, threat analysis, and incident response. Now, this is something where you want to be precise of what you actually want to achieve, and this is context building or context prompting. Alex is dedicated to helping organizations strengthen their security posture, which basically alludes on what is the core technique or what is the core value that it will send to user as a response. And they believe in a holistic approach to cybersecurity, encompassing both technical and human factor. Now, this is really important because when I talked to Alexa and we actually discussed on what is really important to cybersecurity these days, we discussed on it is a holistic approach that will dominate in cybersecurity. So this is what we want to achieve with ChatGPT as well. And below, it's more of a technical prompting of what you want to achieve as an output. So starting with basically setting the guidelines and setting all the things that you don't want it to do or that you want it to do more often. For example, ask for clarification questions or do more credible sourcing. But if you want to strengthen out the whole system right now, you can use a couple of few shot prompting below to make sure that you are getting the best quality output that you can. But here is the whole prompt. So nothing spectacular. We started with the context and role prompting. We build the whole rapport, and then we set basically rules, what you want to see in the response. Click save, and you are good to go. Now you know how to build a good custom instruction that uses all the techniques or most of the techniques that we discussed so far. So let's continue with this and start exploring more advanced techniques. So far, we used only the training data of ChatGPT to extract some relevant information. But quite often it's not the most correct resource or most updated resource out there. And that's why they added something called browsing with Bing, meaning the ChatGPT can go search the internet or scour the internet for the relevant information and find it and bring it back to the result. Now, another thing that I would like to do is to summarize that data into crucial points. So let's say that we are doing a research about the company or about a certain topic. So to achieve this, I would write as you can see here, it's saying doing the research or visiting websites and stuff like that. So it's actually going on and scouring the internet. We didn't specify any website, but you could, if you want, for example, to paste the URL, it will go to that specific URL and summarize the content of that website if you want to achieve that for a specific part of your data stream. And that's basically it on how to go to find that information and summarize it. ChatGPT is amazing in summarizing data. So if you're doing a research about a company or about a system, it's basically this point where finds and summarizes all the information for us. And here, for example, a password access management, session hijacking, AI-driven security mechanisms, which we are exploring in this course. And then tech consolidation, increase regulatory compliance. For security careers, we have engineer, pen tester, infosec analyst, network security specialist, ethical hacker, security software and developer, and stuff like that. Now, if you're considering whether or not it's a true information, you can go to all of the resources that it provides and find that information yourselves inside of that resource that it used. Okay, let's keep exploring further. See you in the next video. Besides traditional prompting to ChatGPT, it has some advanced techniques that we can leverage to find the full power of ChatGPT. One being browsing with Bing, where if you write anything, for example, from the last video, you can write that it goes to the internet, does the research, and summarize everything under one roof, which we did in this prompt right now, and found all about cybersecurity careers from 2024 and beyond. And we found all the trends and techniques that people would expect happening from next year on. From, well, 2024. Maybe you're listening to this in 2024 as well. Okay, so this is basically what browsing with Bing means. Asking it to go to the internet, to specific website, document, and finding the relevant information, which is crucial when you're doing a research that you don't want to leverage only specific file or a specific knowledge from ChatGPT, but you want to expand to real information out there. Now, on top of that, there is something called data analysis feature. And data analysis feature allows us to upload the file that we did in exercise, or you can actually write the full functional program with it. So what I basically ask this model to do is to import the data set, process it with certain steps, and make predictions on top of it with machine learning algorithm. However, as you can see the output, it will structure everything in perfect way, but it said that it unfortunately can't import the IMDb dataset. Or, well, it can't find it, which is debatable because there is one in sklearn. But let's do the same thing for Iris or Boston housing dataset from sklearn. And I'll just point it to the right direction. Of course, this is just an idea what it can do, because in most cases you will upload your own data set. So in this case, it will do everything from Python, which is just demonstrating what it can do. But if you have your own data set that you want to upload to this, you will be able to do that without any issue. As you can see here, it analyzes all the features. Then it will do the same thing for our targets, which is our median value or price of the home. And then it will do all the pre-processing steps, such as train and test split, or making the data set for our prediction. And on top of that, it will make some predictions. So if you want to click here, you will see some code that it actually executed. And you will see here that mean square error is 24, or R squared is 0.66, which is a decent one. And yeah, you can see here all the analysis. How amazing is that? You can do the same thing for your own data set. Now, if you want to upload the full data set to ChatGPT, you definitely could. For example, later down the road, we will build all the custom algorithms in the future section. But if you want, you can upload them to ChatGPT and explore how it will provide or do predictions on top of that dataset. The next feature that is really useful for ChatGPT is DALL-E 3. So what I want to do, I'll create a new chat just for sake of it. And here I will say, generate an image of a puma running next to a bunny in a cartoon Pixar style. Okay, so DALL-E 3 or DALL-E is a model designed by OpenAI to generate images. There are quite a lot of competitors currently on the market of image generation, like Stable Diffusion or Stability AI, Midjourney, DALL-E 2, and some of open source models that you can find on the internet. However, all of those require quite a lot of the techniques and prompt engineering skills to generate a good quality image, where they actually abstracted all of that, and in the background it is writing a prompt for us. So if you click on the image, in some cases you will see the prompt that they used automatically generate for you. And here is an amazing image, really cute image of a bunny and a panther or puma running next to each other. How amazing is that? I love it. Okay, and the last thing that I would like to show you is plugins, where if you go to the new chat, you go to plugins, and by default, you will see nothing right here. But plugins has its own store. So store is also here that allows you to install plugins that connect to external data information. So plugins are built by companies such as Zillow, PDF AI, Chat with PDF, Diagrams, and so on, that allows you to add that functionality to your ChatGPT. Here I have Zillow, for example, plugin, and just bear in mind, depending on when you watch this video, sometimes the companies that are building these plugins might remove these plugins from the store for security reasons, for maintenance and so on. So Zillow happened that couple of times, but Zillow basically removes and adds their plugin for quite some time now. And if you want to use it, just please check on the store if it's still available. But the same strategy applies for all the plugins. So here I want to get the most visited houses in Boston currently on the market. I just asked a really abstract question to the Zillow, and it will find most visited houses, whatever that might be for them, and list them out for us if they can find something. Okay, yeah, they found it. Cool. So we have one, which is right here. It looks like I'm promoting these houses, but I'm not, because I don't know what is going to be output. And here it is. Oh, good apartment. Okay, cool. So you have a couple of different houses that are currently on the market. You can regenerate, you can get all of the condos or information from here to find out what are the most active, or what is the house of your dream you can potentially find through this plugin. What it means, you can ask, get me the specific house under $100,000 or under market value, or that I can afford with this type of a mortgage rate and stuff like that, and it will go and find that information for you. These are all the advanced techniques that we'll cover for now. So these can be used with all of the premium or pro versions of your ChatGPTs that you can use with ChatGPT 4 or ChatGPT plugins to extract additional value to yourself or to your business. Okay, so let's continue with this trend and see you in the next video. It's time for another exercise. In the resources of this video, you will find another file that is a bit larger, which is huge log files that is building on top of the other one. I want you to upload this file to ChatGPT and write a prompt to summarize and extract the crucial points for us where we need to follow along and base our research on, because that is a bit heavy and long file. Okay, so you will find that in the resources, you know how to upload the file to ChatGPT 4. So let's do that together. If you need help, in the next video, I'll show you the solution. Okay, I loaded the file that I provided to you directly to ChatGPT and wrote a simple prompt. Summarize this file and extract main points to focus on as a cybersec team. It will read the document and it will provide here bullet points, multiple port requests, login activities, and from this point on, now you can focus on the main points, pain points, or general behavior that you need to focus on as a team. And here it is. So how amazing is that? Now you can provide, of course, your own logs. I wouldn't suggest directly because of the security issues, but definitely something to consider. Okay, cool. And that's it. This is the solution. Hope you had fun solving this, and let's continue learning. See you in the next video. ChatGPT is definitely most prominent or most famous AI algorithm in the world right now. But it's definitely not the only one, and sometimes not even the best one. So there are a couple of competitors that we can consider when we talk about generative AI, especially for chatbots. And one of those algorithms or competitors is coming directly from Google, called Bard. Now, you will go to the Bard in the link of the resources in this video to find out the Bard. I don't know if Bard is accessible to every single country because they are constantly changing that depending on the rules and AI adoption and stuff like that. So it's up to them on decide where and when the Bard will be released. To be honest, in my country, in Belgrade, Serbia, Bard was not accessible for quite a long time. Okay, so Bard is the same as we had in ChatGPT. It allows you to ask prompts such as generate top cybersec careers from the 2024 and beyond. And it will go and find that information for us. Now, you will see that it actually looks for resources and courses and all of the sort of amazing stuff. And to be honest, sometimes Bard is much, much better and more robust than ChatGPT. So definitely have it on radar when you define and do the research for your own. The only negative side, though, is that it doesn't have as user-friendly API when you want to build some application out of it. But if you're just doing a research and you want to know, this is a definitely amazing algorithm to know. The prompting stays the same. So all the rules that we applied and used for Bard, so for ChatGPT, it applies to Bard as well, or any other algorithm that we're going to discuss in this video. The Bard has an option to double check responses, which is amazing, especially in generative AI, where they are always confidently wrong. So they're not really sure whether or not the data information is quite there. So you can see here that some information is green, meaning that it found the resource, but some information is red, meaning yes, it is there, but it didn't find the official or exact results. You can always go and find that information there. Another amazing feature that Bard has is this view other options. So if you don't really like the way of the answer that it's structured, it always generates at least 3 responses for you. So you can go and select which one works best for you. Besides that, when you scroll down, you can modify responses to be longer, shorter, simpler, more casual, and so on. So it is really useful when you want to, for example, share something or just create a blog out of it. Now, one more thing which is amazing is integration of all Google's products directly to the Bard. So for example, I want to go and structure this response to table. It will go and do it. And amazing thing about it, once the table is generated, we can open the table directly in our sheets. How amazing is that? So on a simple click, it will generate a new document for us that will have all this information there. Okay. And to not stop the fun, there are extensions as well, which are all Google based. So if you love Google Stack, you will love this. So see, you will have Google Flights, hotels, maps, YouTube workspace. So if you want to coordinate and work with G Drive, Gmail, Drive, Docs, you can find all of the documents, summarize documents, locate information, everything that you will like. So everything directly from Bard, and it's private. So it's amazing. Another competitor, well, kind of competitor, is Bing Chat. It's kind of a more substitution. So Bing or Microsoft actually invested a lot of money to OpenAI, which made ChatGPT. And on at their end, they have this algorithm called Bing Chat, which is with ChatGPT 4. And inside of it, you can search the internet and, for example, find the most popular or prominent jobs in cybersecurity in 2024 and beyond. And it will find that information for us. Now, this can access all of the techniques that we discussed or used so far, but this is actually for search alone. So it's not generating text, or it's not chatting as Bard or ChatGPT, but it's more searchable, searching the internet through text. Now, you will see here that it has a creative mode, precise mode, and balance mode. In most cases, I'm gonna use balanced, but if you want to be precise, like information-wise, you need to use that one. If you want to be more creative when they are structuring the output, go with this one, but I never actually found a lot of value out of creative one. Amazing information or amazing structure of this output is a lot of resources that we can use to directly access those points that it actually structured. And here you will have 4 messages alone in this chat, so you need to start over searching the internet. So it's kind of okay, but this will grow if you log in, because I'm not logged in to this browser. The next competitor is Biotropic, called Claude AI. Claude AI requires us to provide phone number, and it's currently not accessible from Serbia. So unfortunately, I can't create an account without using VPN and stuff like that. But you don't have to use Claude AI. It's more important just to know what it is out there. Claude AI is amazing when you work with files. So if you need to summarize the file, load the file, information from a file, use Claude AI, and it is free. But if you want to upload larger files, up to 100 plus pages, you need to pay $20 per month. But the rest, like search, plugins and stuff like that, it's not available from Claude. And that's it. These are 3 most prominent These are 3 most prominent competitors of ChatGPT at this stage or at the time of recording. Okay, enjoy, play with all of this, and see you in the next video. It's really important to take care of your data. No matter if you are an individual or a company, these tools are not quite an environment where you want to share the private data yet. They had some guidelines on how to use them or how to handle the private data, but they're not really taking care of that in the right way. So I would definitely suggest using really precautions when you use private data. The best case is not to use private data at all. Don't upload your self data, your resume if you need. Try to remove the crucial information like phone number and stuff like that, and the rest is there to be used, for example. That's the first rule, and I would definitely suggest always turn off or remove the possibility of entering private data about your clients, about you, contracts, about your company, source code, anything that might be IP or personal data. Try not to upload to any of these tools. Bard, ChatGPT, Claude, Bing Chat, anything. The second approach is if you really need to upload that data, make sure that to dedicate time to anonymize it before. So anonymization of these techniques basically means that if you are using a resume of your employee or your candidate, remove the personal data or replace it with John Doe and stuff like that. The anonymization process takes some time, and that's why most people will not do it. So then go follow back the first rule, which is not to upload this data at all. But if you must, make sure to anonymize it first. The third rule is to turn off the history setting inside of ChatGPT. Now, it might still leak some information, so that's why it's kind of a third possibility, but it's out there. To do that, go to your profile, and under Settings, you will see that this Data Control, and here, Chat History Training. Select Off, and you will see here that you can't save the history that you are chatting with ChatGPT. It's not user-friendly because you won't be able to go back and take a look at all the chat that you had. However, it won't save on either on your end or on their end as well. So it's kind of a secure privacy setting. But it's a really important to note one more thing. If you change the browser and you still use your own account, this will be turned off because this is browser based. So if you change the computer or a browser, make sure to check it out again. The last step is to use API and or Enterprise Edition. So if you're Enterprise, use Introduction to ChatGPT Enterprise Guideline to introduce yourself and your employees on how to use it. So every employee in your company will be able to use ChatGPT or GPT-4 for their own work. You get your own instance, you get completely private environment where you can check and search your data. If you go with API and build your own products, they are guaranteeing you that they are not going to preserve any information coming from your product. So these two options are for developers or enterprises with a lot of employees that are gonna jump on this opportunity and create the environment for them. And that's it. These are 4 steps on how to preserve your information using AI tools. Now, the last one is only applicable to ChatGPT, unfortunately, because the other ones don't have Enterprise Edition so far, but in the future they might add. See you in the next video.
Do you perhaps know what is the #1 cyber attack on the internet? Well, let me give you a hint. It is the name of this lecture. That's right, social engineering and phishing present the #1 threat today online, with millions of phishing attempts being executed every single day. But why exactly is that the case? Well, to understand that, we must first know what is the definition of a vulnerability. A vulnerability in the context of computer security and cybersecurity refers to a weakness or flaw in a system's design, implementation, or configuration that could potentially be exploited by an attacker to compromise the integrity, availability, or confidentiality of that system. But vulnerability is not only found in software. It is in fact much more common in humans. People can be tricked and exploited much easier than you would exploit a software. Imagine this. You're hired to hack into a big company that invests millions of dollars into their security features. They have all the latest antiviruses, intrusion detection and prevention systems, best firewalls, and firewall configurations. It would be quite hard to hack into something like that, right? You would have to find bugs or software vulnerabilities in one of their systems which are constantly being patched, plus you would have to evade all the security measures afterwards. That would be quite some work, right? Well, this company has employees as well. These employees work on the computers that are in the company's network behind all the security measures protecting them from online threats. Exploiting one of the employees, or in other words, social engineering them into running something that they shouldn't or giving information that they shouldn't, would be considered a far easier task in many cases. Once an employee opens a phishing email, for example, they could be downloading a malware which then infects other devices on the network and compromises all the confidential data. What is the use of all the up-to-date security features that cost hundreds of thousands of dollars to set up and even more to maintain if one of the employees willingly gives away their password to the attacker thinking they are colleagues, or if they execute a malicious program from the attachments of an email thinking that it is a legit software coming from their boss, for example? That is where the power of social engineering and phishing is. So now that we know this, let us define social engineering and phishing. We can say that social engineering is a broader term that encompasses a range of techniques used to manipulate individuals or organizations into divulging confidential information, performing actions, or making security mistakes. It often involves exploiting human psychology and trust. Phishing is a specific type of social engineering attack that typically occurs through electronic communication. It involves sending deceptive messages via email, text messages, or instant messaging. The attacker impersonates a trusted entity or organization, such as a bank or an online service provider, and lures the recipient into taking certain actions, such as clicking on malicious links that lead to fraudulent websites designed to steal login credentials and personal information, or downloading and opening malicious attachments which may contain malware or, for example, ransomware. Always remember that people are the biggest security weaknesses and they can easily be exploited. That is why phishing is the #1 threat today. Let us name some of the most common types of phishing attacks. First one would be phishing over email. This one is something that most of us have encountered at some point in time. Usually an attacker would send you an email requesting some sensitive information or trying to trick you into downloading a malicious software which would then grant access to the attacker to your device. An attacker in this case would most likely impersonate someone you know, perhaps your boss, your friend, or family member, because those are the people you would trust more than some random stranger sending you an email. If the email is spoofed properly and if the email is written well, it might end up tricking you into thinking that the email is actually coming from your boss. Now, nobody wants to go against their boss, so you would most likely end up doing what the email tells you to do. These phishing emails usually have a sense of urgency to make you execute stuff faster, so you would have less time to process whether the email is real or fake. AI can be used to write these types of emails. And with the latest tools, it is actually being proven that it is far more efficient in writing phishing emails than a regular person would. Remember, it's all about exploiting trust. Another example of social engineering where AI will take over is voice calls. You can call company staff and pretend to be someone that you are not. If you end up gaining their trust over the call, they might give away some sensitive information which can be used for conducting an attack. This information does not necessarily have to be passwords for their accounts, but it can be something as simple as telling you which version of firewall they use. Or perhaps where exactly is the server room located in the building, or by what vendor are the security cameras that they have. This type of information, if asked for properly, might not sound alarming to them, but for you, they might be the only thing you need to be able to conduct your attack. Now, AI is going to elevate these types of attacks to the next level. With different AI tools, we can do both voice cloning and we can even create a fake video of a person appearing to talk and say things that they never said in their own voice. Scary, isn't it? Now, this isn't too realistic for now, but in the near future, this is going to be quite a big security threat and it is going to cause a lot of trust issues since it will be quite hard to distinguish real videos from fake ones. So, in other words, AI has taken traditional phishing attacks such as sending phishing email or calling company staff over phone to a much more advanced level, and so far the best counter threat to this is to constantly educate your employees about the current threats so that if someone calls them over voice call and the voice on the other end sounds exactly like their boss, they should not immediately act upon what is told to them over the phone before double checking it, especially if the action that they are requested to perform sounds suspicious. Alright, Now we will talk about phishing in more details later in the course, but for now on, it's important that you understand what social engineering and phishing is. So let's take a look at how all of the things that we talked about in this lecture look like in practice. Welcome back. So in the last lecture, we talked about social engineering and phishing, and we mentioned some of the ways that AI can affect social engineering. One of those ways was voice cloning. So right now, let us see a practical example of that. Let's see how we can integrate artificial intelligence in order to clone my own voice and make it say whatever I want it to say. Now for this, we're going to use a tool called 11 Labs, which you can find at the link of 11labs.io. Now this is not a free tool, but it does offer a free trial where you can test some of its options. So before we even open it, let's mention what this tool does. 11 Labs uses advanced AI technology to generate high-quality spoken audio in any voice, style, or language. So let's give it a try. Let's click on the 11 Labs link. And here you will have an option to either sign in or sign up. Now, since I already have an account, I will go and sign in. For you, you can simply just create a new account by clicking on this button. I will log in just a second, and here it is. This is the page that it opens up after we log in. If it doesn't open this page, you can simply just click on speech synthesis and it will load this page. Alright, so we have two options here. We have text to speech and speech to speech. Now, text to speech is converting text into lifelike speech using a voice of your choice. And speech to speech is creating speech by combining the style and content of an audio file that you provide this tool with that has your own voice. So these are the two available options. Now for the purposes of this tutorial, I'm going to use text to speech since I'd rather just type in the text that I want my voice to pronounce. And for anyone that uses the free trial of this tool, these settings will be available for you, so you can just click on settings and you can choose whichever voice you want the text to be pronounced in. So you can, for example, choose George. Here you have the description of the voice. So if I select George, under the voice settings, we can change the stability, clarity, and style exaggeration, but I'm going to leave it on default for now. And under the models to use, I'll just go with the default one, which is this one right here. And here we can type any text that we want. So let's just type one sentence. Hello, today is a very nice day. Let's click on generate.
Hello, today is a very nice day.
And it generated this sentence in George's voice. So let's listen to it again.
Hello, today is a very nice day.
Quite cool, isn't it? We made some random voice say whatever we want. But we want to go a step further. I want to clone my own voice. I want to see how realistic will it sound. Now, unfortunately, this is not available in the free trial, but let me just show you how it looks like. So to clone my own voice, I will go on Add Voice, and if you subscribe to the 11 Labs, you will have this option to generate a new voice or to clone your own. See, right here I already tested it twice, so let's do it for the third time, just so you can see how it looks like. I click on Add Generative or Clone Voice, and here I have several options. Now, the one that I'm interested in is the instant voice cloning. This will clone my voice instantly. It only asks for several samples of my voice, and it will clone my voice, which then I will be able to use. However, there is also professional voice cloning. This takes a bit of time, so you provide it with much more samples of your voice, and you have to wait for a few weeks before they send you the replica of your voice. Now, of course, we're not going to be waiting for a few weeks, so let's just go with instant voice cloning. This one, however, will not be nearly as good as the professional voice cloning, but let's just see how it looks like. I'll click on instant voice cloning. I'll give it a name, so let's call it Alexa 3. Because I will be cloning my own voice, keep in mind that if you're cloning a voice, make sure that it's either your voice or a voice that you have permission to clone. You should not be using anyone's voice who did not give you the permission. Alright, now here I need to provide 25 samples of my voice. To do that, I'll just click on here, click on my desktop. Under the voice samples, I have 25 samples of my voice that I recorded. So I'm just going to copy all 25 of them, or select all 25 of them and click on open. Okay, so it already uploaded all of them. We have 25 out of 25 samples ready, and we can proceed to the next option, which is labels. Now, you can set up labels by clicking on the plus sign, and labels are simply just attributes or descriptions of the voice that you're generating. For the purposes of this lecture, I'm just going to leave this empty because we just want to hear the voice as soon as possible. I already provided the samples, so it should generate a pretty accurate voice from this. Let's click on this to agree with terms of services and privacy policy, and let me click on add voice. This might take a minute or two to finish. And here it is. Here is Alexa 3 voice. We can use it right now. So let's go back to speech synthesis, select text to speech, and under the settings, I'm just going to select my own voice, which we just created, which is Alexa 3. I'll select it right here. I won't be changing the voice settings or the model settings. The only thing that I'm going to give it is a bigger script. So to do that, I can just lower this page, navigate to my voice samples, and here I also have text samples. I'm going to open this and copy the first text. So this would be an example of a phishing email. It would be an example of an email that requests all the employees to download a new software from the attachments which they need for their company. So let's see how this will sound in my own voice. We close this, go back to speech synthesis, and here I'm going to paste the entire script. For it to be believable, I cannot have generic greetings, so I need to just type some name. Let's say there is an employee in the company named John, and John is going to receive this message pronounced with my own voice. So let's generate it. I'll click on generate, and as soon as it's done, it should autoplay the message. Let's wait for it to finish. Dear John, I hope this message finds you well. We have a critical situation that requires your immediate attention. As you know, maintaining the security and efficiency of our systems is of utmost importance. To that end, we have identified a vital software update that must be tested and implemented as soon as possible to safeguard our operations and data. Okay, so it sounds quite good. Now, of course, if you focus really, you can hear that it's a little bit weird. But that is just because this is instant voice cloning. If it was professional voice cloning, it would have been much better. But this is also pretty good. We just uploaded some samples of my own voice, and it managed to read this entire script, which, keep in mind, I never said any of this, and read it in my own voice. Let's listen for like 30-40 more seconds to hear how the rest of it sounds like. We need every member of our team to contribute to this effort. The success of this test depends on your active participation. Your role in this process is crucial, and your dedication to this task is highly appreciated. Here are the steps to follow. Click the link below to download the software. After downloading, please install the software on your work computer. If you face any issues during installation, reach out to our IT support immediately. You should thoroughly test the software for any anomalies, bugs, or performance issues. Be sure to report your findings promptly. Provide feedback regarding your experience, including any concerns or suggestions, by tomorrow. We understand that this request comes with a sense of urgency, but it's essential to ensure the security and efficiency of our systems. Okay, that would be about it. Let's not wait for it to read the entire script. I believe you get the point. It reads really well, even though it doesn't sound exactly the same like me, but it does do a good job of copying and cloning my voice. Now, if you want to test out this tool, you can subscribe to 11 Labs, and you can wait for your professional voice to come in 2 to 3 weeks. then you can use it for whichever purpose you want. Just make sure that those purposes are ethical and that you're only using the voice that you have permission to use, or that you're using simply just your own voice. Okay, let's not make this lecture any longer. We saw a pretty cool example of cloning my own voice, and in the next lecture, I'm going to show you another tool that can do voice cloning. See you there. Welcome back. In the last lecture, we saw a cool example of cloning my own voice with a tool called 11 Labs. And in this lecture, we're going to see a similar example of making a voice clone with Resemble AI tool. Now, since we already saw an example of voice cloning, we're just going to quickly go over this tool just to have some variety of which tools you can use. So type in resemble.ai and click on resemble.ai. Let me open this tool, and once again you want to create an account. I already have an account, so I'm just going to log in. And once I'm logged in, this will be the page that it will open. So here I can just type whichever text I want the AI voice to say. Of course, I can also upload my voice and make it read the text, but for that you once again need the subscription to this tool. But once you get the subscription, it works pretty much the same as it did with 11 Labs. So just to test this tool, you can go under the voices, select whichever voice you want, let's say Samantha, English United States, and type here the text that you want. So I can type, let's say, hello, today is Wednesday, and I have to go to work. Let's just do a simple one sentence.
Hello, today is Wednesday and I have to go to work.
Okay, so it said it in a different voice. Now, here, unfortunately, you're limited to only 280 characters with the free version, so you're not able to add too much of text here. Now, this right here is a simple editor. You also have the full editor, which you go to by clicking on this button right here. And it will open a completely different window where you will be able to add several other options. So once again, we have speech-to-speech option. You remember it from 11 Labs. It means converting recordings of a voice into a synthetic version of the target voice that you want to clone. So you would do that by simply just clicking right here, selecting the voice, and writing the text here. We already know how it goes, so we do not need to do it. If you want to experiment, give a try to this tool, select the voice that you want, or upload your own voice and write the text that you want it to pronounce. Nonetheless, let's not make this lecture any longer, and let's get straight into the next one. Hello, and welcome back. So by far, we saw two different tools that are used for voice cloning. We even saw in the 11 Labs how we can clone my own voice and have it read whatever we provide it to. But now let's also take a look at how deepfakes are created and how we can create a video of someone saying something that we provided as a text. Alright, so the tool that I'm going to show you is called d-id. You can find it at this link, which is d-id.com. Once you open up this page, you want to create an account, and once again, I already have an account, so I'm just going to click on login. And once you log in, this menu right here will pop up, and you can select a new video by clicking on plus videos, and you will have several different avatars which you can use. You can also generate an AI presenter instead. Now here is the usual part where the script goes, so here you would type in whatever you want, or you could upload an audio which you want the AI avatar to say. Now we are going to go with the script this time, so here, let me just go back to my samples, and under the text samples, I will take a script, which is this one, and I will paste it right here. So the script says, "Hi, please download the software sent to you in the link attachments. There we have important security updates which are necessary for our company. Please do it as soon as possible. It is urgent." Okay, so this is our script, and we can select the language right here, as well as the voice right here. So you would select, for example, Jane, and you would select the style in which you want this sentence to be pronounced in. Once you have all of your settings set, you just confirm, and then you go on generate video. Once you generate the video, it will take a couple of minutes, and you should see it under home in recent projects. Let's listen to how it sounds like.
Hi, please download the software sent to you in the link attachments. There we have important security updates which are necessary for our company. Please do it as soon as possible. It is urgent.
Okay, so it doesn't look too realistic. But keep in mind, these tools just started coming out, and with time passing, whether it being months or years or weeks, this will get better and better, and pretty soon you won't be able to tell the difference between a deepfake and a real video. So we chose an AI avatar, we provided a text that we want our AI avatar to say, and it ended up sounding like this. Let's watch it once again.
Hi, please download the software sent to you in the link attachments. There we have important security updates which are necessary for our company. Please do it as soon as possible. It is urgent.
Okay, so it's still pretty cool, right? We managed to create a deepfake. Now, this tool, if you want to use to its full potential, you will once again have to subscribe to it. I used all my free credits. You should be able to recreate what I did with your free credits on a new account. And if you decide that you need it for anything more, you can simply just go on pricing and check the subscription for the tool. Another tool you can use to create deepfakes is this one. But this is also a subscription-based tool. However, you can test it with a free video by clicking on this button, selecting which type of video template you want. So there are 3 different ones. If you don't have a business email, you will have to go with the compliment one. And here you can type 2 to 3 sentences, which this guy will then say in a deepfake video. It will ask you for your email address, and once you provide it, it will send the video to your email address where you will be able to download it and view it. Now these are the 2 different tools used for AI video generating, or simply just generating fake videos with AI avatars that pronounce our written text. Choose whichever one you prefer, and if you find any of these tools useful, you can continue using it for whatever purpose you want, as long as it's ethical. So once again, just to mention, do not use any voice or avatar of a person that you don't have permission to use. The best thing is to test it out with your own avatar and your own voice. Nonetheless, let's not make this any longer, and let's get straight into the next lecture. Welcome back. Let's see an example of using ChatGPT to write an email in someone else's style. And for this particular lesson, we're going to use an example of Luca. So what I'm going to show you is how I can make an email that will be in Luca's style by just using his LinkedIn profile. Now, many of you probably already have a pretty good idea of how we're going to do this. So this is Luca's LinkedIn page, and here he has a bunch of posts. What we're going to do is we're going to provide some of these text posts to ChatGPT and make ChatGPT read through all of those posts and then write an email on a certain topic. Let's see how that will look like. Now, in reality, the more posts we provide, the better. But what we're going to do in this lecture is we're just going to provide one single post and see how well ChatGPT does. So let's scroll for a post that has a bunch of text in it. Let's try this one. If I click on see more, this post right here has 3 paragraphs. If I copy all of it and go back to ChatGPT, what I can do is I can tell ChatGPT this: write me an email to an employee that needs to let all employees know about new software that they should download from the email attachments. So let's just type from the attachments and do it in my style of writing. Take my style from this post. And here we're going to add quotes and paste the entire post that we took from Luca's LinkedIn profile. Let's see how well it does. Awesome, we got an output back. We got this email template that ChatGPT gave us based on this provided text, and it also did the subject that we told it to write. Exciting new software for our team. Now you can already see some of the similarities, such as, for example, Luca used this emoji in his post, and we can see it right here in the email. The post itself probably mimics this way of writing in one way or another. Now it is important to know that we just provided one text. The more text you provide, the more accurate ChatGPT will be in mimicking someone else's style of writing. You can already see how this can be dangerous. You can write in anyone's style just by providing some text samples from that person. And this is something that can be both a good and a bad thing. We can see how this can be used in social engineering attacks to make them more believable. Nonetheless, I just wanted to quickly show you this. Give it a try if you want, see how it works for you. Copy some of your emails or a different post from a social media account and see whether ChatGPT will be able to write in your style. Thank you for watching, and I will see you in the next lecture. The reality is that phishing attacks and social engineering attacks are going nowhere, as they are here to stay for a long time. That is why it is important that everyone is familiar with basic detection methods and ways as to how you can figure out when a phishing attack is taking place. Now, whether the phishing attack is in the form of a voice call, an email, or a video makes little difference, since all of them will at the end ask you for either some type of important information, or they will ask you to download some file from the attachments and run it. So let us list out some of the steps that you can take to check whether you are being phished or not. One of the things that you can do is first check the sender's email. You can look closely at the sender's email address. Phishers often use email addresses that resemble legitimate ones but have slight variations or misspellings. Misspelling in the email address itself is usually a dead giveaway that it is a phishing attack taking place. Also, if you receive an unexpected email asking for sensitive information, be wary. Legitimate organizations usually don't request personal or financial information via email. Another small but important thing that you should keep an eye on is that phishing emails often use generic solutions like "Dear Customer" instead of addressing you by name. Legitimate organizations typically personalize their emails. I have seen this mostly in PayPal phishing attacks, since PayPal, for example, greets you with your real name, but the phishing emails that appear to come from PayPal will write something along the lines of "Dear Customer," since their phishing attacks are most likely widely spammed to hundreds of other emails as well. More things to do with phishing emails is to always check for any suspicious links. You can hover your mouse over any links in the email to see where they will lead. Be cautious if the link URL doesn't match the legitimate's website domain, as this is another dead giveaway that a phishing website is being used. For example, you might get an email that appears to be coming from PayPal customer support that leads to a link to a page that looks exactly like PayPal, but upon link inspection, you might see that the domain is not paypal.com, but rather paypal.com with 2 L's. This would be enough to know that it is a phishing email. Also, if the email has too good to be true offers, you should always be skeptical. Phishing emails may promise unbelievable deals or prizes to lure you in. If it sounds too good to be true, it probably is. But this is not always the case. So to check this, it is best to contact the organization using official contact information to verify the request's legitimacy. Another important thing is to not open the attachment files unless you're certain that it comes from a legitimate source. Attachment files could contain malware that could, for example, open a backdoor on your system and allow the attacker access to your PC and all of your data. These would be some of the basic steps of finding out whether a phishing attack is taking place. But when it comes to AI phishing attacks, there are several other methods which you can consider. These would include things like analyzing message style and grammar. AI-generated messages may have more consistent grammar and writing style compared to human-written messages, which means they will lack typical errors. However, this isn't always the case, as some AI can replicate human-like writing. Also be wary of unusually fast responses. AI can respond almost instantaneously, unlike humans who typically take some time to compose messages. If you receive extremely fast response, it could be a sign of AI involvement. Also verify the identity of the sender, as AI phishing attacks often impersonate trusted individuals or organizations. Always verify the identity of the sender through a different trusted channel, such as, for example, through a phone number or from the official website. And also examine the level of personalization, as phishing AI may use limited personal information. However, it might not be as effective in mimicking someone's writing style or personal history as a human would be. You should also be cautious of something called hyper-personalization. While some AI-generated messages lack personalization, others might overdo it. Be skeptical if the message is overly flattering or appears too tailored to your preferences. Alright, now some of the technical ways that you can use to prevent phishing attacks from working are enabling email filtering and using antivirus and anti-phishing software to automatically detect and block phishing attempts. Same goes for AI phishing. Some cybersecurity tools and email services offer AI-based phishing detection. These tools can help identify AI-generated phishing attempts. And lastly, remember that the most important thing is to educate yourself on these attacks, same way we did in this section. This should be done regularly, as continuous education is essential to recognizing evolving attacks. Alright, now that would be about it for this section, and later throughout the course we will actually dive deeper into email filtering, into phishing attacks, and into social engineering itself. Thank you for watching this lecture, and I will see you in the next one. Alright, let's talk about AI-based SIEM systems. But before we mention some, let's first discuss what even is a SIEM system. We can say that a SIEM, which stands for Security Information and Event Management System, is a comprehensive cybersecurity solution designed to provide real-time monitoring, analysis, and management of security events within an organization's IT infrastructure. SIEM systems are critical tools for improving an organization's security posture and enhancing its ability to detect and respond to security threats and incidents. Implementing a SIEM system is a significant undertaking and typically requires a dedicated team of cybersecurity professionals to configure, monitor, and respond to alerts. It is an essential component of an organization's cybersecurity strategy. Now, some of the things that SIEM systems are responsible for include, let's say, data collection. SIEM systems collect vast amounts of security-related data from various sources within the IT environment, such as network devices, servers, operating systems, applications, and security tools. This data can include log files, event data, and other relevant information. SIEM systems can also provide real-time monitoring and alerting capabilities. For example, security analysts can configure the system to trigger alerts when specific predefined conditions or patterns are detected. These alerts can be based on known attack signatures, or they can be simply just deviations from established baselines. Another use case of SIEM systems is data analysis and reporting. SIEM systems analyze the correlated data to generate reports and visual dashboards that provide insights into organizations' security posture. These reports can help security teams identify vulnerabilities, incidents, or compliance issues. Let's also not forget incident management. These systems facilitate the management of security incidents by providing workflows and tools for incident detection, investigation, and response. They can help streamline the incident response process. And last, let's mention log management, which is another thing that we can use SIEM systems for, as they include log management capabilities, which allows companies to store, analyze, and manage log data. Some SIEM systems also incorporate UEBA to monitor user and entity behavior, identifying deviations from normal behavior patterns. This helps in detecting insider threats and compromised accounts. Alright, these are some of the things that SIEM systems are responsible for. And we know the traditional SIEM systems have long been used in cybersecurity for all the previously mentioned things, but now that artificial intelligence is taking place, we are also introduced with AI-based SIEM systems. AI-based SIEM is an advanced form of security information and event management that uses the capabilities of artificial intelligence and machine learning to solve many of the challenges that traditional SIEM systems had, and also to do previously mentioned tasks more efficiently. Some of the things that AI-driven SIEM systems have as components are machine learning and pattern recognition. Machine learning and pattern recognition empower SIEM to gain insights from historical security data and patterns, which simply allows it to identify irregularities and possible security risks that conventional SIEM systems, which solely relied on signatures and log source criticalities, could overlook. Now, other things that AI-driven SIEM systems have are automated incident response, predictive analytics, and overall automated functions. Some other benefits of using AI-driven SIEM system compared to the traditional one would include, as we mentioned, automated detection, which means that these systems can automatically detect and respond to threats by recognizing patterns and anomalies, reducing the reliance on manual intervention. We have real-time insights, as these SIEM systems provide more real-time insights and can swiftly adapt to new attack vectors without requiring frequent rule updates. And reducing false positives, which happens with the help of advanced analytics, as AI-based SIEMs tend to produce fewer false positives, making it easier for security teams to just focus on genuine threats. And let's finish off this lecture by mentioning some of the examples of AI-driven SIEM systems, which are Microsoft Azure Sentinel. This is a cloud-native SIEM that provides intelligent security analytics for the entire enterprise, and it's also powered by artificial intelligence. We also have Fortinet's FortiSIEM, which protects against both known and unknown threats. It is combined with the latest AI-driven behavior anomaly detection capabilities, such as user and entity behavior analysis. And for the end, let's mention Darktrace, which is an AI-powered cybersecurity platform that utilizes machine learning and AI algorithms to detect and respond to cyber threats in real time. So you get the point. AI-based SIEM system is definitely better than traditional one, but it still has a lot of developing to go through. Nonetheless, let's not make this lecture any longer, and let's go straight into the next lecture. In the last lecture, we talked about traditional SIEM systems as well as AI-driven SIEM systems, and we mentioned what were the differences and what are the benefits of using the AI-driven SIEM systems. And now, let us do the same just for firewalls. First of all, what are firewalls? Firewalls are network security devices or software applications designed to monitor and control incoming and outgoing network traffic based on predefined security rules. They act as a barrier between a trusted internal network and untrusted external networks to protect against unauthorized access, cyber attacks, and the spread of malware. Firewalls are considered a fundamental component of network security and play a critical role in safeguarding digital assets. There are several different types of firewalls which you might encounter. These include host-based firewalls, and host-based firewalls are simply just firewalls located on an endpoint device and are usually built into the operating system. They are used to set rules for traffic for that endpoint device. An example of host-based firewall would be Windows host-based firewall. Now, besides just host-based firewalls, we also have network-based firewalls. This is typically a hardware device on the network that is used to filter the network's traffic. Now, these two are the main division of firewalls, but there are other types of firewalls which you might encounter, such as new generation firewalls, web application firewalls, and unified threat management firewalls, and so on and so on. But what interests us the most are not the firewall types, but rather what are the differences between traditional firewalls and AI-driven firewalls. Well, first, let's mention some characteristics of traditional firewalls. Traditional firewalls have limited intelligence. They lack the advanced intelligence and learning capabilities of AI-driven firewalls. They cannot adapt to evolving threats or detect anomalies without explicit rules. Also, traditional firewalls use rule-based or static policies to filter network traffic. These rules are typically defined by network administrators and are based on criteria like IP addresses, port numbers, and protocols. Administrators must manually configure and maintain these rule sets. And of course, this process requires a deep understanding of network traffic and security requirements, making it resource-intensive and potentially error-prone. Firewalls are also used for packet filtering. They primarily use packet filtering techniques to inspect and control traffic. This approach examines individual packets without considering the state or context of the connection. Now, here we can talk about another division of firewalls, which you might also encounter, and those are stateful and stateless firewalls. Stateful firewalls actually monitor and keep track of state of the active network connections, as well as analyze incoming traffic and look for potential risks, while stateless firewall just determines whether a packet should be allowed or denied based on the rules that are set. It doesn't keep track of the active network connections, and it doesn't perform deep packet inspection. But we can say with certainty that AI-driven firewalls solve many of the traditional firewall issues. AI-driven firewalls are dynamic and adaptive. This means they leverage artificial intelligence and machine learning to adapt and respond dynamically to emerging threats and evolving network behavior. Another very useful thing that AI firewalls can do is perform automatic learning. AI-driven firewalls learn from historical data and can continuously update their threat intelligence, reducing the need for manual rule updates. They also have better protection against unknown threats, which means they are especially good at protecting against zero-day attacks, as they don't rely solely on predefined signatures or rules. Another good thing about them is that they have enhanced real-time protection. They offer real-time threat detection and response, often without requiring any human intervention, which is crucial in the face of rapidly evolving threats. Now, unlike many basic traditional firewalls, AI-driven firewalls are also context-aware. These firewalls offer enhanced context awareness, considering the entire communication session and the content of the data being transferred. This enables them to make more informed decisions about network traffic. In summary, AI-driven firewalls offer a more proactive and intelligent approach to network security, providing better protection against emerging threats and reducing the need for manual rule management. Traditional firewalls, while still widely used, may struggle to keep up with the rapidly changing threat landscape without continuous human intervention and rule updates. This refers to next-generation firewalls as well. Now, next-generation firewalls struggles with rapidly mutating threats, it stumbles in extensive attacks, and also its maintenance is quite stressful. And in today's age, next-generation firewalls are severely challenged by increasingly complex security situations, while AI brings new opportunities for enterprise firewalls. This means that next-generation firewalls should embrace AI and evolve into the artificial intelligence firewalls. Email filtering is an important part of any organization's cybersecurity strategy. You might be asking why? Well, if you remember, the number one threat online are still phishing attacks. And phishing attacks are mostly being done over emails. But how does AI work with email filtering exactly? And how does it filter out spam emails or phishing emails? Well, it looks for emails that signal red flags such as malicious IP addresses and URLs, suspicious keywords, distrustful attachments or embedded content, inconsistent grammar, syntax and spelling, such as, for example, using symbols and numbers as letters, and excessive use of special characters or emojis. These red flags could trigger the algorithm to move the email into spam. Now keep in mind that not every algorithm is the same, so what might be a red flag for one algorithm might not be a red flag for another. In general, AI email filtering performs several functions, which are spam detection, phishing detection, malware detection, categorization and prioritization, and content analysis, as well as adaptive learning. To be able to do all of this, it leverages several AI filtering algorithms to execute precise judgments. These filtering algorithms include similarity-based algorithm, in which filters compare incoming emails with pre-existing emails stored in servers. We also have sample-based algorithm, which uses templates of legitimate and non-legitimate spam emails that allows AI to assess new emails based on those templates. And we have the adaptive algorithm, and this algorithm reacts over time to adjust data categories. It separates emails in different categories and compares potential spam against these more specialized categories. Alright, now it is also important to understand the act of filtering with AI presents certain risks, as AI may misclassify secure emails as unsafe or vice versa. For instance, malicious spam or phishing emails often go to great lengths to imitate or exploit the appearance of trustworthy and familiar email sources, and that is why it is possible for well-crafted emails to bypass the email filter. Now, it's also important to note that false negatives are much more dangerous than false positives. This is simply because when there is a false positive, this means there is a legitimate email that was flagged as spam or phishing. But when there is a false negative, this means that there was a phishing email which was flagged as legitimate email and it was led through the filter. You can see why this is more dangerous. Also, while some AI-driven spam filters can alert recipients when they block a potential threat, the future will likely involve AI collaborating with human analysts to gain additional insights. In the context of spam filtering, it may be necessary to establish guidelines that enable AI to question its own decisions. Currently, AI systems might validate an email that appears to originate from a legitimate source, but is in fact spam sent from a hacker's highly trained algorithm. Over time, AI-powered spam filters may become more finely tuned to detect nonsense, thereby reducing false positives and identifying cases where hackers employ social engineering techniques in their spam distribution. To address these issues, it's essential to strike a balance between security and usability when configuring AI email filters. Make sure to regularly review and fine-tune the system and allow users to provide feedback on misclassified emails, as well as ensure that there is a process for handling false positives and negatives. Additionally, combining AI filtering with other security measures like user awareness training can help mitigate some of these challenges. Alright, we will talk more about spam filters and email filters in one of the future sections, and we will actually even have a coding project where we will see how to practically apply artificial intelligence into spam filtering. Nonetheless, let's not make this any longer and let's move on to the next lecture. Identity and access management is a big topic, and along with the AI, there are two rapidly growing fields that are transforming the way organizations make their IT environments. But as usual, before we talk about AI implementation in identity and access management, let us first define what that really is. Identity and access management is a set of processes and technologies used to manage user identities and control access to IT resources within an organization. IAM systems help ensure that users have the appropriate level of access to the right resources at the right time, while also maintaining security, compliance, and auditability. By this definition, we can all agree that identity and access management is quite important, especially in bigger organizations. It determines who will have access to certain assets, and by doing that, it keeps a level of security from unauthorized access. However, this task is not that easy, especially with the increasing complexity of IT environments. This is why IAM systems are facing new challenges in terms of scalability, performance, and security. Luckily, AI is here to help and take identity and access management to the next level. So where exactly is AI being used with identity and access management? Well, there are several use cases. Let's list them out. We have user authentication, which can be applied in biometric authentication, as AI enables biometric authentication methods such as facial recognition, fingerprint scanning, and voice recognition. These methods offer a high level of security and convenience. Instead of identifying access based on a password or PIN code, which can be discovered by a security breach or which can be rather weak, we can use facial recognition and fingerprint scanning, which is unique for each person, so that only the person that we want to have access to certain asset or data can access that data. We also have behavioral analytics, so user behavior analysis is when AI algorithms analyze user behavior patterns to detect anomalies. If someone's behavior deviates significantly from their typical patterns, it can trigger alerts for potential security threats. This is much more efficient when done with AI, as artificial intelligence can learn others' behavior much faster than a person would, as well as it can detect much faster if someone's behavior changes. Let's not forget risk-based access control. AI can assess the risk associated with specific access requests. It considers various factors such as the user's location, device, time, and historical behavior in order to grant or deny access to that user. You know that time when you try to log into your account and you're required to input some additional information or additional digit code because you're logging in from a different location or from a different device. Well, AI can be used in this type of risk assessment where it will try to determine the likelihood of that being you or someone else who possibly stole your account credentials and now is trying to log in. This is why AI can be used in multi-factor authentication as well. AI can assist in implementing adaptive multi-factor authentication where the authentication methods required may change based on the perceived risk level. And lastly, let's mention password management, since AI can be used in password strength analysis by evaluating the strength of passwords and enforcing strong password policies. This includes password reset assistance, as we can use AI-driven chatbots which can assist users in resetting forgotten passwords securely. Now, these are just some of the things that AI can improve and make more fast and more efficient compared to traditional ways of how these things were done. Of course, this is nowhere near to being perfect yet, and there are potential issues or security risks with AI implementation in identity and access management. These risks would include false positives, false negatives, privacy concerns, and security vulnerabilities. AI itself can become a target for malicious actors. For example, if an attacker gains control over AI system in identity and access management, they can manipulate the access control or carry out more sophisticated attacks. They could potentially grant access to everyone to a specific asset like a server. The risks also include ethical concerns, as the use of AI in identity and access management can raise ethical questions, especially regarding the balance between security and user privacy. Decisions made by AI algorithms may not always align with the organization's ethical standards. And there are always the training and maintenance costs. Developing, training, and maintaining AI-based identity and access management systems can be costly and resource-intensive, especially for smaller organizations. Now, to conclude, incorporating AI into IAM systems can significantly enhance security and user experience. However, it's important to deploy AI in identity and access management thoughtfully with attention to privacy, data security, and potential biases in AI algorithms. Now, data bias in AI algorithms is something that we will talk about later in the course. Alright, now that we got that out of the way, we got one more topic to talk about inside of this section, and that would be AI usage in intrusion detection and intrusion prevention systems. Alright, one final thing to talk about when it comes to cybersecurity tools and their AI implementations. We got IDS and IPS. These are pretty important in secure network environments, so let us first define what they are. IDS stands for Intrusion Detection System. IDS is a monitoring solution for detecting cybersecurity threats to an organization. If a potential intrusion is detected, the IDS generates an alert that notifies security personnel to investigate the incident and take immediate action. Now, when it comes to IDS, we have two main types. We have HIDS and NIDS. HIDS stands for Host Intrusion Detection System, and it is only used to detect potential threats and security risks on an endpoint device or a host, while NIDS stands for Network Intrusion Detection System, and it is set at the network level, allowing it to identify threats on the entire network. IPS, on the other hand, stands for Intrusion Prevention System. It is an active protection system. Now, like the IDS, it attempts to identify potential threats based upon monitoring features of a protected host or network and can use signature, anomaly, or hybrid detection methods. However, unlike an IDS, an IPS takes action to block or remediate an identified threat. While an IPS may raise an alert, it also helps to prevent the intrusion from occurring. So now that we know what they are, how exactly does AI make IDS or IPS better? Or even better question would be, does it make it better at all? Well, same as with other tools, AI can help in certain complex processes and make them more fast and efficient. For example, combining IDS and AI for autonomous systems offers a wide range of benefits. By monitoring, detecting, and responding to malicious activity, autonomous systems leverage the power of machine learning and AI to improve network security. With AI-enhanced IDS, you can quickly detect suspicious activity and respond with analytics-driven insights that help you automate your security processes. Moreover, autonomous systems provide faster incident response times since they are able to process data more rapidly than by using manual methods. This minimizes the risk of breach exposure by detecting threats earlier and responding more quickly than ever before. Not only does this ensure more secure systems, but it also reduces operational costs as there is less manual work involved in handling incidents. Some other reasons AI makes IDS and IPS better include things like anomaly detection, where AI-powered IDS/IPS can analyze network traffic and user behavior to establish a baseline. When deviations from this baseline occur, it can trigger alerts or take actions to mitigate potential intrusions. We also have real-time threat detection, as AI systems can analyze data in real time, allowing for rapid detection of emerging threats that traditional signature-based methods might miss. Another good use case is in reducing false positives, since machine learning can help reduce the number of false alarms by understanding the context of network events and distinguishing between benign and malicious activities. However, this depends on how the model was trained. If the model is not trained properly or on the correct data, it can actually have the opposite effect of increasing the number of false positives. Now, AI can also have automated responses for IPS, so for intrusion prevention systems, AI can be used to not only detect intrusions but also take automated actions to block or isolate malicious activity, preventing any further damage. And lastly, we have zero-day attack detection. AI can identify zero-day attacks by recognizing previously unknown attack patterns based on behavior analysis and threat intelligence. Zero-day attack is an attack that exploits a previously unknown hardware, firmware, or software vulnerability. AI is particularly well suited for this task due to its ability to analyze behavior and patterns in data, making it capable of identifying previously unknown attack techniques. But, of course, as with other security tools that we talked about, there are the bad sides of AI implementation, which for IDS and IPS would include, once again, false positives and false negatives. AI-based IDS and IPS may produce false positives, triggering alerts for benign activities, or they can also produce false negatives, which is failing to detect real threats. That's why over-reliance on AI for decision-making can lead to security gaps or unnecessary disruptions. We have adversarial attacks, which are used by sophisticated attackers that deliberately craft attacks to evade AI detection by identifying and exploiting vulnerabilities or weaknesses in the AI models. Data privacy concerns is another big topic, as implementing AI in IDS and IPS may require the analysis of sensitive network and user data, which then raises privacy concerns and potential legal and compliance issues. Nobody wants their own data being accessed by someone else, not even the AI tool, especially not wanting AI to disclose some private information or data which shouldn't be known by someone else. And remember, in the last lecture we mentioned data bias as one of the problems or weaknesses that could occur with machine learning and artificial intelligence, as AI models are only as good as the data that they are trained on. Biased training data can lead to biased or inaccurate threat detection, disproportionately impacting certain groups or types of threats. This could end up making IDS and IPS detect everything but the things that they actually need to detect, which is malicious software or cyber attacks. This is why implementing the model must be done carefully and must be tested multiple times before it actually starts being used. And there is one more security risk which can be applied to all the security tools that use AI, which is limited human oversight. Over-reliance on AI might reduce the level of human involvement in security decision-making, which can be risky, as human judgment and context are often essential in complex security incidents. Alright, these would be some of the risks, and in order to mitigate these risks, organizations should implement AI in IDS and IPS systems thoughtfully. This means conduct regular audits and combine AI-based threat detection with other security measures to create a defense in-depth strategy. Training and educating security personnel about the capabilities and limitations of AI-based systems are also crucial for effective and responsible use of AI in security. Remember when we talked about email filtering with artificial intelligence? We touched on some important aspects of email filtering, the reasons why it's important, and how artificial intelligence affects email filtering and spamming. Now, let's go over some traditional email filtering methods and use cases before we get into coding our own email filtering program that integrates artificial intelligence. In today's digital age, email has become a primary mode of communication for both individuals and organizations. With its extensive use, email systems have also become a lucrative target for cybercriminals. This lecture will refresh what we already mentioned, and it will introduce new concepts to you of email security and filtering, shedding light on its significance, challenges, and the role of artificial intelligence in email filtering security measures. Let's kick it off with importance of email security. Now, probably on the number one spot of importance for email security is data protection. Emails often carry sensitive data, whether personal or professional. Protecting this data from unauthorized access is necessary to maintaining privacy and complying with regulatory standards like GDPR. On the second spot, we have preventing phishing and fraud. Now, phishing attacks often start with a deceptive email, tricking the recipient into revealing credentials or clicking on malicious links. In 2019, the FBI reported that business email compromise schemes resulted in losses over $1.7 billion. Other than that, email filtering and security is important for malware and ransomware prevention. Malicious software can be distributed via email attachments or links. Once they are opened, malware can do anything from encrypting your files and demanding a ransom for decrypting them, to running a keylogger in your background and stealing some important credentials. And lastly, we have the brand protection. Companies can suffer reputational damage if their email systems are hijacked for spam or phishing campaigns. Okay, so that would be the importance of email filtering. But we really want to understand email filtering on a deeper level. We know that email filtering is a crucial component of email security, and here is how it operates. First of all, let's talk about spam detection. Now, in spam detection, filtering systems identify and quarantine spam emails based on various attributes like sender reputation, email content, and user feedback. For example, Google's Gmail uses an array of techniques, including AI, to filter out spam with a reported accuracy of over 99.9%. We also mentioned malware scanning to be an important part of email security, and in order for this to work, email attachments and links are scanned for known malicious signatures or suspicious behavior. Many organizations employ dedicated email security gateways to scan for malware. Same goes for phishing protection, where advanced filtering can identify phishing attempts by analyzing email content for deceptive language, impersonation, or malicious URLs. For example, Microsoft's Office Advanced Threat Protection employs machine learning to analyze emails for phishing characteristics. And let's not forget content filtering. This measure allows or blocks emails based on a predefined policies regarding sensitive information or inappropriate content. For example, a financial institution might use content filtering to prevent accidental sharing of customer data. And let's also mention behavior analysis. Now, behavior analysis can, for example, refer to analyzing historical email data to identify abnormal sending patterns which could indicate a compromised account. An example of this would be Agari's behavioral trust platform, which uses AI to build communication profiles and detect anomalies. And last thing that we want to mention, which we already talked about before, but let's give a quick recap of it, which is the role of AI in email security. So on the number one spot, we have enhanced spam detection. AI algorithms learn from vast datasets to identify subtle patterns indicative of spam or phishing. Malware identification is something we already mentioned. Machine learning can identify zero-day threats by analyzing file behaviors rather than relying on signatures. Also, natural language processing can help in identifying deceptive language or impersonation attempts, or otherwise known as phishing attacks. And predictive analysis is another important aspect of AI in email security, since AI can predict potential threats by analyzing trends and proactively adjusting filtering criteria. Alright, so by employing artificial intelligence, the domain of email security and filtering is continuously evolving, making strides towards creating a safer digital communication environment. Now, in the next lectures, we'll delve deeper into the technical aspects of building an AI-driven email filtering system, starting with understanding spam filters and their operation in the next lecture. See you there. Alright, let's dive a little bit deeper into spam filters. Spam filters play a vital role in maintaining the hygiene of our email inboxes by going through incoming messages and filtering out unwanted or harmful emails, often referred to as spam. The effectiveness of spam filters is crucial for individuals' and organizations' productivity and security. This lecture will break down the mechanics of spam filters, the techniques employed, and the challenges faced in spam filtering. Let's start with definition of spam. Spam refers to unsolicited messages sent in bulk via email. These messages often contain advertisements, phishing scams, or malware. The objective of spam varies from advertising to malicious intent like fraud or distributing malware. The mechanics of spam filters work through a set of rules and heuristics to determine whether an email is spam or legitimate. Now, here's a simple overview of how they work. First of all, spam filters scrutinize the email header for anomalies or suspicious elements such as a forged sender's address or misleading subject line. They also perform content analysis, since the content of email is being analyzed for known spam characteristics. This can include scanning for certain keywords, phrases, or patterns that are commonly associated with spam. We also have blacklist and whitelist checking, so filters usually check the sender's IP address or domain against a blacklist of known spammers or whitelist of approved senders. So usually it's either just using blacklist or whitelist, and it depends from organization to organization. Definitely the more secure one is whitelist, because then you have a simple list of all the allowed senders and everything else will be blocked. Next up, we have Bayesian filtering, which utilizes the principles of probability to analyze the frequency of words and phrases, comparing these frequencies to those found in spam and legitimate emails. We also already mentioned that machine learning is being used to learn from previously identified spam and legitimate emails in order to improve detection accuracy over time. But we already mentioned that, so we're not going to dive into this right now. And last thing we want to talk about is spam trap and honeypot networks. This refers to networks of email addresses and systems that are designed to attract and identify spam, which then feeds this data into the spam filtering system. Now, some of the techniques that are employed in spam filtering are rule-based filtering, which are simply just sets of predefined rules or heuristics that are used to identify spam based on known characteristics. We also have statistical analysis, which is basically using mathematical models like Bayesian filtering to statistically analyze the likelihood of an email being spam. Machine learning and AI, we already went over this. We have real-time black hole lists, or RBLs, which utilizes real-time databases of known spam sources to block or flag emails. We have fingerprinting and checksum techniques, which are used to identify unique fingerprints or checksums of known spam messages to quickly filter them out. And lastly, we have graylisting. Graylisting temporarily rejects emails from unknown senders, asking the sending server to try again later. And the point of this is that spammers typically don't retry, therefore the email never gets resent. But it's also important that we touch on some challenges in spam filtering. And trust me, there are quite a lot of challenges. The number one is probably false positives and negatives. We need to strike the right balance to minimize both false positives and false negatives. And just for a quick recap, false positives are legitimate emails marked as spam, and false negatives are spam emails making it to the inbox without getting detected. We should also regularly evolve our spam tactics, since spammers constantly evolve their tactics to bypass our filters, which then results in us needing to continually update our filtering mechanisms. Resource consumption is another problem of spam filtering, as processing vast volumes of spam can consume substantial computational and network resources. And lastly, we have privacy concerns. Spam filtering can raise privacy concerns, particularly when analyzing email content, because nobody wants their emails to be read. Okay, now spam filtering is still an ongoing battle, with both spammers and spam filter developers continually evolving their tactics. In the next lecture, we'll delve into a real-world dataset analysis to further understand the nuances of spam and how machine learning can aid in the identification and filtering of spam emails.
For the technical part of the course, meaning when we implement some code, we'll be using an IDE, meaning environment for coding, called Google Colab. If you never used Google Colab before, please check out this tutorial. But if you had, make sure to proceed to the next lecture, because this is for people who never used one. Okay, to properly use Google Colab, you will need your Gmail account. You can create one for free if you never had one. Go to the link in the resources of this lecture to end up to the place that looks similar to this one. Now, you won't have these files exactly as I have, because these are files that I created in the past. So this is a history that showcases only your own work. When you select a file or create a new one, you will end up to the place that looks something like this. It will have some title, or untitled in my case. Let me rename to test, env Google Colab. And this will be just a name of a file. Now, what is a Google Colab? Google Colab is an environment that allows us to code Python, in this case, directly from cloud, from browser, without installing any libraries or any programming language locally on our computer. And we are using this environment so anybody in the course could have the same opportunity for learning. And you can open this file or this editor on your tablet, on computer, desktop, old laptop, even a mobile phone, and you can code on the go. Now, it's not the most pleasant experience, but I tried, it actually works. When you create a new environment, it will look like this. It is consisting of cells, as you can see here, a cell, and you can write some code in it. For example, a equal 10, or let's say 42, because that's the answer to everything. And you can execute on Shift Enter, or you can execute on just this play button. For the first time when you load this file, it will take some time because it is connecting. So where it's connecting? Well, it's creating a virtual machine for you, for your coding experience directly on Google servers. So you can execute directly using their RAM and their disk. How amazing is that? So it's creating the fully functional computer somewhere in the cloud for you, so you can write code. Now you can even upload your own files right here, like a dataset that we're going to do throughout the course. But you will see that sometimes, or always, when you upload a file, it will be removed once you close this session, or just stop it. You can create virtual environments or secret and variables and stuff like that. Now, there is a lot of things that you can actually work and inspect the whole code. Amazing IDE for starting and learning Python and coding your first version of the software. Okay, so I'm not using it entirely for private code. So IP definitely put it on my computer. I'm not using Google Colab for that, just in case. I never heard any case where Google actually stole the code, but better prevent than cry. The other thing that I would like to show is this edit right here. So you can do all sorts of stuff right now. Now, there is a notebook settings. We won't use these notebook settings for the whole course, but if you need in the future to change Python version to R, for example, and code in R, or if you need some hardware accelerator, meaning GPU, for example, you can choose the GPU from here. If you are using the free version, you will be able to choose T4 GPU for free. These two are unlocked if you're using the Pro. You don't have to pay, it's $10 per month, but you really don't have to pay. I just experimented and that's it. That's why. Now that we have that out of the way, let's explore a bit of a code. So code is a weird thing right here. So for example, these cells are not in the order. So if I just execute and say, hey, A is print A, and then execute and say A is equal to 515, and then go back to print A, even though it's above, it's 515. So it's not the order of cells, but the order of execution. So this is 1, 3, and 4. So if you make a mistake down the line when we code, make sure to test the runtime, restart everything, restart session, and start from the top to the bottom. Because sometimes it will remember some state, cache, some variable that you potentially removed, and it will still be there. For example, I removed A's, but if I print out, even though there is no A, it's still there. So it's quite a weird interface, but it's online and easy to set up. Okay, so that's it for introduction. It's enough for now. Make sure to create your own Gmail account for free if you want to follow along with this environment and not install anything locally. Okay, see you next video. Throughout the course, we will create some kind of a workbooks that you can create a copy of and start coding along. But make sure to create a copy and not change the original one because you won't be able to save your work. And imagine when you come back a couple of days ahead and you don't see your progress. It's not really a pleasant experience. So I don't want that to happen to you. So let me show you how to do that from our workbook example for section 8. So this is a workbook for malware detection system, and you can find it in section 8 of this course. When you go to the file, you can start here and save a copy in a drive. It will open this, creating a copy, it will open exactly the same version of this that is directly open for you, copy of your workbook malware detection. And now whatever you change will be preserved and saved in your version of the code. So if I go here, you won't see any difference because it never executed in the original workbook that we shared with you. So make sure that you are creating a copy to your drive and then change the copy and not the original one, so you will have all the code preserved for later reuse when needed. And that's it. Happy learning. See you in the next video. Hello everyone, and welcome to the section 5 of the course. In this section, we're going to build something called email spam detection. If you use the Gmail or Office Outlook mail, you might notice that they are using something called spam detection or spam filter, which basically means that any mail that comes your way to your inbox, before you can see it, it will go and be checked by some set of rules. And those rules will check the substance of the mail, the sender, and potentially the receiver end as well. And all together will be flagged either as a normal mail or as a spam. And if you go to your Gmail account, you will see the spam folder where the mails that are not passing those filters are ending up. And in most cases, those are kind of a harmful mails. So if somebody wants to sell you something that you don't really want, or a sender that you ignored for quite some time might go directly to that folder right now. So all of that is considered as spam. So you want to build a system so your users or yourself using that email want to see only useful data. Okay, so for this task, we're going to use something called machine learning or AI, and we're going to learn together on how to work with data set consisting of spam or no spam emails, and how to put all together in a project in this workbook right now to build that system and potentially deploy it to your own email provider. Okay, so to start working, you will have this workbook directly linked to the resources of this very lesson. So please check out the resources of this lesson to download or click a copy, create a copy of this very notebook to start working on your end. Okay, so let's start building this from the next video. See you there. Let's start working on building our email spam detection system. Once you open the notebook that you can find in the resources of the first lecture of this section, you will see the first cell, code cell, has some libraries associated with it. These libraries might not be familiar to you, so let's explore each of them and see what they do. So NumPy library stands for numerical Python, and it allows us to do multiplication and computation on multiple arrays of data. So if you want to perform some bigger computation on top of your data, it can be a few points or whole data set, the NumPy library is there for us. And we're gonna do just that, to perform some analysis of data, some computation on top of it, to get the best outputs and inputs actually to our model. On the other hand, we need to load the data into our program. And for that, we have pandas dataset. After that, you have a seaborn and matplotlib. These two libraries are there to visualize some data points. You might use them to visualize all the data points in your dataset or just something that you really need. Whenever we work on AI project or machine learning project, whatever you want to call it, you need some form of a data set. Now, the data set might be created by you and your company, or you can find it online, which we're going to do today. And you can use it to experiment, build a project out of it as a kind of a demo or a prototype. And then you can demo your data against that prototype to collect more and more real-world data to scale your machine learning system that was trained on kind of a toy data set. Now, there is an amazing website called kaggle.com. And this website allows us, data scientists, machine learning engineers, or just practitioners from other industries such as cybersecurity, to find a data set, data points, to perform their analysis on. And if you go to the link right here from your workbooks, or from the resources of this lesson, you will end up to the page that looks like this. And this is just a part of a Kaggle website. As I said, Kaggle website is really famous for the number of data sets and competitions it hosts every day. So when you want to practice and learn more about algorithms and how to process and get value from the data set, you can go to Kaggle, potentially find the most similar data set to yours, and start exploring it. See how other people actually use this data set to get their result up and running. Now, for this very section, we're going to use something called spamhamdataset.csv, which is only 5.5 megabytes. And when you go to the link that you can find in the resources of this lesson or in the workbook that we provide for you, you will be able to download this file directly from Kaggle. But you need to be signed in. And if you don't want to log in and get this dataset yourselves, you can download directly from the resources of this lesson as well. So don't worry, you don't have to create an account on a Kaggle as well. It's free completely, but if you don't want, you don't have to. When we explore this dataset, you will see some columns such as ID, label, which basically means that it's already labeled as a spam or normal, 0 or 1, and email text or email data as they call it right here. we have about 5,000 unique values or 5,000 unique emails in this case. And we need to process it in a way that we can use the substance of this mail, a text, to actually perform some analysis on top of it and get it to the algorithm, whatever algorithm you might want to use, to predict whether or not it's spam or normal email. So once you're done with downloading this CSV file directly from Kaggle or resources of this lesson, you need to upload it to your workbook. So here's how to do it. To upload this data set, you want to go to this folder-like icon right here, which will open the folder consistency or file structure in this very notebook. Right-click and click Upload. It will prompt you to select a file. So from Downloads, I have the file called spam or ham. So let me find it. Here it is. Open, and it will prompt you with a warning message. Don't worry, if you used for the first time this workbook with the file, it will prompt you with a message that once you've closed this browser and session, all uploaded files will be deleted. So since it's a kind of a session-based coding, once you are done with it, it will remove all the stateful data inside of it. So you need to reopen or re-upload certain files if you want to continue using it later on. Okay, so I'll click OK and close this left menu. Okay, now we need to execute the first cell, which provides us with all the libraries that we might be using throughout the whole section. And when you scroll down, you will see already that I provided a lot of information about this dataset. So even if you don't go to kaggle.com, you will see all the necessary data directly extracted for you. Now, I already have the pandas library imported right here. So if I want to open this file from our files, I'll just copy the name. And here I'm going to name data. And I'm going to provide pd.read CSV. So pandas has a lot of opportunities to read SQL, CSV, Excel, and so on. So whatever your data might be stored in, you can use directly that type of file to load it in pandas. So I'm going to paste the name .csv and I can execute. If there is no error, it will look like this. Now, to check if this data is correct, I'm going to add one more code block right here and type data.head. This head is a normal or a most basic function to analyze your data, which will basically visualize first 5 rows if you don't provide any argument to it. So if you want, you can provide 3. If you want to see less, 5 first rows. And as you can see here, we have some IDs which we won't use, labels, text, and label in numerical format, which is 0 or 1. Okay, and that's it. We have our data loaded, and now it's time to perform data analysis on it. So let's do that in the next couple of videos. See you there. Now that we have our data loaded, it's time to do some analysis on top of it. So it's a rule of thumb. Whenever you upload or load your data for the first time, you might not be as familiar with that data set as you might think. You don't know how many of labels or data points in each label you have. So for example, let's say you load this data set right now and you have about 5,000 examples in the whole data set, where from those 5,000 you have about 4,000 normal mails, while only 1,000 that are considered spam. It is a great data set in the sense of numbers, but if we're speaking about balance of how many representative cases you have about spam, it's not so much. So it's really important to know what data you have, what is the quality of data. So for example, if you just paste the same example of a spam email 100,000 times, it doesn't mean that you have 100,000 examples of a spam email. It's just noise because you have the same example repeating so many times over. Okay, so that's why it's really, really important to dedicate your time to analyze what you have. And as a part of data analysis, you need to process your data. And we're gonna speak about that in a second. When you go to the first cell, you will have some weird code for plotting the data, and I'm gonna walk you through this in a second. But before we do that, we have some variable called class count that is not defined, as you can see right here. So let's define it. I'm gonna copy it and paste it above. It will take our data, and from data, I'm gonna take label. So if we scroll up a bit, you will see that I'm taking this data point right here, and I'm gonna call a function on top of it called value counts. And this value counts will go to that very column, in this sense, ham or spam, and count how many times we have our spam repeating, and on the other hand, how many times we have normal emails repeating or ham. Now, once we have this, we have some plotting code. And plotting code is consistent of two libraries that we mentioned in the previous lesson, matplotlib and seaborn. The first line is plt, which is short for matplotlib.figure, which will just specify on the size of the whole visualization that we're going to do. Now, this is optional. You don't have to do it because it has some default shapes and sizes inside of the code. But if you want to override that, make it bigger or larger, you need to specify this figure configuration right here. After that, you want to specify what kind of plot you really want. Now, if you use only matplotlib, that's also the okay case, and many developers will not consider seaborn because it might be slower and sometimes an overkill. But seaborn has much better visualization options than native matplotlib. And in this case, I'm gonna call SNS, which is short for seaborn.barplot, and here X will be our class counts.index, which will be ham or spam, and Y will be how many we have of each of those. This will specify our legend or configuration of the graph, like names of axes and the whole title. And in the end, I'm gonna have this plt.show to actually show the graph. And if you execute this, you will see the graph that looks like this. And as you can see, we have almost the double in size of normal mails, ham, or spam, which is not great. So we need to consider what is the frequency of how many unique words we can recognize in each of these categories. Like, for example, hey, I'm offering you, I don't know, this amount of money, I'm Nigerian prince, and so on, which I received that email quite a few times. But yeah, this is kind of a representation of our data set. Of 5,000 examples, we have 3,500 that are considered normal, and the rest of about 1.5K or 1,500 emails that are considered spam. Okay, so in general, this is considered imbalanced data set. And now you can go and perform some kind of a processing that will take some amount of this data and remove it to have the same exact time. But before we do some rash decisions, we need to dig deeper into each of these categories and understand what is actually the structure of each of these parts of data set. So to understand that, we're going to implement a couple of functions. And in this video, we're going to implement the first one, which will take the class name and show us how many unique or most common words we have in that category. So let's implement this function. The first thing that I'm going to do, I'm going to use some other library called collections and import counter from this library. The counter will take any array or any amount of data and count how many unique values we have inside of that list. So we're going to implement a function called get most common words. The first argument will be our class label. Then number of words, or how many we want to show, and column name, just to take that from our dataset. And the last argument that I'm going to provide is dataset, which is our whole CSV file. Here, I'm going to define something called text, and this text will join the most common words. Now, this text variable will take all messages, in this case mails, from certain label, spam or normal, and join them in one big text. So here what I'm going to do is message for message in data. Now I'm going to take data of data dot column name, and here I'm going to define equal to class label. And one thing that I did here, either I'm going to provide label column name as a separate, or just assume that it's going to be label like this. And at the end, what this is going to do is this. So let me add one more cell to explore what I did right there. Here I have a data. This data is the whole data set. Now where I'm gonna filter it out is provide data of label, which will provide this as a kind of an error because it's not an index. So we need either specific index or true or false. To get true or false, I'm gonna put equal sign right here and provide ham, for example. Now this ham will take all the data points, as you can see, about 3.5 thousand, that has only label ham. After that, because it's still the whole data set, I want to take only, for example, text. So here I'm going to provide text, and this is my result. Okay, so here I'm doing exactly that. I am taking the data set, I rename it to dataset right here. Label is my label right here, equal to class label. So I want to make it a dynamic, either spam or ham, that user can provide. And what I'm gonna do is take the exact column name, as you can see right here, so we can only take messages or emails in this case and concatenate them together. So I'm iterating for each and just appending it to the end. So by this point, we have all messages as one big string. Now I need words. So I'm going to define words that's going to be equal to text.split. And here is one thing that you can do to improve this function later on. And I do encourage you to test it out yourselves. Now, here, as you can see here, it's case sensitive. So guess as a word and guess with uppercase G, it doesn't have the same context, for example, or the same structure of the word. So that would be counted as two different words. And if you don't want that, you can normalize the whole text and make it lowercase or uppercase, and then split it out. So you have all the same words in the same letter casing. Okay, so you can experiment that on your own. Now, the beginning of this function will stay the same. The rest will change depending on lower or uppercase like this. After we have the words done, we need to return counter of words. And I don't want to return like thousands of words. I want most common. So most common. And I'm going to call how many, as you can see the argument n, most common of 3 will return 3 words. I have number of words argument right here. And this is the whole function that we need to count how many unique words or most common words we have in a specific part of data set. So if I go and call this get most common words, class label is spam. I'm gonna take 20 most common words, and the target is text. At the end, I'm gonna provide data. And it will go through whole data set. And as you can see here, this is the structure that I get. Now, if you've taken the challenge that I provided, you would end up with, for example, code like lower, execute again. And if I execute this again, it will be mostly similar because the most common words are something called in English stop words. So we're going to speak about that in later video in this section on how to remove them if we need to remove them. But for now, we have the first function to analyze our data set called get most common words. Now, for your homework, go check it out, explore lower and uppercase to see if there is a difference, and call this for ham and spam. Experiment a bit and see what results you're gonna get. See you in the next video. The first step of our data analysis was to find out what are the most common words and also to find out whether or not we have the balanced data set. The last step that we're gonna do before actually doing the pre-processing stage and switching gears to machine learning and making some predictions on top of this data, I want to find out some more statistics about this data set, which might indicate whether or not we have a spam email or ham. Now, one of these indicators might be in the length of our emails. Are you considering a bit shorter email to be more spammy because it's more direct, more strong words, selling something in like a split of a second and then going away? That might be an indicator of a spam email. So sometimes before machine learning, these networks or these platforms for email processing, they provided these kind of a rule-based algorithms that were not relying and using machine learning or AI as we call it these days, which is basically here to just calibrate on how many words, repetitions and stuff like that specific email has, and if those are satisfying those rules. It will be flagged as email, as a spam email, or as a normal email. Now we're just gonna explore this and we won't build this rule-based classifier, but it's a really useful thing to know. Now, I want to take you in an adventure of getting kind of application of applying multiple functions directly to your data. And it's more advanced, a bit more advanced pandas functionality in this case. Now, if you have a string, let's say this is a spam email. When you're looking in the Python version of this string, it is kind of considered as a list of characters, THIS space and so on. So if you call the built-in function, Python function called len, it will return amount of characters or letters in this very email or a string. Now, when we speak about data in pandas data frame, we have something called apply. So I taken all the data out except text by calling just text. And what I can do is apply some change. And this apply will take a function. So it can be your custom function, or it can be a built-in function in Python directly, like len. So if I just write len, it will recognize this as a built-in function, and as you can see here, it will take the length of all strings from start to finish. How amazing is that? So of course we need to store it somewhere. So let's create a new column called text length and put it like this. If I visualize the first 5 rows right now, you will see a new column emerging at the end, which is called text length. By default, we don't have this in our data set. We just created it, and it's kind of a feature engineering way of looking at this data. We have this feature which indicates how many characters we have inside of this very email. Now, you can also go into more direct way and just measuring how many words you have, unique words inside of each mail, but basically you're communicating the same information. So now that I have this, I want to indicate on what is the average length of an email that is considered a spam or a ham or normal email. Now, to do this, I need a function called group by. I'm going to call group by, and this will take a column name, so label. And if you do this, you won't see much because it will just perform this grouping of our data. And what this will do, it will take all the data set and consider what is the mean, standard deviation, and so on by specific unique value in this column. So in this case, we have ham and spam. And I don't want all of the columns. I want just the newly created one called text length. And if I do this, not so much. To extract that information, we need to call describe. So describe will take my data and it will label it because we have unique values ham and spam. And describe is a native one to pandas, which will calculate on how many unique values or what is the mean, standard deviation, minimum value inside of every column. In this case, column will be perceived as a kind of a unique value in this group by statement. And that's why we have this ham and spam separate entries. And if we take a look here, you will see that ham has more samples, which we did know, which is count. And in a lower end, you see that spam is actually longer by average than our ham, for example. But also, on the other hand, we know that standard deviation means it's a bigger one. So it might be really short or really, really long email. And minimum length of our spam is actually shorter than the normal one. And as you can see that 25% of all the emails considered to be spam is under 283, then 50 is under almost 600, which is consistent, almost consistent across the whole page. Now, maximum value is really out there, and you can see that it is 32,000 letters or characters in the normal one, while 22,000 in the spam one. Okay, so we just learned what is the data structure email. Okay, so we learned about our data. Now it's time to actually clean our data set and prepare it for our algorithm that we're gonna use for this section. Let's do that in the next video. See you there. Whenever we use machine learning, it's really important to process or pre-process our data before putting it to the algorithm. Now, in rare cases, we're going to use the raw data as we received it from either a system or a user or other teams in an organization directly to the algorithm. In most cases, we're going to do some magic on top of it, prepare it to be more successful. Because in most cases, raw data is not that great, especially if it comes from the real world. Now, in this case, we are kind of working with really raw data, which has a lot of grammatical mistakes or errors, which is a raw text, and we can perform any mathematical operations on top of it. So machine learning basically fails. And in this video, we're gonna start working towards the way of how to put it to the algorithm so we can actually perform some predictions on top of these mails. As a first step towards working with machine learning algorithms, we're gonna remove all the words and punctuation that are not really necessary for this very task. And this is a very important lesson to be remembered when we work with any data for your machine learning or AI project. You're going to learn a lot about data processing, steps of cleaning data, removing certain points and stuff like that. But it's really per case or per task that you want to perform. Now, just take a step back. In this case, we want to predict whether or not some email is considered spam or no spam. Now, if you are given as a human this task, you're gonna check a specific words, whether or not somebody is selling you something, asking for millions of dollars directly in email, or an email address that somebody is sending you from. Even a subject line is really important. But you won't consider looking at a punctuation, for example, or like stop words such as the, your, yours, he, she, it, and stuff like that. These words, as common as they are, they're not really informative towards us humans, as well as algorithms as well, because they're really common and they can appear in any sorts of text, spam or no spam. So we want to remove it to make the task for our machine learning really easy, or not really easy, easier than it is supposed to be. So let's build it right now. I'm going to import one new library called string. Now, string will allow us to remove punctuation where we need, for example. The next library is called sklearn. sklearn is shorter for scikit-learn, and this library actually allows us to work with machine learning in basically 2 lines of code. So if you don't know the needs and greets of any machine learning process, sklearn is there to help us. So to scale data, process it, even transform it, and later import the algorithm that we want to use and make certain predictions. So here I'm going to import feature extraction, then text, and import something called English stop words. And I'm going to use this English stop words to just visualize what we're going to do. If you take a look, it's a big list of words that are really common and not really informative, like pronouns, words, verbs that are like have, I am, and stuff like that. They're not really context-based and they can appear anywhere. And we want to remove that. So to do that, we're gonna implement a function called preprocess text, which will receive text or email, whatever you name it. Then what I'm gonna do is create text to lowercase to make it easier to work with. Then I'm gonna define text.translate str make trans, and here I'm gonna do some weird syntax and explain it in a second. So string punctuation. I'm going through the whole text, making this translate function, which basically says, hey, transform this to another text that will have some changes. In this case, these changes will take any place which is a punctuation. So if you visualize this punctuation, let me do that here. So if it has any of these, it will remove it and replace it by an empty string. So basically, as it never existed there. Once we cleaned and removed all punctuations, we're gonna split our text into words. So words equal to text.split. So nothing fancy. And of course, it has a possibility to fail right now if those 2 words are not split in the right way and stuff like that. Then I'm gonna use this. So for word in words, and if word not in English stop words. So here what I'm doing is I'm going to iterate through all the words in this and check if the word is not in our English stop words. And if that's the case, so if it's a normal word, not considered a stop word, we're going to append it right now. Then what I'm going to do is text equal to join all words, return text. So let's see how this works. Let me take the text values of 1. Okay, so this is our first email. Now it has a lot of those new line characters, brackets and stuff like that. What I'm gonna do is call preprocess text and provide it right now. And here is the output. We removed all of that, removed any of these punctuation symbols, and removed the words that are not really considered favorable or informative to our algorithm. Once I have that, I'm going to apply it to all of the strings inside of our data set. And if you remember what we did in the last video, we applied a function. In this case, we're going to apply the newly customized function, this one. So here I'm going to define data cleaned text that's going to be equal to data.text apply, as we did before, but instead of using len, we're going to use this preprocessed text, which we just defined. And if I just call it, call head, just to see what we have right now, we're going to create another column called clean text. And from now on, we're going to use that column to visualize the most common words, pre-process, create information to our algorithm and stuff like that. So let me visualize this right now. And I'm going to go up, scroll up and a bit more and call this get most common words 2 more times. But this time, instead of using our text, I'm going to use our created column called clean text. Now I am curious to find out what are the most common spam words when we removed all unnecessary words. And as you can see here, now we have new structure right now. And that's it. We have everything that we need to start transforming it from text to numbers in the next video, and then learn about the algorithm that we're going to use in this section called K nearest neighbors. Stay tuned for that and see you in the next video. So far, we did an amazing work together. We went through a raw data set to something that we can actually call clean text, which, if you don't make a mistake like this, is going to look like this. Everything lowercase, removed all the unnecessary words, and now we can actually go into the details on how to make this text into numbers so we can make some predictions on top of it. Okay, so when you work with text, there are many different ways, but the 3 most common ways to transform it from raw text or clean text as we have it right now to something that we can call features that can be used to train an algorithm on. So there are bag of words, TF-IDF, and word vectors. Now, word vectors are really out there and they're really complex. I have included amazing read in these resources if you want to learn more about it. And there is an amazing article that has provided this visualization for us, also in the resources of this lesson. And the simplest one is called bag of words, which will go to the whole data set, find all the unique words that we have, and dedicate a certain index to it. Now, bag of words might go and just put a vector of how many unique words we have. So for example, if we have 1000 unique words, you will have a vector of all zeros, 1000 of them. And instead of, let's say, 0 here, you will have 1, because that word is repeated inside of your example. Like for example, subject here is 1 because it is repeated right now. And that's basically it. And now you can go and make it more fancy, for example, where TF-IDF comes into play, where you would basically go and count how many of those words repeat in all of the texts, and then find out how many texts, or in this case emails, have that specific word repeated inside of it. So for example, basic has only repeated in the first one, not in the second one, and it has 0.5, so from 2 times, so from number of documents, then you would basically go and see how many times it actually repeats inside of those documents. In this case, in our case, a single document is an email. Now, it has amazing description on how to make it and how to work with this inside of the resources of this resource or this video. Okay, so to implement this in code, what we're gonna do is import from sklearn dot feature extraction dot text import something called count vectorizer, which is doing exactly as it sounds. It's gonna count how many unique words it has and just transform it inside of those vectors. So I'm gonna use vectorizer or tokenizer, however you want to call it. Here I'm gonna provide like this. So I defined it, and my X, which is all the features, emails, is gonna be vectorizer dot fit. So fit will take and find those distribution, find how many unique words are repeating when and stuff like that. But if you want to output transformed data, so instead of raw text directly to vectors, you're gonna call fit transform, which does basically 2 things: learns all the information, and on top of that returns the vectorized information. So if we take a look at ASX, and it has 5,171 rows, which basically states on how many emails we have, and it has 50,000 unique words in our data set. So some words are just, for example, subject, 10 is considered a word, FT, transport, volumes and stuff like that. All of that is a unique word, but the subject, for example, is a unique word, repeating all 5,000 times, and it will basically be considered as a one word. And this is our data set right now. And we need a target. So our target is what we actually want to predict. Now it's a label num, already present in our data set. And if I just show it right here, you will see that it's 0 or 1. 0 meaning it's a normal email, 1 being a spam. So now we have our data transformed. It's in a vector format. It's no longer a string, but we need to put one more thing before actually applying machine learning on top of it, which basically means splitting it to 2 different parts. Now, if we take a step back right now, before we speak about this methodology and just meditate about think what we want to achieve, any machine learning algorithm out there, whether it's a ChatGPT, whether it's a k-nearest neighbor or a spam detection filter, in this case for our spam mails, its goal is to predict on unseen data or data from our users that we don't really know yet. So we want or try to approximate that information along the way. Okay, so we collected some data. In this case, we have 5,000 samples collected from all over the place. It might be scraped the internet, maybe our internal data source, whatever is the reason, Kaggle in this our case. But we have 5,000 emails on our pile. So we need to see how our system will perform once it's deployed to our new users that never used our system before. And we need to approximate it in some way. And to achieve this, we're going to split our dataset into two different places or two different spots. One called training set and the other called testing or validation set. Now, those two are different things, and for now, you just remember that we need to split one more thing, split one part of dataset to make sure that our algorithm works so well on the data that it never saw before. Okay, so what we're gonna do is define xtrain, xtest, ytrain, and ytest. And we'll call a function from sklearn that we need to import right now. So from sklearn, model selection, import train test split. This train test split will take two mandatory arguments. One is our data, and the second one are our targets. So what we want actually to predict. After that, an optional argument is test size. So test size is what percentage of our data we want to put aside to actually leave our algorithm to test on. Then I'm gonna use random state, and random state will just make sure that we are gonna take these splits constantly the same way. If we want to close down the system and rerun it later, we want to be able to replicate the result and prove that we actually can achieve that specific accuracy. So to make sure that nothing is actually randomized, we want to put this random state to exact number so we can replicate that in the future as well. Okay, so let's see what this will do for us. If you take a look at xtrain.shape, it will say that it has 4,100 something samples of 50,000 that we actually know its number of unique words. But on the other hand, we have this xtest. So this xtest, if we check the shape, it will be 1,000 samples. Okay, so you might already see what we did right now. We took the full data set of about 5,100 samples and split into two different parts. One is called training set, which we'll use to optimize our algorithm, find those best parameters to use, and this will replicate or try to simulate behavior of users or emails that will come later in the future that our algorithm never saw. Okay, and when we measure the accuracy or performance, this is the most important argument, which will basically tell us on how well our algorithm will work in the future. And that's it. We have everything prepared. Now it's time to learn about the algorithm that we're going to use and train it for the first time. See you in the next video. The algorithm that we're going to use is called Key Nearest Neighbors algorithm, or KNN for short. And we're going to use it because it's the simplest algorithm to learn, and it can actually deliver decent results. So let's learn the intuition behind it. In machine learning, we have different ways of learning or teaching the algorithm to function. The most common one is called supervised learning, where we already have the data prepared and we know what the data is supposed to predict, which is called labels. And we have that right now, which is called Y. We know what email, when we collected it, which is supposed to be spam or normal email or ham. Now, Key Nearest Neighbor will take that data and optimize it so we can apply those rules learned from our data to unseen data coming from our users later down the road. So we have two groups of things that we want to classify. In this case, let's say this red group is called spam. On the other hand, we have ham. Now, the new email comes into the data set. We don't really know what it is. We have some data point, which is our email, and you know that these are not only X and Y or X1, X2, but it has actually 50,000 of those X's because for every word in our data set. So, okay, how to determine, or this is basically the goal, what we want to achieve. We want to achieve it to assign it whether or not it's going to be green or red, spam or ham. So let's see how Canon does it for us. So the first step is to determine what's gonna be K. This K means how many of those data points that we already know what are those, like spam or ham, we should ask for about the new data point. And that's the first step that we're gonna do. And it's really important to select it to be odd number, not even. For example, 5 is a default one. It can be 7, it can be 9, and so on. Why the odd number? Well, it needs to be decision breaker. If we have two of the class spam and two no spam or ham, the fifth one will determine whether or not it's going to be spam or ham. Now, how to calculate or how to find out what is the closest or which points are the closest one to something that we have? Well, for that, we're gonna use distance metrics. There are a lot of distance metrics that we can use, but the most common one is called Euclidean distance. Euclidean distance looks like this. So we have a square root of x2 minus x1 and y2 minus y1, and then squared. So the difference is squared, just to know that it can be negative difference, and we're gonna do the difference between all of the coordinates. Now, in this image right here, we have only two different coordinates, x and y, or x1 and x2, but in reality, in our case, we have 50,000 unique words, so we will have 50,000 differences that needs to be calculated, squared, and then used root out of those differences. And that's called Euclidean distance. Now, you can use cosine distance and so on, but the first one, or the easiest one to use, is Euclidean distance. We're gonna take that distance and measure it between the new data point to all data points in our data set. So if we have 5,000 of data points in the training set, we're gonna measure that distance between the new point, the new mail that came to our inbox, to all 5,000 of already received emails. And then we're gonna take the K closest ones and ask our system, our data set, hey, the K closest ones, are they the part of the spam or no spam? And we're just gonna take the majority vote and determine whether or not the new data point will be considered a spam or normal email. So this is how it works. If we take K to be 5, we're gonna measure the distance between all of them and take 5 closest mails in this case. And in these 5 closest ones, you see that 2 of those are considered spam, while 3 of them are considered no spam or ham. And because we are taking majority vote, we're gonna take and see that group 2 wins because it has one more sample than the red ones. And we're just gonna assign that the new email is not a spam, so it's gonna be proceeded to our primary inbox, for example. And that's it. This is how K nearest neighbors or KNN algorithm works. So let's implement that in the code in the next video and train it on our data. See you there. Now you know the intuition behind the first machine learning algorithm that we're going to learn together, k-nearest neighbors. Now, it might sound a bit complicated at first if you never used or worked with these kind of methods in the past, but trust me when I say it's really easy to work with machine learning algorithms these days when you have sklearn libraries at your disposal. So you don't have to implement anything by hand, so you can use all of that just in a couple of lines of code. So the first step that we're going to use is import sklearn neighbors and import k nearest classifier or regressor. So because we are doing classification, asking whether or not an email is considered spam or no spam, we're going to use classification. If you want to learn about the intuition behind classification and regression, go check out the appendix of the course where we teach about intuition and introduction to artificial intelligence. Okay, so once we have this imported, it's time to create an object out of it. So we're going to define KNN or classifier, however you want to call it. And we're going to define key nearest classifier. And inside the brackets, you don't have to specify anything if you want to use k to be 5. But just for practice, I'm going to specify n neighbors to be 5. And it's going to take 5 of those points as we visualized in the last in the intuition lecture. So we're going to execute that and create an algorithm. Now it's time to create a couple of more cells. And to train this algorithm to learn on our dataset, we're going to provide X train and Y train. And we have our dataset or dataset optimized or algorithm optimized on our dataset, so it knows what are the rules inside the data that we collected. And now it's time to make some predictions out of it. So to make predictions, it's really simple. Call knn.predict and provide the data. So I have X test, and it's going to run it through whole data set or test set and predict 1 or 0 on our data set. Cool, but we don't really know whether or not we are correct. So I'm going to store to preds, and I want to check out the accuracy. So the accuracy basically stays and asks how many of those predictions were actually right. So we have Y test that are 0 and 1s values. I'm going to extract only array. And if I go and ask for preds, it's going to be true if it's correct, or if it's 0, 0, 1, 1, and so on, or false if it's incorrect. Now, if I want to sum everything up, I can. And this number will give us 829. Okay, so what does it mean? Well, if our prediction was correct, or these comparisons yielded true, when we called sum, that's gonna be +1. If it's false, +0. So this only calculated how many of those were correct. And I need to define that by len of preds. And as you can see here, 0.8% or 0.80, which means that 80% is accuracy of our algorithm. So our algorithm, k-nearest neighbors, in 80% of cases is predicting correctly that our email is spam or no spam. Okay, so now you have an algorithm that is able to predict whether or not an incoming email is spam or normal one in 80% of cases, which is amazing for the first iteration of algorithm. If you want to play out of it, and you can, for example, choose nearest neighbors to 11, you can train it again, just run through all the cells, and you can see that our algorithm is changing. So it actually has worst accuracy right now. If you want to select 3 and check out for 3, you have increased to 83% of accuracy on our test set. So this is something that machine learning engineers or practitioners using these algorithms are supposed to do. When you use the first algorithm, in most cases, the first iteration of the algorithm won't be the perfect one. So you're going to iterate over it to find out what is the configuration, for example, the k nearest neighbors in number of neighbors, to use. So it's going to be perfect for your data. And that's it. This is how to learn or teach key nearest neighbors on your text data to predict. Let's see how to use OpenAI's ChatGPT to do exactly this in the next video. See you there. Now that we have our system created using traditional machine learning methods, which stays everything under our IP, the machine learning is trained, you would test multiple algorithms, in this case, the different versions of key nearest neighbors algorithms, but everything is implemented from scratch. But in this age of generative AI, when you work with text, you can optimize these big large language models or LLMs to solve these types of tasks for you. Not all of them. You will see that some of those won't be possible to be solved with OpenAI's in the next couple of sections of the course. But this one, because we are working directly with text data, is solvable, but OpenAI's API or ChatGPT algorithm. So by default, the library OpenAI is not installed. So we need to install it. It will take a couple of seconds to install the newest version of OpenAI library. And you will need to set it up. So the first step is to import OpenAI API. OpenAI, like this. Now you need to set up OpenAI.API key. Now, where to find this API key? In the resources of this lesson, you have the link to API's documentation where you can find all the necessary information extra out of this very video. So when you go to that very link, you will see that you can go directly to ChatGPT or API. So it's the same account as you're using for your ChatGPT access point. Once I'm here, the documentation page that you have in the resources, you have on the left hand menu something called API keys. These API keys allows you to tell OpenAI that you are the ones using these resources to make predictions. So you need to create this key and say, for example, cybersec course, and make sure, because we are speaking of course about cybersecurity, what I'm doing right now is definitely not secured. So I'm gonna remove this key right after we record all the videos. So don't worry about me, you won't be able to use the same key. But you're gonna paste it right now like this, or save it in environment variable under your terminal and then use it as from the code right now. So I'm gonna execute this and I'm basically ready to start writing a function. So I'm gonna write a function called classify messages. It's gonna take one message as an input. And here what I'm gonna do is call response. This response will call OpenAI dot. Now I'm gonna take chat, then completions, then create. And under create, I need to provide model, which will be the name of the model that we're gonna use. So it can be GPT-4 or 3.5, depending on what you have. So 3.5 is about 20 times, 10 times cheaper, depending on what you send directly to ChatGPT as a request. So GPT-4 is definitely more accurate, but definitely more inexpensive. So if you're creating a really scalable application, make sure to balance the cost. If you want to check out the GPT or OpenAI models, you can go to the link right now, models, and you will have all the models listed right now. So the newest one is GPT-4-1106-preview. Now, I'm not intentionally using this model right now because in most cases, people won't have the access to this model. So I'm using the traditional one called GPT-4. Okay, so GPT-4 will be sufficient enough. Now this is cheaper one than GPT-4 traditional one, but in most cases people will have it. So for course sake, I'm using this one. If you have the access to this one, you can use this one. If you go to the documentation and go, for example, to text generation, or you can go and chat completion, this is what we are going to build. So it will take messages, and you can copy like anything like right now and go paste it right here. So just to see the structure, and we're going to change it for us. So messages will always be a list. List of dictionaries in Python. Now it has 3 roles. System will tell ChatGPT that we want this to be a system, or basically act as a something, act as an algorithm, act as a marketing engineer, whatever. So you're basically sending a context directly to it. Every second value will be content, which is your prompt. Then user is something that you are sending to it, your message, and assistant is the response. So if you want to iterate through different responses, you're going to take user assistant, but for now, we don't want any user and assistant. We just want the system and user, because user will have a content of message. So let's change it to our message from the data set. And here for the content, I prepared our prompt, which is going to look like this. Let me remove this. Okay. So act as a spam detection algorithm for email classification task. Classify given message or email into spam or no spam. You can control the output to make sure that it only receives the JSON output, but we can change it later on. So for now, I just want to return response.choices of 0, the first choice, text.strip. And this is the output of this message. So if I take the message, for example, free money, click here to claim your prize, like this, we're gonna send it directly to the prompt, and we're gonna take the response. Now this one says that, hey, choice object does not consist of a text. Now they are changing their library constantly. So if you receive some kind of message like this one, make sure that you go and visualize, like for example, we're gonna return just response, just to make sure what is the response structure of this library right now. So you can see that we're gonna take the choices. I'm gonna check the first choice, which is this one. And this one will take message as a argument, and then content, and then strip. So we're gonna take choices, the first choice, message, then access the content of that message, as you can see right here, and strip. So I'm gonna remove this, and it's considered spam. Okay, cool. So it's working perfectly for us. We implemented the same algorithm. Now, amazing thing for this, you don't have to do any data preprocessing. to use ChatGPT. So let's use the same for classify message. And what I'm going to do is data of text, not clean text, values, and I'm going to put like 10. And before I send directly to it, I want to create like this just to see what we are sending. So this is the data that we are sending. And if you take a look at what we are supposed to have as an output, we can go to like this. It's 1, so it should be a spam. And if I run it through now, it's considered spam. Okay, amazing. It's working perfectly. And now you can go and consider what you're gonna use for your own system. So now that you have implemented your own algorithm and or spam detection system using ChatGPT, which is scalable as much as you want, but with money, of course, it's the time to decide what you want to use. If you want with the KNN, it is definitely less expensive, but it might be less accurate because ChatGPT is trained on so much more data than our KNN algorithm. But you can always go to the choice of choosing another algorithm that we're going to learn in the future of the course. The advantages of KNN, if you deploy with your application, the latency and the prediction time might be much shorter than OpenAI's API, and you are relying on yourself to deploy and to control. The cost of running KNN is definitely much cheaper, almost free, compared to OpenAI's API, which is definitely a lot more. And sometimes it can go to hundreds, if not thousands of dollars to make a simple prediction. Maintenance or maintainability of the systems definitely goes to ChatGPT end, because you're not maintaining anything except the balance in your account. So everything is kind of outsourced to them, where for KNN, if you want to have everything in-house, you need to make sure that everything is deployed and considered on your end. And of course, the privacy or security of the systems. KNN definitely has privacy and security on its end, because you're not sending data to anywhere. Everything stays on your server. So if you want to secure and predictably secure private application, definitely go with your own application and not some LLM that is APIs driven. And that's it. Congratulations so far. We built amazing system for spam detection that works either with KNN, with our solution, or with OpenAI's API and using the newest algorithm called GPT-4. And that's it. See you in the next section.
We talked about phishing and social engineering in detail in Module 3, so we're not going to be diving deep into it right now. But let us just make a quick recap as to what phishing is and learn about different types of phishing attacks that exist. So phishing, we already said to be a specific type of social engineering attack that typically occurs through electronic communication. It involves sending deceptive messages via email, text messages, or instant messaging. However, out of all of the methods, it is safe to say that most of the phishing attacks take place over email messaging. Some of the characteristics of a phishing email include spoofed sender's address, urgent or threatening tone of the email, spelling and grammar errors, generic greetings, request for sensitive information, mismatched URLs if URL is provided in the phishing email, and unusual or unwanted attachments. Now, besides email phishing, there are other types of phishing that we want to know about. These include spear phishing, and spear phishing is a type of a targeted email form of phishing where attackers tailor their messages to a specific individual or organization. The emails often contain personalized information to increase the likelihood of success. This type of attack is common in corporate and governmental espionage. Then we have Wishing, which stands for voice phishing, and phishing involves using voice communications such as phone calls to deceive individuals into providing sensitive information. Here, attackers may pose as legitimate entities such as banks or government agencies and use various social engineering tactics to extract information. Another one that utilizes phone to conduct phishing is smishing, and smishing stands for SMS phishing. Smishing uses text messages to trick individuals into providing sensitive information or clicking on malicious links. These messages often appear urgent, claiming issues with bank accounts, passwords, or other critical matters. Farming is a sophisticated type of fraudulent activity that redirects internet users to fake websites to steal personal or financial information such as login credentials, credit card details, or social security numbers. And the last one that we want to talk about is whaling. Whaling targets high-profile individuals within an organization, such as, for example, CEOs or top executives. Attackers use social engineering techniques to create convincing emails that will trick anyone into performing actions like, for example, transferring funds to a different bank account. Okay, so this was a short lecture. It was good to refresh our memory about phishing attacks. And now let's move on to something that we have not talked about before, and that would be different ways as to how we can detect phishing attacks. See you in the next lecture. Being aware of these different types of phishing attacks is crucial for individuals and organizations to recognize and mitigate the risks associated with deceptive online tactics. Education, cybersecurity awareness training, and the implementation of security measures are essential components of a comprehensive defense against phishing. You and everyone else should know how to recognize some key characteristics of phishing attacks. For example, when it comes to phishing attacks that lead you to a fake website, there are a few things that give it away. Number one thing is to always check the URL and check if it matches with the official website's URL. Let's say you get an email from PayPal customer support asking you to reset your password. They provide you a button which once you click on, it leads you to a PayPal-looking web page that looks exactly the same as a PayPal page, but the URL has two L's in the name. That would be a 100% indicator that it is phishing attack and that you should not input any personal information there. Another giveaway would be if the page is HTTP and not HTTPS, especially with banking platforms and social media platforms. They will almost always be HTTPS to provide more protection. And if you encounter an HTTP page, once opening a link from the email, you should double check it if it is coming from the right source. Keep in mind that even if the page is legitimate, but it is just regular HTTP and not HTTPS, it is still dangerous to input any personal information there. The reason is that HTTP pages are vulnerable to man-in-the-middle attacks, which means an attacker spoofing the connections could intercept all your traffic sent to an HTTP page and read it in plain text because the traffic is not encrypted. This also includes passwords as well. So if you send them to an HTTP page, they can be read by an attacker in plain text. Okay, but what if the web page from the email that we are suspecting to be phishing is not a web page that we visited before? We can't know if the URL is correct or incorrect, and we can't know whether the page should be HTTPS or not, since we didn't visit it before. Well, in that case, there are a few things you should check. You should check the page for spelling and grammar. You should check the page for fake logos and fake branding. You should always verify website certificates and check for lack of privacy policy or terms of service. Let's not forget to mention that if there are too good to be true offers inside the email that leads you to an unknown web page, it is always good to be suspicious. And lastly, you can check for any contact left on the web page and call that contact. These would be some of the manual methods of detecting a phishing attack, and to be honest, it is also the best way as well. There are tools that will help you detect phishing attacks such as Barracuda Sentinel, Sophos Email Security, McAfee Total Protection, Iron Scales, and others, but it is always best if you combine your own knowledge of manual phishing attack detection with a phishing detection tool for best possible security. If you do decide to get a phishing detection tool, here are the things to look for. You first of all want to look for real-time detection and blocking of phishing attacks. What's the point of the tool if it doesn't block the phishing attacks at the time that they're taking place? Ideally, you also wanted to have machine learning-based analysis to identify phishing patterns, and you wanted to have the browser extension or plugin to let users know when they visit a potentially malicious domain. These tools might also have deny lists and safe lists, and this simply means that the software should maintain and continually update a database of known phishing sites and email addresses. So if you at any point come interacting with one of those email addresses or websites, it immediately notifies you and blocks the attack. If your tool has a possible integration with other security systems, that is also good. And you also wanted to have detailed reports and analytics of phishing attacks that took place. Alright, it is important to note that while these traditional anti-phishing solutions are effective, user awareness and education are critical components of a defense strategy against phishing attacks. Okay, now that we know what phishing is, we know different types of phishing and how to recognize these attacks, let us focus on introducing artificial intelligence into phishing attack detection in our next project, which will be website phishing detection with artificial intelligence. See you in the next lecture.
In this section, we are embarking on a new challenge to make a website phishing detection algorithm using machine learning. Now, we are going to leverage everything we learned from the previous section and learn a new algorithm to apply to these kind of problems that are considered classification. Now, if you want, you can also apply KNN or K-nearest neighbors algorithm that we learned in the previous section to this problem as well. We're going to learn a new algorithm though, so you can have more options to apply these machine learning AI algorithms down the road. So the structure of the project will be the same. We're going to load some libraries that we use so far, understand the data set that we're going to use, and explore it. And after that, we're going to import it, of course, and apply some data analysis points to understand what the data is consisting of. Do we have some missing points, and so on. So it's going to be really interesting to build this type of a system based on machine learning. So let's get started. You can find the workbook directly in the resources of this video. So if you want to follow along and download it directly from the resources of this video. The link to the dataset is also linked directly in the resources. So if you can go directly from the resources or from your workbook. And because it's a Kaggle, we downloaded the file for you and provided under resources as a raw file. So you don't have to create an account yourselves if you don't want to. Cool. So the first step for us is to import dependencies. Now, we used all of these in the previous section, from NumPy, Pandas, Matplotlib, and finally to split our dataset to train and test parts so we can test our algorithm offline when we are done training to see how well it's going to perform on unseen data, meaning data that will come potentially from users in production. Once we have our libraries loaded, at least the libraries that we know we are going to use, we're going to use more, of course, in the future. Go to this link or download directly file from the resources of this video and start exploring it. When you go to this link right here, you will end up to the page that looks like this. It's a Kaggle page, normal page about the data set. Every data set at the Kaggle at least has a context or kind of exploration of the content itself, how it was built, what is the intention, why somebody built this data set, and so on. This in particular data set is built, of course, for researchers in phishing detection for different websites. It is created by scraping the websites and using Selenium WebDriver to analyze different perspectives or parts of the data set. And they actually calculated 48 different features or meaning columns about every single website. And we have 5,000 websites considered phishing, while 5,000 considered normal or legitimate businesses. Now, because we have really balanced data set right now, it's considered really research data set. So in production or in a real world, in most cases, we won't find exact number of normal or positive samples as negative ones as well. So this is kind of tuned for us to research on. But this dataset is amazing for a couple different reasons. The first one, it is really proven to be working in a production. So if you are able to collect all of these 48 features for new websites, this dataset will be amazing as a starting point. The second one, it's kind of ideation phase. So if you want to explore and create your own dataset for new websites, because these ones are from 2015 to 2017, you definitely can. And you can have this dataset as a reference to start building your own. And on top of that, if you're just starting out with phishing, this is an amazing starting point to understand what other people are thinking when they consider analyzing a website about phishing. When we scroll down, you will have the overview of phishing legitimate full.csv with all of the columns. Well, not all shown, as you can see, 10 of 50, so you can select all, apply, and we're gonna see all 50 of 50 columns right now. Now, here we see number of dots, subdomains, path levels, URL length, number of dashes in the host name, @ symbols, and so on. So it's analyzing URLs in many different ways, hashtags, no HTTPS, random string, IP address, so analyzing IP addresses as well, domain in subdomain, domain in paths, and so on. Query length, you can see that it's actually analyzing a lot of data load that is coming towards your way, connecting to different perspectives of URL that is considered to you. So it's not a pure URL, but also features that are extracted directly from it. Okay, cool. So now we understand what we can get, and class label is the final one that we are trying to predict, 0 meaning it's not phishing and 1 meaning it's phishing. And if you want to find directly the source of the dataset, here is the link under Kaggle, which will lead you to this page right here. It is a paper that has a lot of views and downloads, meaning that people are still doing data mining, machine learning, and exploration of phishing approach to this dataset as well. Okay, so this is a dataset purely designed for us to do research on, so we can start exploring it right now. Once you download the dataset, go right here, click upload, and find the phishing dataset. So phishing legitimate full, open, and as always, this dataset will be removed after you close this session, after you finish working. Okay, cool. So I'm gonna right click rename just to copy the name so we don't have to type it out, and close this on. Then type data equal to pd.read.csv and then paste the name CSV. When I execute this line and then provide data.head, you will see that we have 5 times 50 columns, everything that we saw in the Kaggle website as well. The ending with a class label, so we're going to have 48 features. One of them is URL ID, so ID is not considered feature, and the last one is the label, so it's not feature as well. So for every single website we have 48 features and 1 label that we're going to use. Now that we know this, let's start exploring the data set and do some proper analysis on it. See you in the next video. Whenever we start working with a new data set that you potentially never even created, so used from an online source as we did so far, you need to analyze it, meaning understand what is the reasoning behind it, what is the structure of data, does it have some missing values? Because missing values might be a make or break for your task. If you don't have all the values inside of your data set, you might just remove some columns or rows depending on how many of those missing points you have in your data set. So to find out that information, you can go and type data.info, and this will take all the features that we have inside of data set and find out what is the amount of those features, meaning just the rows, and if there is some missing values, not null. Now, in this case, we are really lucky and all of those are filled for us, so we don't have to imagine or do some imputation of data, meaning how to fill those missing values. And on the other side, we are also very lucky that this dataset has all integer or floating data points, so we don't have to convert it as we did or had to do in the previous section with the text data. So in this case, we just can do some more analysis on top of it and then structure it in a training and test set to start working directly with this data set for our machine learning. Now that we have this information, the distribution is also really important. And the other comment that will help you a lot when you analyze future data set is called describe. So data.describe. This describe will take every single column and count basically how many of those unique values you have, or how many entries you have, what is the mean value, what is the standard deviation, what is the minimum value, and what is the maximum, and what is everything in between. Now you have all of these features between, 0 and 1. You have URL length that goes between 12, I think, yes, that's minimum, to 253, and number of dashes, which is 55. Okay, cool. So in most cases, when you apply a certain algorithm to this, you would need to handle these features. But because we don't use a normal algorithm in this section, we are using something called decision tree, which we're going to cover in future video in this section. You don't have to care, or you don't have to pre-process and handle this in a special or a separate way. To find out the maximum values, because this is not really readable, I'm gonna create a new data entry, so data.max, and provide something called axis 0, meaning am I going to look per column or per row? And because I'm interested per column, so to find out what is the query length or path length, the maximum values at least, that's what axis 0 means. So checking like this and not like this. Okay. And as you can see right here, the URL length is 253, and the most of those are ones, and that's basically it. Once you know what is your data distribution and decisions that you need to care about, are you going to pre-process the data in a different way? Are you going to remove some data points or add information to the data set if, for example, some data points are missing? Now it's time to decide whether or not you're going to use all of these features directly to your algorithm. And we know that one of those columns, meaning ID, is not really informative because it's just an ID. It's increment +1, so it's not really a feature, it's just an information from a database. So we need to drop it or remove it. The function to do that is called data, so your dataset.drop. And then under drop, I'm going to specify the name of that column. So in this case, it's ID. Axis is 1 because I'm dropping from all the rows that specific column. And if I do this like this, you will see that we don't have 50 columns anymore. We have 49 because we removed that ID. And if I call this head right now, you will see that we still have this ID. Yes, we dropped it, but it's somehow there. So this means basically that we did it in a runtime and we didn't do it in actually memory. So to apply this change in memory, you need to provide another argument called in place and set this to true, meaning we're gonna change directly from the memory. And when you call head again, you will see that we have 49. There is no ID anymore. Now, from the distribution or from the data exploration phase, we need to determine what is the class balance. And we know that from our Kaggle, but it's always good to test it out. If there is some way in transaction that some information is missed, So no, it's not. We have 5,000 by 5,000 and that's it. Now it's basically that. We have all of this done. We know that we are not missing any data. We know that we have all of that data scaled to some degree that we can use it directly in the algorithm. It's time to split the data into train and test part. Now we've done it in the previous section, so I want you to try it alone to see if you can go about and split it into train and test parts based on the lectures from the previous section. And if you need help, in the next video, I'm going to show you how to do it. See you there. I hope you had a lot of fun splitting the data into training and test parts. So let's do it right now and together split the data into features, targets, and then finally training and test parts. So here I'm going to select features or X, depending on how you want to call it. It's the same. Then data, I'm going to specify drop, and then I'm going to specify class label X is 1. But I'm not going to specify it in place because I still want data to have it as a default column. I'm just going to save that instance where class label is not present in this X variable. Then I'm going to just paste it right now and define Y. And here instead of drop, I'm going to use these brackets as a kind of a selection of this class label column. So we have X and Y, and now it's time to call this train test split algorithm that we defined at the very beginning of this section. If you scroll up, here it is. So what I'm going to do right now is define X train, X test, Y train, and Y test. This will have train test split, and here I'm going to provide X and Y. And if you want, and it's a good practice, to define a random state to any number, I'm using 42 because that's the answer to everything. And I'm going to execute this, and that's it. We have our training and test parts. So if we check out test.shape, is going to have 2.5 thousand, while X train will have 7.5 thousand. Okay, so 25% is the size of our test set. So I would keep it like that. Okay, now it's time to start talking about the algorithm that we're going to use. So let's do that in the next video and explain an algorithm called a random forest algorithm. See you there. The algorithm that we're gonna use or learn in this section is called decision tree and random forest. So let's talk about the first part of this algorithm called decision tree. Now, decision tree, as we had before, it's a classification algorithm. But right now, it can work with many classes as well, as can and did as well. So if you had 10 classes, it will work as well. And it works as a decision tree. So it will break down to a set of rules your data and decide what part of data set will be sophisticated enough to decide what class it's gonna look like. And it looks something like this. So if you had a data set that is a bit more complex, so red class is going together to the part of the blue class, and of course this is only x1 and x2, it can be much more complex than this. It can split to something like this. So it will decide on multiple decisions. So from this one, so if it's above 60 for x2, it's going to be above this line. If it's below 25, it's below this line. And then on x1, it's going to monitor for 35 and 70, and of course all in between. And because it's a decision tree, it can do that really easy. Now you can, for example, do this, and let's say first is if x2 is larger than 60, if yes, then it's blue. If no, let's go and check out if x1 is larger than 70. So we're gonna be this. If yes, it's gonna be yes. If no, we're gonna check out and decide for x1, which is in this case asking again, hey, is it larger than 35? And if it's larger than 35, it's gonna still be blue. Or then, okay, well, more complex, then we need to ask. So if it's no, so then we're gonna say red. If yes, we're gonna go and monitor x2 now. And if we have this line right now, we're gonna ask if it's below 25, then it's blue. If yes, it's gonna be red. And we have that classifier. And that's it. This is how this classification works. Now, why random forest? Well, we have multiple of these decision trees that we can ask our algorithm to create and create different thresholds to ask for our features. So we are not only splitting for x2 of 60 or x1 of 70, but we are actually creating hundreds of these algorithms to classify on a different spectrum. And what we do, we are taking all of those 100 plus algorithms we create, we're gonna take as many as possible predictions and make a prediction or make a final prediction that is most popular or most present in our final predictions. And that's it. This is why we have random forest as our decision maker. Okay, so now that we know the intuition behind this algorithm, let's implement this using sklearn. See you in the next video. Now we know how random forest algorithm functions. So let's import it from sklearn and create it using Python. So from sklearn, because it combines multiple algorithms or multiple decision trees, it's called ensemble. So ensemble learning is a type of machine learning where we are defining multiple algorithms and using a decision based on multiple predictions, which is going to be final one. So in this case, I'm going to define random forest classifier. Now it can be used for regression and classification for us because we are predicting the class, whether or not it's phishing or not. We are predicting a concrete number, so it's classification. So I'm going to define it as RFC. You can name it as whatever you want. And then random forest classifier. And at the first iteration, I'm going to use normal or default arguments, default configuration. But if you want to change the number of trees, decision trees, you can, as a first argument is number of estimators, which is by default 100. If I define it and create a couple of more code blocks, I'm going to use rfc.fit x train y train. Okay, cool. So it's going to take a couple of seconds and we are done. Let's make predictions. So rfc.predict on x test. Cool. So we have our predictions. So far, what we did is basically compare it to y test to see whether or not something is true or false. So I'm gonna just use values right now to have it like an array. And if I have sum and divide it by length of preds or y test, we'll have 98% accuracy. So with 98% of certainty, we can predict whether or not a site is phishing somebody or not. How amazing is that? And we done it with a default configuration of random forest. Now you can always play with number of estimators, with different configuration settings and so on. We're going to learn all of that in the future section, how to automate that process as well. But for now, with the default one, we have almost 100% accuracy, which is amazing. But now it's a question of, is it really performing that well? Or do we need to have this type of accuracy calculation all the time? Well, the answer of those two questions on one And yes and no, we need to test it out. There are multiple things that we need to ask. Is this actually performing well? So let's discuss on different metrics to evaluate our machine learning algorithms in the next video. So far, we tested our algorithms in a single way. How accurate it is towards our test set, which is or has a goal to replicate and simulate users that will come to our platform down the road. But sometimes the accuracy is not the perfect solution to follow or perfect evaluation metric to follow. Just imagine this. We are tasked by business to create an algorithm that will predict whether or not somebody on ATM is making a fraudulent transaction. And we get 10 million transactions as a data set. From those 10 million, only about 10,000 of those are actually flagged as a fraudulent one. So if your algorithm only predicts zeros, you would have basically 99-point-something% accuracy of the algorithm, which on paper sounds amazing, but it's completely useless because it is not able to capture the difference between the fraudulent transaction and the main point, which is to not flag the normal ones. Okay, so there are two metrics that we can add on top of our accuracy, which are called precision and recall. To calculate precision, we have two new terms to follow: true positive and false positive. True positive means when we predict a website, for example, that is phishing, it's actually phishing. But false positive is when we predict a website that is normal one that is phishing, but it's actually not phishing. So if we predict everybody to be phishing, this would be really low because we have so many false positive, but only a couple of true positive. And to calculate precision, we're going to take true positives, so what websites are actually phishing, and we predicted them as phishing, divided by everything that we said as phishing. So we have true positive plus false positive. Okay, that's precision. The other metric that we can use to calculate the success rate of our algorithm is called recall. So it will take true positive, which is still if a website is phishing and we actually predicted it as a phishing. And then we have false negative, which basically stands about if a website is phishing and we didn't recognize that as a phishing, or we just predicted it to be a normal website. That's not good either. So to calculate that, we're gonna take our true positive divided by true positive plus false negative. And that's basically how recall and precision are calculated. Now that we know that, let's switch back to the code view and implement that in code. And we are back in the code. So from sklearn.metrics, I'm going to import accuracy score, then precision score, and finally recall score. Those are three metrics that we introduced right now. So accuracy will actually calculate the same thing that we did so far. We're going to take y test, and we have preds, and it should return the same as we calculated right now. So basically giving us the same score or how accurate our model is overall. And then we're going to take precision score. So just remember, precision will monitor true positive divided by true positive plus false positive. So you can see this in the documentation right now. And if I use y test and preds, it's gonna take 98.34, which is amazing. And then finally, to calculate everything, we're gonna take score, a recall score, and we're gonna take y test and preds. So just remember, This recall will take true positive divided by true positive plus false negative. I'm going to take this, and it's also 98 point some percent. All of this indicates that our algorithm actually captured the data consistency really well, so we can go and start exploring how to deploy it. And this is a really good algorithm to continue with further investigation. Now you have everything covered, from the data set that you can use to further solidify your knowledge in the realm of how to structure your phishing detection system, to actually knowing two algorithms to predict this kind of behavior. You can use random forest, which is amazing and really robust algorithm. In most cases, researchers are using it to detect mostly anything basically in classification world. And you have KNN, which we learned in the last section, where you can apply the same KNN that we learned and applied in the previous task to do this task as well. Now, just one and a final quick note, these metrics are there when we have binary classification. Accuracy is used all the time, but these ones are used when you have binary classification. There is a way to do it multiple classes as well, but it needs to be interpreted in a different way. And that's it. Let's continue learning about how AI can be applied in cybersecurity world in the next section. See you there.
All right, let's talk about network security. At its core, network security is the practice of safeguarding computer networks and the data they harbor from unauthorized access, attacks, and potential damage. Picture your network as a medieval fortress. Just as walls, gates, and guards protect the physical realm, firewalls, IDS, IPS, and encryption fortify our network. Now, when it comes to network protection, there are quite a few tools that are used to tighten up its security, and we mentioned most of them a few sections ago, but let's quickly go over them again to refresh our memory and to prepare ourselves for the next project. Let's go over each of them and mention what do they do and how they are useful. First one that we have is something we have already talked about, and those are firewalls. But remember, there are two main types of firewalls. We have host-based firewalls and network-based firewalls. Right now, we are interested in just the network-based firewalls. Network firewalls can be both a software or a hardware device used to stop or mitigate unauthorized access to private networks connected to the internet. The only traffic allowed on the network is defined via firewall policies or rules. Any other traffic attempting to access the network will be blocked by the firewall. Now you can imagine a firewall as some sort of a gatekeeper. Whenever certain traffic or packets arrive, the firewall inspects those packets and compares them to the previously set rules. If the packet aligns with the rules, it is permitted to pass. If not, then it is blocked. This process applies to both inbound and outbound traffic, ensuring a controlled and secure flow of information. There are several different types of network firewalls, and these include packet filtering firewall, which is the firewall that we just discussed. It filters all the incoming and outgoing network packets. It tests them based on a set of rules that include IP addresses, port numbers, and other aspects of the packet. If the packet passes all the rules, the firewall allows it to proceed to its destination and rejects those that do not pass. Next up we have stateful firewall, and stateful firewalls go beyond packet filtering. They include packet inspection technology and TCP handshake verification to provide protection. These firewalls, which are also known as dynamic packet filtering firewalls, examine each network packet to determine whether it belongs to an existing TCP connection or another network session. Opposite of those are stateless firewalls, and unlike the stateful firewalls, stateless firewalls do not maintain information about the state of active connections. Instead, they make decisions on a per packet basis, independently evaluating each packet without considering the context of previous packets. And we have next generation firewalls. Now, next generation firewalls integrate additional features such as intrusion detection and prevention, application layer filtering, and advanced threat protection, offering a more comprehensive defense mechanisms than the firewalls that we talked about before. It is the most common type of firewall used in network protection today. Alright, these would be just some of the firewalls used in network security, and they're doing a pretty good job most of the time. But firewalls alone are not enough. When it comes to network security, besides firewalls, you will also often hear about IDS and IPS. IDS and IPS is something that we already talked about before. They stand for Intrusion Detection System and Intrusion Prevention System. Same way we had a division of firewalls into host-based and network-based, IDS and IPS also have their division in host-based and network-based. Now we are currently interested in the network intrusion detection and prevention systems. So what are they used for? Let's just quickly go over it, even though we mentioned it a few sections before. Well, let's define IDS first. An intrusion detection system is defined as a solution that monitors network events and analyzes them to detect security incidents and threats. IDS looks for suspicious network activity or incidents and sends out alerts to incident responders or to the Security Operations Center analysts. So we can say that IDS has two crucial steps, which are detect and alert. On the other hand, Intrusion Prevention System goes a step further. It actually tries to stop the detected threat. It is an advanced security solution that not only detects malicious activities, but actively works towards preventing or blocking them. It combines the functionality of an IDS with the ability to take immediate action to stop identified threats. Now, another tool you might have heard about before in the course, which can be useful in network security, and that is SIEM system. SIEM stands for Security Information and Event Management, and it can be used to collect and analyze log data from various sources across the network to identify and respond to security events. Let's remind ourselves of some of the key characteristics or tasks that SIEM systems perform, and those include event collection. Now, SIEM systems aggregate log and event data from various sources within the network. This can include firewalls, intrusion detection and prevention systems, routers, switches, servers, and other network devices. By collecting data from diverse sources, SIEM creates a comprehensive view of network activities. We also have normalization and correlation. SIEM normalizes the collected data, converting it into a standardized format. This step is crucial because different devices generate logs in various formats. Once normalized, the SIEM system correlates events, identifying patterns and relationships that might indicate a security incident. Now, SIEM is also used for threat detection, as it uses predefined rules and algorithms to detect potential security threats. These rules are based on known attack patterns, abnormal behavior, or deviations from the established baseline. The system can identify activities such as multiple failed login attempts, suspicious network traffic, or other indicators of compromise. It also generates alerts, so when SIEM system detects an event or pattern that may indicate a security incident, it generates alerts. These alerts are sent to security analysts or administrators in real time, providing them with timely information and potential threats. And in case incident does happen, SIEM system also helps there. It helps with incident investigation, as security analysts use the SIEM console to investigate and analyze the alerts. The system allows them to drill down into the details of specific events, view related logs, and assess the severity and potential impact of the incident. And two more key characteristics that we will just mention are compliance reporting, which many organizations are subject to, since they have regulatory requirements and compliance standards to fulfill. SIEM systems assist in compliance management by providing reports and documentation on security events, ensuring that organizations follow regulatory guidelines. And lastly, we have automated responses, which are used by some advanced SIEM systems to automate responses to certain predefined security events. For example, they can automatically block an IP address that is engaged in suspicious activity. Alright, trust me, these are not all the functions that SIEM systems do. You can see that it can be quite useful when it comes to network security. In conclusion, we can say that SIEM is a powerful tool for network security, offering a comprehensive and centralized approach to monitoring, detecting, and responding to security events. Alright, these would be the most common tools used for network security, but this is not where the list ends. Network security is a lot more complex than this. If you're serious about your network security, besides just using the tools that we mentioned, you will also perform manual periodic monitoring and scanning. Manual network traffic monitoring can be done with tools like Wireshark, while networking can be done with tools like Nmap or Nessus. Nmap is a network mapper tool used to scan networks for open ports, their services, and versions of services running on those open ports. Nessus, on the other hand, is a vulnerability scanner for your network. All of these tools, of course, require expertise in order to properly run and read the output from, but it is essential for enhanced network security. And in case you forgot, we are in era of artificial intelligence and things are changing fast. All of the mentioned tools and techniques are part of the traditional way of securing your networks. And while they are here to stay for some time, it is just a matter of time before all of this is replaced with artificial intelligence. And since in the course we're exploring AI in cybersecurity, let's develop a tool that utilizes artificial intelligence for network security.
Hello everyone and welcome to section 7, where we're gonna explore on how to build a network anomaly detection system using machine learning. So far we explored multiple cases where AI meets cybersecurity, but this one is really interesting because every single day we can notice a lot of attacks to a specific network or a system. And this dataset that we're gonna use throughout this section should be able to replicate some of the attacks or cases where we want to prevent them or detect them at least, so we can prevent them of happening in the future. In the resources of this video, you will find a link to workbook that I'm using throughout this section that you can create a copy out of it and start editing as per your needs and experimentations. Okay, so we have a couple of lines already implemented for us. So let me walk you through them before we actually explore the data set. As before, we have a couple of imports, so NumPy and Pandas, couple of libraries that we always gonna use. Then we have two for visualization purposes, Seaborn and Matplotlib. That's all standard. However, we have one list of strings called columns. And you see that it's duration, protocol type, service, flag, and so on. So all of this are strings or names of columns that we can notice happening in the data set that we are about to download. So all of this data information or column information should be there, but it's not quite, because we are going to receive an empty or just data inside of a text file. So it doesn't have this information and we need to add that information to that file. So I'm going to remove this extra line, execute this, and we define this column list right now. Okay. So to find the dataset that we're going to use together is on the link right here or on the link in the resources of this video, which will lead you to Kaggle as always. However, as always, we're going to download these files for you so you can download directly from Udemy and you don't have to create your own account on Kaggle. But just to know, the original data point is from this account right here. The dataset that we're going to use is created to simulate and actually detect a lot of attacks to specific network systems. And you can see here that our task is to create or build a network intrusion detection system to detect anomalies and attacks in the network. There are two problems: binomial classification, meaning is there an attack or not, which we're gonna tackle, and multimodal or multinomial classification, where we are actually detecting whether or not is activity normal, DOS, probe, R2L, or U2R. So these are not explicitly defined for us, and there is some work to be done so we can actually perform this multimodal or multinomial classification, where if you want to do that, under code section right here, you have one of the examples, this one, that actually talks you through or walks you through the whole example of preventing or detecting multi-class problem. So if you want to do that after this section, please do that and practice on your own. It's going to be an amazing practice section for you. Now, as you can see here, the list of all columns that I pasted are coming from here. So they created the whole list of columns that we can just plug and play to our code, which I did, and we can start working. When you scroll down, you will see some of the columns that are present. Every single column is explaining some information about the data. So duration, length of the time duration of the connection, protocol type, service, flag, meaning status of the connection, normal or an error, SRC bytes, number of data bytes transferred from source to destination, then number of data bytes transferred from destination to source, land, wrong fragment, urgent, and then you have hot, number of hot indicators in the content such as entering a system directory, creating a programs, and so on. So you can read about all of the columns right here, all 41 of them. Then you have attack classes, which explains what you can create a system for, like DOS, probing, U2R, R2L, and so on. When you scroll almost down, you have a couple of files. So this is the first dataset coming from two different files, one for testing purposes and another one for training. And you will see that both of them are in TXT format. However, you don't have any classes and it's not really structured in a good way. So we need to do some extra polishing of this data so we can actually work with it. Now you can see that there are a lot of parameters and we actually want to use all of them to perform that classification problem with the new algorithm that we're going to introduce together in this very section. Okay, so when you're ready and when you download the file here or take your time to explore the dataset through these descriptions right here, switch to the code and start coding itself. The first step is to upload the files. So I already downloaded the files, so click upload, archive, and I have these two files, train and test. I'm gonna upload two of them just for the sake of it, if we potentially gonna use them. Then, while that is uploading, I want to start building the first line of code, which is actually using pandas library to load these files to our memory. So what I'm gonna do is define data, then use pd.read_csv, which is a bit weird because this is a txt file and we don't have a CSV extension. However, what we can do is use train.text and then provide sep, which is shorter for separator, and create a character, meaning what is going to be an indicator for us to specify which column or which column starts and where the next ends. After that, I'm going to do and define names, which is going to be columns that we defined right here. And when you execute this line of code, it works. I want to do the same thing for our testing file, just for sake of it. And then provide test. And here we go. We have data, which is our training data and testing data right here. Now, for some reason, this is loaded. If you have an error uploading the file, or Google for some reason is not uploading the full file, don't worry, just try again. Close it when you're done, and you have two files loaded right here. So let's explore data.shape to see what is the shape of our data set. And you can see that we have 76,000 entries and 43 columns, which indicates that we have some extra columns that we need to take care of. So let's get ahead. And you can see here that we have duration, protocol type, all the columns that we mentioned when we looked over it. And we said, okay, so there is an attack that we're going to potentially predict. and we have last flag. Okay, cool. So everything is there. Now that we have our understanding or basic understanding of the data, it's time to go and perform data analysis and data pre-processing so we can actually put an algorithm around it. Let's start building a data pre-processing pipeline in the next video. See you there. Before we continue with our data processing pipeline and data analysis, it's an important thing that I want to mention right now. So when I loaded the data set and got into the place of about 76,000 data points, it is not the full data set. The full data set has about 130,000 data points or rows. So if you leave the full upload of this train.txt file, you might have even more data than I do. So if you have more data, 130,000, that's the right answer. So this amount of data that I have will still be useful, really useful for us, but the original dataset has more data than this one. Okay, now that we understand that, let's jump to data analysis. The first step, as always, I want to find out what is the description of each column. So I'll use describe, and you'll see that some columns are not describable because they are not numerical. They are actually either string or something is missing to those columns. And when you check all the information about every single column, you will see that we have some extreme values like number of components, meaning the biggest one being 7,000 something. So we need to do something to prevent that from happening, because some of the columns, okay, they're in 3, 3, 7, 7, and so on. Now duration is even going even further than that, meaning 42,000. So we'll need to normalize this data somehow, and we'll do that in a bit. Now that we have that information, let's use one more analysis point, which is called info, which will print out all the information for every single column. So some of them will be object, meaning strings, some of them meaning floating 64, and of course, here we have 3 more for object, which are strings. Okay, cool. So I have a couple of columns selected for us to explore. And before we continue, I want to explore these columns. Now, just by this, it will fail. So if you want to recognize many columns or get many columns, you need to put another set of brackets around them. And this will select all of the columns right now. Okay, so the only thing is, are there all zeros? I want to describe. And here, as you can see here, maximum 1, 3, 4, but you see that more than 75,000 of all of these columns are zeros, which is not really descriptable or describable for our data set, meaning most of the data points are same. So we don't get an extra value, we just get more computational exhaustion of this data set. So a good practice is when you have a data set that, or a column that has all or almost all of the same values as we have right now, it's a good practice to remove them because they are not adding extra value to it, so it's only the same. So now that we have that, I would love to drop or remove this data. How to do that? Well, first of all, I'll define data.drop, and instead of this bracket, I need the normal one. The list of all the columns that we're gonna remove stays the same, so we're just gonna remove this. And to find all the columns, I'm gonna use axis equals to 1. And this will shorten or create a smaller data set, meaning in number of columns. However, if you visualize or try to access all the columns again, they will be there. So we need to use inplace equal to true to make sure that this is going to be applicable to the rest of or the whole new data set as well. So when you go to data.shape, it will actually take this into account, and we don't have 43 different columns, but 39. Cool. So let's see if we have any missing values is an a dot sum. This sum assumes x is of 0, so we don't have to specify that extra. And you can see here that we have some missing values, but only one of them per column. So we're going to remove this one row. So if you go to data, drop an a, and then under drop an a, we specify axis of 1, we can check out the shape right now, telling us that we only lose or lost one entry point. But that's nice. So let's define clean data and use it from now on. Now we have all the missing values excluded, and we have all the data points that are most generic or normal or most present across all the data points, so we don't have any repetitive columns. So let's create a couple more call blocks. And now I want to explore all the data columns that are actually not numbers. So we need to see how to handle those. To access that point, I'm going to use data.select the types, and I'm going to exclude equal to mp.number. So any number I'm going to exclude and leave only object values. As you can see here, we're going to use TCP, protocol type, service, flag. Then we have a tag, which is normal, or we have a missing value here. So it's a bit weird. Yeah. But did you notice why we have this missing value? Well, first of all, I have this missing value because I stopped the upload process. That's the reason. The second reason is I used data and not clean data. So if I change this to clean data, let me do that in a second, you will see that we don't have any missing values anymore. But then we are missing another column. So did you notice what went wrong? Well, we done everything right. However, we removed almost all columns because this axis 1 actually removes columns and not rows. So for this, I want to remove only rows, and we are just missing one row, and that's fine. So everything works as intended, and that's it. Now that we have all of this straightened out and we've done the analysis process, it's time to perform some additional data cleaning. So let's continue that in the next video and start cleaning the attack or our target variable to make it more robust for our prediction. See you next video. Let's continue with our data preparation. So for now, if we go to select data of attack, which is our target or should be our target variable, and you can use unique on top of it, it will spill out all of the unique attacks or types of attacks that you can perform. Now, if you want, you can always go and create a classifier to recognize all of this independently. However, it's a really complex task, and you might not have enough data to support all of these unique cases. But if you want, I would definitely suggest you trying out after this section, because you will have all the necessary knowledge and data prepared. Only the attack variable shouldn't be a binary one, but actually multi-class classification problem. Okay, so to transform this attack variable, I want to leave normal as a normal and everything else to recognize as an attack. I don't want to recognize specific types of attack. I just want to flag the system that something's wrong. So this is the first type of alerting system that we're going to build together, which will just alert users that something might be wrong. So we have enough data for that. Now, to achieve this, I'm going to use something called mp, which is numpy.where. And this mp.where will take, first of all, a question between an array of our data and some clue or value. So this will be an attack where I'm asking where this attack is not normal or equal to normal. And this, if I just execute like this, it will just return all the pieces of array where this actually is true, which basically extract all the points that are not normal. We have quite a lot of them. Now, I'm not interested in finding the indices only. I just want to change this value to non-autark or normal. So there are two ways. I'll do the harder way, or a way that requires additional steps so we can learn. So I'm going to use attack. So that where that's correct, I'm going to switch to attack value. Where that's not true, I'm going to keep normal. And if you execute again, you will see that we have a lot of attacks or normal. That's it. The attack or normal, that's the value. Now, I want to switch the gear and replace the original attack to this. So I'm just gonna put this data of attack equal to the new value. And yeah, that's it. It works. So if you go again and call unique just below it, you will see that we have only two values, which indicates that they are normal or attack. We don't know anymore which type of attack it is. As I said, you definitely can do that by switching the gears and not doing this step. Now, as a part of our data pre-processing, we need to handle all of the data points that are considered object of strings. And if I scroll up, you will see that besides this attack, we have 3 more columns: protocol type, service, and flag. So let's do and switch the gears for that. So here I'm gonna import a new thing called sklearn.preprocessing import label encoder. This label encoder will take an array and then encode it in just basically switching from strings to numbers. And I'm gonna call it label encoder equal to label encoder, and that's it. This will run through it. And now that I have that, we can use le.fit or le.fit transform. The main difference between le.fit and le.fit transform is that fit only finds the unique values like normal and attack and is ready to switch or change the values of all the upcoming values that we put through this LE or label encoder. And on the other side, we have the fit transform, which actually learns and transforms the data immediately in the same step. So if I want to transform our protocol type, what I'm going to do is this le.fit transform of data protocol type. And when I execute this, you will see that it actually found out all the values that we need to switch here. Now, I need to run this a couple more times because we have a service, flag, and attack. So I'm going to just copy and paste 3 more times. And instead of using protocol type, I'm going to use service, flag, and finally our attack variable. Now, all of this is great, but we need to dedicate or change the value of our data. So here I'm going to switch to this, here, this, and here, this. Of course, not attack for everything. So let me switch. And here finally flag. When I run this, all of the data will be completely encoded to data types. Once encoded, you will have all of data in the data type of numbers. So if we call info again, you will see that we don't have any object whatsoever, so either integers or floating points, which is exactly what we need. And to visualize what is the influence between variables themselves, that is called correlation matrix, which basically explains on how much influence or change one variable has to another one. So I'm going to use plt.figure to increase the fig size, which is figure size, and that's going to be a huge one. So this, and then another is going to be heat map data of CORRR, which is shorter for correlation. And when I execute this, it's going to be a huge matrix of all columns against all columns. As you can see here, all the columns against all the columns. So every single column will have some indication on how much it influences another. And you will see that the diagonal, it makes sense to be 1 or close to 1, because it actually showcases that it with itself has huge correlation, which makes sense. Now, this white symbol right now, we don't really know what it means because it might be an error in our data. So potentially is host login, we might be better off removing this in the future. But for now, let's go with it. Now that we have all of the data sorted out, encoded, it's time to do 2 more things before we train the algorithm. One thing is to normalize the data points, and then we need to switch or split it to train and test parts. So to normalize all the data points, what I'm going to do is import another thing called from sklearn.preprocessing, import min, max, scalar. This scalar, min, max, scalar, if you take a look at its arguments, will take and scale any feature to be between 0 and 1. Because we have a lot of features that, for example, duration time that goes to thousands, where most are between 0 and 1. So to have everything between 0 and 1 and have the same influence to our algorithm, I'm going to scale everything by dividing the biggest with the biggest numbers with the largest number of that column. So duration will be divided by 42,000 something because that is the largest number for that column, and everything will become between 0 and 1. So to achieve this, the first thing is to extract data.drop attack, and then it's going to be axis of 1. And once I do that, I'm going to use x scaled is equal to scalar fit transform of x. Okay, so now we have our scaled data. The only thing left before we split to train and test parts is to define y, which is going to be a data of attack. And that's it. We have our y and x scaled. To import train test split, I'm going to do from sklearn.model selection import train test split. With this, we have everything. So let's define x train, x test, y train, and y test equal to train test split of x scaled and y. And we have our data, so let's check it out. We have 57,000 something times 38. So that is our training data. Now we have everything to start and learn a new algorithm called logistic regression. I know it sounds as a regression algorithm, but trust me, it's not. It's a fully classification algorithm for binary classification. We have everything so far up and ready. So it's time to learn that algorithm, train it, and find a way to finally automate the part of finding the best parameters for our algorithms. So let's do that from the next video. See you there. The next algorithm that we're going to learn in this course is called logistic regression. Besides random forest and KNN, it's one of the most popular algorithms between data scientists. And whenever you start working with some data scientists or yourself, you will have a logistic regression on your radar as a kind of an algorithm that you want tested out. So let's explore how it works and why it works so well. So logistic regression, as the name suggests, it's not a regression, but actually classification algorithm that works on predicting binary classes, meaning it's a classification algorithm and it's there to distinguish between two classes, yes or no, positive or negative. And it looks something like this. So let's say that we want to predict whether or not somebody will leave the company. So we have on the lower spectrum people that left or 0 and one that stayed in the company. and you will see that it's mixed match. So what you want to do is, based on the amount they spend from 3,000 to 180,000, that's our data set, you want to find out whether or not they're going to churn, meaning they're going to leave the company. So you will see that if they spend more, it's less likely, but still likely that they are going to leave the company. So how this works is basically we're going to take two data points, for example, 35,000 and 45,000. I think this should be higher, but let's call it like this. And we're going to take it to the line and find out whether or not it's a right decision. So we have some barrier. In most cases, it's 50-50%. So if it's above 50%, because this squishes all the values from 0 to 1, that's it, and always find a way to predict something in between. It doesn't mean that it's going to be 0, almost never, and 1. It's going to be something in between. As you can see for these 2 points, it's 42 and 81%. And now we can decide what the threshold will be. In this case, it's going to be 50%, including 50% for positive case, meaning they're going to stay, or negative case, meaning they're going to leave. So what we're going to do, we're going to measure that and find out that, hey, this is below 50, so it's going to be that. And this is above 50%, so we're going to mark it as they're not going to leave the company, which, yes, they're going to stay. I know it's a bit confusing, it should be vice versa, but hey, yeah. So one more thing, through learning, they're using something called maximum likelihood, which basically tested a lot of those curves and multiplies, sums all of the probabilities for the data points in our data set to every single possibility of a curve. And we just find out what possible curve is with the largest likelihood or largest probability when we multiply and sum all of them. And that's it. We have this line, we take a new data point, we suggest it based on the line, what's going to be 0 or 1, and we make the final prediction. Okay, so let's implement this in the code and make some predictions. Let's do that in the next video. Let's implement logistic regression in the code. So the first step is to import it from sklearn.linear model import logistic regression. Now that we have that, we're going to define LR logistic regression. And when you check the statistics here, you have a lot of things that you can change. For example, C, you have some interpolation, you have total, and stuff like that. Now, we won't change this manually because it might be a bit harder. So I'm going to just define it as it is and then use lr.fit x train y train. And finally, I'm going to use it to make predictions. So preds equal to lr.predict on x test. And you'll see that it might have some none values. So this is because of my file. So let's handle that in a second. Okay, so most of you, if you loaded the full data set, you might not have this issue, which I did. But if you did, this is the way to solve it. So x, which is our data features, fill NA 0 in place equal to true, which means that we're gonna put zeros to all the places where it might missing value. Now, this might be because of my internet or because of data transfer or upload that happened later on, but still didn't finish for some reason. So whatever might be the reason, it might happen to you as well. This is how to handle it. Now that we have our predictions, it's time to test it out. So we have preds, let's see what they are. Then we have our y test. And I'm going to use values just to compare two arrays. Then, as we did before, I'm going to sum everything up and divide by the length preds. You can use preds or y-test, whatever you want. And here it is. It's almost 98% accuracy, which is amazing algorithm for this kind of a kind of application. So with 98% of the certainty, we can predict whether or not there will be an attack to our system. We don't know with this algorithm which type of attack there might be, but that's something that you can build later on. You can first predict whether or not there will be an attack, and then from those cases, when we detect there is an attack, we can actually go and define which type of attack that might be. And that's it. We have everything set up for us. Now that we have that, it's time to test something else, which is called grid search. Grid search is there to find out what type of logistic regression algorithm, with all of the things that we can provide to it, is the best suited for this data set. So it might be that some parameters will yield even 99%. We don't know. I'm not certain that we're going to improve this score because it's really good, but let's test it out and learn how to improve our algorithm. So let's do that in the next video. In the previous section, we did explore with multiple configurations of our algorithms. For example, with key nearest neighbors or k nearest neighbors, we tested with different configuration of neighbors or k. Now with random forest, we tested with multiple configuration of how many decision trees we want to have in that algorithm. Now, every single algorithm in machine learning will have some sort of tests or things that we can actually change or tune to perform better. It doesn't mean it will, but we can. And in this case as well, we have our logistic regression that has a multiple parameters that we can play with. Now, of course, we can do it manually, but once we have multiple configurations or tests, especially when we are not testing only, for example, n of nearest neighbors, but multiple configurations or multiple parameters, it becomes really messy and you want to automate this process as much as you can. And for this process, we are using something called grid search. This whole process is called hyperparameter optimization. So any algorithm out there might have at least one parameter or hyperparameter that we need to set before we start training the algorithm. So to do that, we're going to use from sklearn.model selection, import grid search CV. So grid search is basically taking something like this, which I just created offline. So it's called parameters grid, or you can name it whatever you want. It's a dictionary. Every key is a name of a thing that you can change for a certain algorithm. So this is configuration for our logistic regression. It has two mostly or most commonly changed parameters for the algorithm. One is C, which stands for a value usually used to scale the whole algorithm. And then you have penalty. One is L1, which is lasso, and L2 meaning ridge. So these two will decide which parameters or which columns features are not really useful and just turn them off. So we won't use that as a final decision, and it's really useful. And now we're going to execute that and start potentially defining that in a grid search. So our GS CV is going to be grid search CV. And this CV, don't worry for that for now. I'm going to teach you what it is in a second. Then I'm going to provide LR, and param grid is param grid. And the last thing is CV equals to 5. Okay. Once you define that, you potentially want to define a clear or new algorithm just to have everything in the same spot. So logistic regression. Okay. And if you define it, it's time to train. But before we do so, I want to teach you this CV part. CV stands for cross-validation. Cross-validation is a way to determine, is your algorithm really performing as good as you might think? Because for now, we used train test split. We are testing it or training it on a single part and testing on another one. That might be an amazing solution for some cases, but we might not be as certain as you might think. So CV or cross-validation will split our dataset into n parts, in this case 5. and it will train for 5 different times, meaning every single time one of those parts will be put aside for testing, and 4 other, in this case 4, because we have 5 here, will be used for training. And it will go around and use every single part of a data set for training purposes or testing purposes. And now that we have that sorted out, let's call GSCV dot fit on X train, Y train, and it will take a bit of a time to do that because you have multiple combinations, and for every single combination it's going to take about 5 trains to complete. So it might be a couple of seconds or a couple of minutes depending on your configuration. This one, it might take a couple of minutes for me. And here we are. If you take a look, we have normal logistic regression. So let's take a look at best parameters. So GSCV dot best params to find out what is the best parameters. As you can see, C of 100 and penalty of L2. And amazing, that is our parameters. If you want to get the best algorithm, it's called best estimator. That is our logistic regression. So what I can do for here is predict on X test and define preds new. And we know what was the final score. Let's scroll up here, but instead of these preds, let's change to preds new. Okay, so here and here, and we have 97.67. So we did actually improve, but not as much as you might think, because we are really close to 99% of accuracy. But we still improved and maybe made it more consistent. Okay, and that's it. This is how to find the best set of parameters automatically without actually trying by hand all sorts of information that you might think will fit to your need. With this simple method, with a couple of minutes down the training, we actually found the best set of grid or best set of parameters for our logistic regression use case. How amazing is that? And we didn't test it by hand whatsoever. Okay, that's it for this section. Let's explore further of where AI can help with cybersecurity. See you in the next video.
We can safely say that malware is one of the biggest threats on the internet, right next to phishing attacks. Malware, short for malicious software, refers to any software designed to harm, exploit, or compromise computer systems. I bet every single one of us at one point in time got infected with malware and possibly spent hours trying to remove one from your system. Well, that is how annoying they can be. The problem is that they are not only annoying most of the time, but can actually be very dangerous. There are many types of malware, and to properly define all malware types together, we can say that at its core, malware is a broad term encompassing any software specifically crafted to cause harm, exploit vulnerabilities, or compromise the integrity of computer systems. Malware operates with a diverse range of objectives, from stealing sensitive information and financial data to disrupting normal system functions or facilitating unauthorized access. But it's important to note that not all malware types are equally dangerous or do the same thing once infecting a device. So let us take a look at what types of malicious softwares exist. First, we have viruses. A virus is a type of malicious software designed to replicate and spread to other computer systems, often with the intent of causing damage, stealing information, or disrupting normal operations. Some of the key characteristics of viruses are replication and attachment. Viruses have the ability to replicate themselves, creating copies that can spread to other files, programs, or systems, as well as they can attach to executable files or documents. Besides viruses, we have worms, and worm is simply just a malicious software that operates independently, spreading across computer networks and systems. Now, unlike viruses, Worms don't need to attach themselves to host programs or don't need other files to propagate. Instead, they are standalone programs designed to replicate and spread autonomously. Usually, worms move into other networks and devices by exploiting vulnerabilities in network protocols and operating systems. Now the one that you most likely have heard about already, and that is Trojan. Trojans are disguised as legitimate softwares in order to deceive users into installing them, which essentially grants the attacker unauthorized access. There are different types of Trojans, depending on what they are used for, but the most common and possibly most dangerous ones are backdoor Trojans. This is because they can either load all sorts of malware onto your system in their role as a gateway, or at least ensure that your computer is vulnerable to certain attacks. A backdoor is often used up in botnets. Now, botnets are just a group of infected computers, and each of those computers is referred to as a zombie. So, without your knowledge, once infected with Trojan or backdoor, your computer becomes a part of that zombie network, which is then later used for further attacks. The next one that we want to talk about is ransomware. Now, ransomware attacks are on the rise in the last few years, and they're infamous for encrypting files and demanding ransoms. Now, ransomware poses a substantial threat to data security. Usually the ransom is required to be paid in crypto, and once you pay your ransom, your files will be decrypted. However, there is no guarantee that they will indeed be decrypted. You might just end up losing both money and files. This leads us to the next malware, which is called rootkits. Now, rootkits are arguably one of the most dangerous malware, as they bury deep inside of your operating system, and in many cases they go undetected. The reason they go undetected is because once inside the device, they can deactivate anti-malware and antivirus software. Rootkits typically enter devices and systems through phishing emails and malicious attachments. And let's not forget about the probably most interesting one, which is keylogger. A keylogger is simply just a surveillance malware that monitors keystroke patterns. Now, threat actors use keyloggers to obtain victims' usernames and passwords and other sensitive data. Now, similar goal also has a malware called spyware, and spyware is a malicious software that is used to collect sensitive information without user awareness. Spyware can track credential and obtain bank details and other sensitive data. It infects devices through malicious apps, links, websites, and email attachments. Okay, we listed quite a few different malware types, but guess what? There are more. However, these are the most common ones out there and the ones you should be familiar with, so we will just stick to knowing these. Now that we know what malware is and what actions different types of malware perform, let us shift our focus on their detection, which is the most important part for us. See you in the next lecture. Remember, detecting malicious software is a game of cat and mouse. Hackers create undetectable malware, and cybersecurity experts and antivirus vendors work on updating their systems in order to detect that new malware. And it pretty much goes like this in circles. So let's talk about the traditional ways that we used to detect malware for decades and that we still use. The number one prevention method to not getting infected with malware is to have basic cybersecurity knowledge and to always be cautious on the internet. Every file, every attachment you download, triple check it if it's safe to download and run before you actually run it. Matter of fact, you actually want to avoid clicking on links overall or downloading attachments unless you truly need to. This will keep you away from most of the malware online. Now, other than that, you want to keep all your applications and your operating systems up to date. Having outdated software running on your machine or not patching your operating system is just asking for malware to come and infect you. Malware can infect your machine through various exploits, and these exploits attack through a vulnerability in your software or operating system. If you don't patch it, you will allow that exploit to work and deliver malware to your machine, so make sure that you always have everything patched and up to date. Another measure which you are 99% familiar with as a protection against malware is the usage of antivirus or anti-malware software. Here, you pretty much can't go wrong. Just make sure to pick a well-known and trusted vendor. However, people make a mistake here and get comfortable after installing a good antivirus. In reality, the first two steps we mentioned for protection against malware are more efficient than the antivirus itself. Remember, hackers constantly update their tools, so even with antivirus software, if you don't pay attention to what you download, it will be just a matter of time before you get infected. Firewall will also be a good protection method against malware, since if it has a strict rule set, it might prevent malware from running or contacting the command and control center which it communicates with. Other protection measures which you want to implement as well include implementing strong access control, always requiring at least two-factor authentication, but even better would be multi-factor authentication. You want to use the principle of least privilege, which essentially means you should not have more privilege to do a certain task than you actually need to. So, for example, if you need to download a tool, you wouldn't use a root account on Linux if you can download the tool with a simple user account. Using higher privilege than needed is just calling for trouble. And fourth thing that we want to do is regularly monitor for abnormal or suspicious activity. Okay, but what do these tools like antiviruses even do? We know they are used for detecting malware, but how exactly? There are several techniques and approaches used in malware detection, which are often combined to enhance the effectiveness of the overall security system. Here are some of the common methods. We have signature-based detection. This method involves creating and maintaining a database of known malware signatures or patterns. When a file or program is scanned, its signature is compared against the database, and if a match is found, the file is flagged as malware. The signatures are usually in hash format, and the hash uniquely identifies the specific malware. Now, besides signature-based detection, there is also heuristic-based detection, and heuristics involve analyzing the behavior of a program to determine if it exhibits characteristics typical of malware. This method doesn't rely on specific signatures, but instead looks for behavior that might indicate malicious intent. For example, if a program tries to access a large number of files rapidly or exhibits polymorphic behavior, which means to change its code in order to evade detection, it may be flagged as potentially malicious. We also have sandboxing, and sandboxing involves just running suspicious files or programs in an isolated environment to observe their behavior. If the program exhibits malicious behavior in the sandbox, it will be flagged as malware. Let's also not forget the network-based detection, which is essential because many malware communicate over the network. That is why network-based detection monitors network traffic in order to discover patterns associated with any type of malware communication. It might be just backdoor to command and control center, it might be malware initiating a flooding attack. All of those traffic can be scanned over the network and blocked. And the last one that is probably most important for us for this course, which is machine learning detection. Machine learning algorithms are increasingly being used for malware detection nowadays. These algorithms are trained on large datasets of both malicious and non-malicious samples. Once they are trained, the system can identify patterns and anomalies in new files or behaviors, making it effective against previously unknown threats. And since we are doing a course on AI in cybersecurity, we will be creating a project which will make a tool that will utilize machine learning to detect malware. Alright, those would be some of the methods that are used to successfully detect malicious software. But I will mention for the third time that in the ongoing battle between cybersecurity defenders and malicious actors, knowledge is our strongest ally. Understanding the nature of malware and the intricacies of detection mechanisms allows individuals and organizations to navigate the digital landscape securely. Now, by adopting a proactive stance and by staying informed about emerging threats and leveraging the latest in the cybersecurity tools and techniques, we can collectively fortify our defenses against the ever-evolving threat called malware.
In this section, we will apply everything that we learned so far, from data loading to testing multiple algorithms, comparing which one is the best per our metrics, and then choosing the best algorithm to go with. In this section, we will apply all of that to a new problem called malware detection. So we'll use a data set that has monitored a couple of files and detected some of them being a malware, and the goal of our system should be to analyze all of that information about each of the files and detect which one is considered to be malwares and which one is the normal one. So when you open the workbook that is listed and linked to this very lecture in the resources, create a copy out of it. And here, the first step is to execute and import all the data or all the imports that we use so far from NumPy, Pandas, Seaborn, Matplotlib, traditional ones, and immediately I imported metrics and train test split. The dataset can be found on the link right here or the same link that is listed in the resources of this video. And of course, we downloaded this file directly from the Kaggle, so you don't have to download yourself or create an account if you don't want to. This dataset has a simple explanation of what it is, but if you scroll down, you will see the full dataset. It has a lot of columns. Unfortunately, we don't have many of the explanations for each of the columns. And if you go here, you will see that there are 79 different columns about a lot of information about each of the data. And you have two files, one called dataset malwares, which we're going to use, and another one which is dataset test, which we don't want or consider using at this stage. So it started from the file ID or name, analyzing every aspect of the file, and there are many things that we can actually analyze about this file. So if you're a researcher and malware detection expert, I definitely want your thought and analyze the whole data set if you want to get further insights about the whole sense of it. And the final column is malware, meaning 1 being a malware, or 0 meaning it's not a malware. And we have 0, 5,000 and something examples, and 14,000 meaning malware, or 15,000 actually, meaning it is actually a malware. And we are trying to predict that one. Now, there are a lot of columns that we can use. So let's load this dataset to our work file and start working with it. As always, the first step is to upload the file. So what I'm going to do is upload the new file called dataset malwares, which you can find in the resources of this video. Click OK, and it will take a couple of seconds to upload the file. Now that you have that file uploaded, it's time to load. While that happens, I'm going to write data is equal to pd.read CSV. And here, what I'm going to do is define dataset malwares.csv. Execute the line, and the dataset is loaded. Now that I have that, I want to check the shape. So the shape of this is 19,000 examples, almost 20,000, that are either malware or normal files. And then 79 columns, which is quite a lot. So we definitely need to remove some of them. For example, name, we unfortunately can use the name. So data.head, just to see the first couple of lines, you will see that there is a lot of columns that we definitely explored through Kaggle as well. Now that we have our dataset loaded, it's time to do some data analysis on top of it and prepare it for machine learning predictions. And I'll tell you where I think you, as a researcher in this space, or you want to learn more about this space, you want to visualize it in a better way, explore each of the columns and find out more about the dataset. So stay tuned for that, and let's go to the next video where we start exploring the dataset. Let's continue with our data analysis and pre-processing step. The first step, as always, will be to check data info. So it will tell us whether or not we have some null values and what is actually the type or data type of these columns. A lot of them are either float 64 or int, but we have a couple of them being an object. Now we have a couple of problematic values or columns that we're going to explore in a second, but this is the first step only. After that, what I'm going to do is data.describe to see the distribution of all the columns we have. Now, unfortunately, we can't visualize all of them, but one thing that you will see that maximum value varies a lot, where this maximum value here is 0. Now, section main char is all 0, so we're definitely going to remove that one. And this one is 588, this one is 4000, and so on. So definitely not the best data set, and we will need to work a lot on top of it. And if we go and visualize these 3 columns, you will see that we have machine that is almost all the same, and we have time data step that is just a huge number, which we need either to remove or process a lot. For now, we'll just remove it. And I want to find this column here that I will remove as well, because they're all zeros. So here, I'm going to add this one. And that's it. We have our 4 columns that I would like to remove. So to do that, I'm going to use drop. And here, I'll add this to the column, x is 1, and then in place equal to true. This will remove unnecessary data points or features. And then the next step is to visualize the malware. So malware is our target. And if I use hist, which is histogram, you will see that there is a discrepancy between these two. For now, this is okay. Definitely we need to think about ways to handle this, either remove some of them, oversample some of them, meaning create artificial examples, but because this data is so noisy, anything we do will create even more noise. So the first iteration before balancing this data set will be to train the algorithms as it is, and then decide later on if we need to improve it. Now, we need to find out, before we continue with the training algorithms, a couple more steps for processing. The next step is from sklearn.preprocessing, import min max scalar. And we're going to define scalar is equal to min max scalar. That's going to be our data. So features are going to be data dot drop malware, x is 1, and then I don't know why did I copy, targets is equal to data set or data of malware. Okay, so we collected that. It's time to normalize this by using features scaled is equal to scalar dot fit transform of features. It will scale our features, and we're quite ready. Now, the next step is to split it into training and test parts. And I think we have that train, test, split from the above. So we're going to use feature scaled, and then targets, and test size, let it be 20%. We're going to use one more thing though. Because we have this distribution of data, meaning that it's imbalanced, we need to make sure that in the test part and the training part, we have the same balance or the same distribution of our targets, which is quite a lot of difference. So to achieve this, what I'm going to do is define something called stratify. And this stratify will take our targets to follow along. And it's going to return as before, xtrain, xtest, ytrain, and test. And this stratify will make sure that distribution of our targets in Y train and Y test stays the same as we did right here. Okay, we didn't do quite a lot of data processing, but I want you to continue in my steps. We've done quite a lot of analysis, visualization of data, correlation, and stuff like that. Before you continue with machine learning algorithms and exploring it, as a homework, I would like you to explore all the solutions they have here under code and find the best visualization and create your own data analysis of all the features inside of dataset. Because there might be gold and amazing dataset to start working on something bigger. So before you continue just applying a machine learning on top of it, I would like you to step back and explore the whole dataset, start researching online on what other people did. When you're done and you want to continue, let's restart and go from the next lecture where I'm going to apply a couple of machine learning algorithms to test what works the best for our system. So see you in the next video. Whenever we start working on a machine learning project, you will explore with multiple algorithms that you have or know in your toolbox. So you will test all of the cases, starting from the most simple one to more advanced ones, to test out which one works the best for your use case, and then later optimize it even further if needed. And so far we learned 3 amazing algorithms, and I want us to try all 3 of them on this data set to find out which one actually performs the best for this application. So this is the right way or the approach that most data scientists will do when they are tackled with a new data set. So the first step, we'll need to import all those algorithms. So from sklearn, I'm going to import first linear model, import logistic regression. After that, I'm going to import from ensemble, import random forest classifier. And from sklearn, neighbors, import k-nearest classifier. All the algorithms that we know. Then I'm going to start from the simplest one. So always start from the simplest one. Here, we'll start from key neighbors, then random forest, and then finally logistic regression. So knn equal to k nearest neighbors classifier. I'll keep all the default settings for the first pass. Knn fit x train y train. And then we're going to make predictions, accuracy, score, immediately y test, and then here knn.predict on x test. So let's see the accuracy, 97%. Amazing. Okay, so knn, the simplest algorithm, works really well on our data. So let's explore for random forest one. So I'll define RFC, random forest classifier, with default settings, rfc.fit, xtrain, ytrain, and then use the same code here, but RFC here. Okay, it's trained. Let's make predictions. 99%. Amazing. So for now, it works the best so far. And the last algorithm to test out, we can stop here because we are pretty much done, but let's make another prediction. So I'll make LR is equal to this, and this is all with the simplest configuration without changing anything. So, which is really interesting. Fit xtrain ytrain, and then I want to make prediction on this as well. So it's going to be LR 96%. Okay, so knn and logistic regression are quite similar, and the best one is our winner one is RFC. Now, if you want, you can apply grid search on top of it and find the best algorithm that is suited. But for now, we don't have to because we have amazing algorithm now. Okay, now that we have our algorithm, let's learn how to save it so we can reuse it later on when we are ready to deploy. So let's do that in the next video. Saving the trained algorithm is really important and crucial step. Once you are done and satisfied with your results, it's time to prepare that algorithm so you can actually use it later down the road when you're ready to deploy that algorithm to production. And for this, we're going to use something called Pickle. We're going to import Pickle. Pickle library will allow us to save our algorithm into binary files so we can reload it later when we are ready to start predicting. So the first step is to define model file, which will be our malware predictor dot pickle, like this. Now, when we have that and we have our model, we're going to define with open model file, which is this, then write binary as file, and here I need to define pickle.dump, and for the object, we're going to take our RFC file. And when you check it out, here is our model predictor. Now, one crucial information is this. We normalized our data. So because we need to replicate everything we did in production, we need to save this as well. So the new data that comes our way, we need to run through this scaler to make sure that the new files and new data is actually savable as well. So here I'm going to define scaler file is going to be malware scaler.pkl with open scaler file like this as file pickle.dump scaler and then file. So we use this scaler, which we trained right above here, and we know all the mean, all the statistics of our data that we can translate later down in the road when we start predicting. And here it is. We have our model and our scaler saved that guarantees or helps reach 99% accuracy on our test data. How amazing is that? The loading is really simple with pickle.load, and instead of this, you can use read binary to load the whole file. So for example, let me show you. Loading saved model. I'm going to use this. So read file, and I'm going to define RFC loaded pickle.load file. And if you check out, this is our random forest. How amazing is that? And you can run predict anything we just loaded out. Cool. And that's it. We built a fully functional malware detection system that we even compared a couple of algorithms and trained it on our data, tested out and saved the best model so we can reuse it later in production. Okay, let's continue learning. See you next video.
Welcome back. It is time we dive deeper into vulnerabilities and security threats when it comes to AI and machine learning. To start it off, we will focus on one of the most common attacks which some of you might have heard about, and that is AI poisoning or data poisoning. An AI poisoning attack occurs when an AI's model training data is intentionally tampered with, affecting the outcome of the model's decision-making process. In the data poisoning attack, adversaries inject malicious or misleading data into the training dataset. The attacker introduces small modifications which can taint the learning process, creating bias and causing the incorrect outputs or faulty decision making from the AI model. So we can simply say that the steps of data poisoning go like this. We have the first step, which is the injection of malicious data. Here, adversaries introduce carefully crafted data points into the training set. These data points are designed to influence the model's learning process negatively. The second step is manipulating the model's behavior, so the injected data points can distort the model's understanding of the underlying patterns in the data. This can lead to biased or incorrect predictions during both training and deployment. And the third part is impact on model performance. The poisoned model may exhibit unexpected behaviors such as misclassifying specific inputs, making incorrect predictions, or simply just becoming more easily impacted to adversarial attacks during deployment. Okay, now some of the real-life examples of using data poisoning would be, for example, in spam filtering. In a spam filtering system, an attacker could inject a significant number of legitimate emails into the training data that is labeled as spam. This can pretty much cause the model to become less effective at distinguishing between the spam and legitimate emails. Now, data poisoning can also be done in image recognition models. In a model trained for image recognition, an adversary might inject images of a specific object with incorrect labels. For example, labeling images of cats as dogs during training could lead to misclassification in the deployed model. Another example of data poisoning would be in fraud detection. So in a fraud detection system, an attacker might introduce examples of legitimate transactions labeled as fraudulent. This could lead the model to become less accurate in identifying actual fraud, as it may learn patterns associated with normal transactions. Alright, you get the point. Data poisoning can be a real problem. But now comes the important question. How do we prevent or protect against it? Well, there are several steps we can take. There are certain defense mechanisms which we could implement. These defense mechanisms include things like robust model training, which is implementing robust training practices such as outlier detection and data validation, which can help identify and mitigate the impact of poisoned data. We have data quality checks, which refers to regularly monitoring and validating the quality of training data, which can then help detect anomalies or suspicious patterns that may indicate the presence of poisoned data. Adversarial training is also important, as training models using adversarial examples can enhance their resilience against data poisoning attacks by exposing them to deliberately manipulated data during the training process. And last, we have anomaly detection techniques, which is leveraging anomaly detection techniques that can help identify unexpected patterns or outliers in the data that may be indicative of data poisoning. Alright, that was pretty interesting. Now, we know what data poisoning is, what effects it has, and we also know some ways of how we can protect ourselves against data poisoning. Now let us move on to the next lecture, where we will talk about data bias. See you there. Welcome back. Let us talk about data bias. Last lecture we focused on data poisoning, and we can say that data bias does have similarities with data poisoning. So let us define it first to show you what I mean. We can say that data bias refers to the presence of systematic and unfair distortions in a dataset that can lead to inaccuracies or unfairness in the outcomes of machine learning models. Bias in data can arise from various sources, including historical inequalities, sampling methods, or data collection processes. When not properly addressed, data bias can result in discriminatory or false predictions, reinforcing existing disparities and creating ethical concerns in AI applications. Now, some of the sources or reasons as to how data bias can occur would include things like historical biases, for example. So if the historical data that is used for training models reflects existing biases or inequalities, the model may perpetuate and even intensify those biases in its predictions. We also have sampling bias, which stands for incomplete or non-representative sampling of data, which essentially leads to bias. If certain groups are underrepresented or overrepresented in the dataset, the model may not generalize well to the entire population. We also have labeling bias. Now, biases can be introduced through the process of labeling data. Human annotators may accidentally inject their own biases, leading to exaggerated interpretations of the data. And we also have algorithmic bias. Now, bias can also be introduced by the algorithms themselves, particularly if they are designed or trained in a way that disproportionately impacts certain groups. So, by knowing this, we can safely say that data bias occurrence is quite high. But what steps can we take to mitigate these threats? Well, there are plenty of measures we can take. These include having diverse and representative data. We must ensure that training data is diverse and representative of the entire population to reduce the risk of biases related to underrepresented groups. We should also have bias detection and evaluation by implementing tools and techniques to detect and evaluate bias in both the training and testing datasets. This involves analyzing the data and model outputs for disparities across different demographic groups. Now, ethical data collection means that we should follow ethical practices in data collection, labeling, and annotation to minimize the introduction of biases at the source. To have algorithmic fairness is to incorporate fairness considerations into the design and training of machine learning models. This may involve adjusting algorithms to mitigate biases and ensure fair treatment. And lastly, transparency and explainability. We must make efforts to understand and communicate the decisions made by AI models. Transparent and explainable models enable stakeholders to identify and address biases more effectively. As you can see, the solutions exist. But in reality, we can expect data bias to continue being a thing for the simplest fact that it is a part of human nature to be biased about something. However, if proper control is implemented, we can remove data bias almost completely. Addressing data bias is essential for building ethical and fair AI systems. By taking proactive measures in data collection, model development, and evaluation, the negative impact of biases can be mitigated, promoting more fair and reliable AI applications. Okay, we already mentioned some of the model vulnerabilities, like, for example, data poisoning, but there are others as well, so let's talk about them too. First, let's mention prompt injections. Prompt injections involve bypassing filters or manipulating the large language model using carefully crafted prompts that make the model ignore previous instructions or perform unintended actions. Common prompt injection vulnerabilities include bypassing filters or restrictions by using specific language patterns or tokens, exploiting weaknesses in the model's tokenization or encoding mechanisms, and misleading the large language model to perform unintended actions by providing misleading context. An example of an attack scenario is a malicious user bypassing a content filter by using specific language patterns, tokens, or encoding mechanisms that the model fails to recognize as restricted content, which essentially allows the user to perform actions that should be blocked. We saw an example of prompt injections once we covered bypassing ChatGPT filters. Now, besides prompt injections, we also have data leakage. Data leakage occurs when a large language model accidentally reveals sensitive information, proprietary algorithms, or other confidential details through its responses. This can result in unauthorized access to sensitive data or intellectual property. It can also result into privacy violations and other security breaches. Now, some preventative measures that can be taken against data leakage are implementing strict output filtering and context-aware mechanisms to prevent the large language model from revealing sensitive information. You can also use different privacy techniques or other data anonymization methods during the model's training process to reduce the risk of overfitting or memorization. And let's not forget that we should always regularly audit and review the model's responses to ensure that sensitive information is not being disclosed unintentionally. Now, next up, we have unauthorized code execution vulnerability. Unauthorized code execution occurs when an attacker exploits the large language model to execute malicious code, commands, or actions on the underlying system through natural language prompts. Common vulnerabilities include non-sanitized or restricted user input that allows attackers to craft prompts that trigger the execution of unauthorized code, insufficient restrictions on the model's capabilities, and unintentionally exposing system-level functionality to the large language model. To prevent this, the developers have to prioritize implementing strict input validation and sanitization, as well as ensuring proper sandboxing and restricting the model's capabilities to limit its ability to interact with the underlying system. Remember, this is not just a problem for AI models. This is a rule for any software that is coded which interacts with the client. You must filter user input, otherwise the user might be able to execute code inside of your application. That itself is a critical vulnerability. Okay, now the next model vulnerability that we will discuss is rather interesting, and it is called inadequate AI alignment. Inadequate AI alignment occurs when the large language model's objectives and behavior do not align with the intended use case, leading to undesired consequences or vulnerabilities. If you remember those movies where AI takes over the world because it started listening to itself and doing things that it shouldn't, well, that would be a theoretical example of this. Of course, that is nowhere near to be happening right now, but you get the point. Developers can prevent inadequate AI alignment vulnerabilities with certain actions like defining the objectives and intended behavior of the model during the design and development process. They can also ensure that the reward functions and training data are aligned with the desired outcomes and that they do not encourage harmful behavior. And lastly, make sure to regularly test and validate the large language model's behavior on a wide range of scenarios, inputs, and contexts in order to identify and address any alignment issues if they are present. And last model vulnerability that we will talk about is over-reliance on large language models generated content. Now this is an interesting one, because it does not directly refer to the actual model, but rather to the people that use this model. Organizations and users may trust models generated content without verification, leading to errors, miscommunications, or unintended consequences. Common issues related to over-reliance on large language models generated content include accepting the model's content as a fact without any verification whatsoever. This essentially means that they are assuming that the content that model generated is free from bias or misinformation, and they might end up relying on that content for critical decisions without any human input or oversight. For example, let's say a user in a company relies too much on the large language model to generate security reports and analysis. And let's say that model generates a report containing incorrect data which the company then uses to make critical security decisions. There could be significant repercussions due to reliance on inaccurate models' content, which could result in, for example, company getting hacked because they used incorrect security configurations provided by the model. Alright, you get the point. Don't trust these AI models for now, as they are known to sometimes give incorrect information, and that could cause some issues depending on how that information is processed. Always double check it with a different source to make sure. Nonetheless, These would be some of the common model vulnerabilities and security threats that you might encounter. Now that we got that out of the way, let us talk about ethical concerns of AI in the next lecture. Alright, we have to talk about the yin-yang of artificial intelligence. As much as there is good stuff when it comes to AI, there is also a bad side to it. The rapid advancement of artificial intelligence and machine learning technologies has raised significant ethical concerns. As these technologies become an integral part of various aspects of society, it is crucial to address the ethical considerations to ensure responsible development and deployment. Let's list out some of the key ethical concerns regarding AI and machine learning. So the first thing we already talked about, and that is bias and fairness. AI models learn from historical data, and if the training data contains biases, the models can perpetuate and even make those biases worse. This can lead to unfair outcomes, particularly when it is applied in, for example, hiring, lending, or law enforcement. Another one is transparency and explainability. Many AI and machine learning models operate as black boxes, which makes it a challenge to understand how they arrive at specific decisions. Lack of transparency and explainability can lead to a loss of trust and hinder accountability, especially in critical applications such as healthcare or criminal justice. Of course, when talking about AI, there is always privacy concern. AI systems often require vast amounts of data for training and operation. The collection and use of personal data raises concerns about privacy, especially when individuals may not be aware of how their data is being used or when it is used without their explicit consent. Autonomy and decision-making are another important thing. Since the deployment of AI in autonomous systems such as self-driving cars or military applications raises questions about the level of autonomy given to the machines. Ethical considerations include accountability for the decisions made by the autonomous systems and the potential for unintended consequences. For example, what if the self-driving car crashes? Who is responsible for that? And perhaps the topic that most people are currently worried about is job displacement and economic inequality. The widespread adoption of AI and machine learning has the potential to automate certain jobs, leading to concerns about job displacement and economic inequality. It is crucial to consider the societal impact and develop strategies for retraining and upskilling the workforce. There are always security risks as well, since AI technologies can be exploited for malicious purposes such as creating deepfakes, running cyber attacks, or generally just manipulating the information. Now, ethical considerations would include developing safeguards to prevent misusing the AI models and establishing clear guidelines for responsible usage of these models. Let's not forget the user consent or informed consent, since users may not always be fully informed about how their data is being used in AI applications. Ensuring informed consent, especially in sensitive areas like healthcare or biometric identification, is essential to respect individuals' rights and autonomy. And lastly, we have accountability and liability. Determining accountability for decisions made by AI systems is a complex issue. Establishing a clear alliance over responsibility and liability is essential, especially in situations where AI systems have significant impact on individuals or society. Okay, so these would be some of the ethical concerns that everyone should pay attention to and be aware of. Addressing these ethical concerns requires collaboration among policymakers, technologists, as well as the broader community. Establishing ethical guidelines, promoting transparency, and fostering a culture of responsible AI development are crucial steps towards ensuring that AI and machine learning technologies benefit society while minimizing potential harms. Welcome to this small section where we will cover the basics of cybersecurity. Now, this is an appendix section for anyone who was not introduced to cybersecurity before. In this section, we will talk about the evolution of cybersecurity through the past few decades, as well as mention some common cybersecurity tools and strategies. We will also talk about the most common cyber attacks out there and some of the best practices to protect against them. So let us first start by talking about evolution in cybersecurity throughout the last few decades. We can say that evolution of cybersecurity is a fascinating journey that mirrors the rapid advancement of technology and the increasing digitization of our lives. It has evolved from relatively simple measures to protect isolated systems to a complex and dynamic field that is continually adapting to new threats. In the early days of computing, cybersecurity was virtually non-existent. Computers were isolated, and the concept of network systems has not yet emerged. Security primarily involved physical protection and access controls such as locked rooms and restricted access to the machines. Due to the internet not existing yet, people didn't really worry much about someone else stealing their private data, which was only possible if a person physically stole the device or transferred the data. Now, as computers became more interconnected in the 1960s and 1970s, the first hackers emerged. These early hackers were often motivated by curiosity and sought to explore the limitations of computer systems. Security measures were still rudimentary, and there was little awareness of the need for comprehensive cybersecurity. The 1980s saw the rise of computer viruses and malware. So, for example, we have the Morris worm, which was one of the first notable computer worms, which used to expose vulnerabilities in interconnected systems. The worm only targeted computers running a specific version of Unix operating system, but it spread widely because it featured multiple vectors of attack. For example, it exploited a backdoor in the Internet's electronic mail system and a bug in the Finger program that identified network users. It was also designed to stay hidden. This led to development of the first antivirus program and the realization that software vulnerabilities need to be addressed. The 1990s marked a significant shift with the commercialization of the internet, and as businesses and individuals flocked to the World Wide Web, the attack surface expanded dramatically. This specific era saw the development of firewalls, intrusion detection systems, and the first comprehensive cybersecurity frameworks. This is the time where everyone understood that real damage can be made by hacking and that it is wise to invest in higher security, especially with the introduction of e-commerce and online financial transactions, since cybercriminals turned their attention to exploiting these opportunities. Phishing, identity theft, and credit card fraud became widespread issues, prompting the development of stronger encryption and authentication methods. The 2000s brought about a new breed of threats known as advanced persistent threats. These sophisticated attacks often involved nation-state and targeted specific organizations for espionage or data theft. The cybersecurity industry responded with more advanced threat detection and mitigation technologies. One of the most famous advanced persistent threats from that period was a worm called Stuxnet. Now, Stuxnet is a computer worm that was originally aimed at Iran's nuclear facilities and has since mutated and spread to other industrial and energy-producing facilities. The original Stuxnet malware targeted the programmable logic controllers or PLCs, which were used to automate machine processes. It generated a flurry of media attention after it was discovered in 2010 because it was the first known virus that was capable of crippling hardware and because it appeared to have been created by the US National Security Agency, the CIA, and Israel intelligence. Later in 2010, the Internet of Things devices presented new security challenges. The explosion of connected devices led to the creation of new standards and best practices for securing these technologies. More and more breaches in companies were made through hacking an IoT device, which resulted in more security measures taking place. Also, as businesses moved their operations to the cloud and adopted virtualization, cybersecurity had to evolve to address new risks and vulnerabilities. Security as a service and cloud-based security solutions became essential for protecting cloud-based assets. And right now, in the current time, cybersecurity is also facing both an enemy and a new friend, which is artificial intelligence. Machine learning and artificial intelligence are now being integrated into cybersecurity tools to enhance threat detection and response. These technologies enable faster and more accurate identification of suspicious behavior and patterns. However, AI can also be used for cyber attacks and making cyber attacks themselves more efficient. That is why in this course we will cover everything you need to know about the implementation of AI in cybersecurity in this current age. We will talk about the usage of ChatGPT, how it can be used for both good and bad, and we will also talk about different attacks on machine learning models, and we will show several coding projects where we will create our own AI tools for cybersecurity. So stay tuned for that. Alright, those will be some of the most important things that happened in cybersecurity throughout the last few decades. Or in other words, what we mentioned in this video is just the important turnarounds in history when cybersecurity strategies and implementations changed drastically. But what can we expect in the future? Well, we can't say with certainty, but looking ahead, the future of cybersecurity will involve advancements in quantum-resistant encryption, improved cybersecurity for IoT devices, and the development of more proactive, predictive cybersecurity measures. Additionally, as AI and machine learning continue to mature, they will play a significant role in cyber threat mitigation. Alright, now that we talked briefly about history of cybersecurity, let us focus on the most common cyber attacks and threats in the next lecture. Welcome back. There are many different cyber attacks out there, and if we were to talk about each of them in detail, that could be an entire course on its own. Since we want to mainly focus on AI implementation in cybersecurity in this course, we're only going to mention the most common cyber attacks out there in this lecture. And we will start off by talking about the number one attack out there on the internet, which is phishing or social engineering. Now, it is not surprising that the most common cyber attack actually involves hacking people and not the machines. Remember, people are always the weakest link. You can have the most technically secure system in the world, but if you click on a random link or download random attachment file, then it is all over. Your system is compromised. But how can we define phishing? Well, we can say that phishing is a social engineering attack where cybercriminals trick individuals into divulging sensitive information such as usernames, passwords, or credit card details. Phishing attacks often involve deceptive emails, fake websites, or messages posing as legitimate entities. While it is most common that phishing emails generally seek your credentials through fake web pages, phishing emails can also have attachments linked with malicious software waiting for you to download it and run it. This leads us to the next most common cyber attack or way of compromising a system, and that is with a malware. Most of you already know what malware is. Malware is a malicious software that is designed to harm or exploit computers and systems. This category includes viruses, worms, trojans, ransomware, spyware, and others that are less common. Malware can be delivered through infected email attachments, malicious websites, or compromised software. It can also be delivered manually through a USB device. Now, I'm pretty certain that all of us at one point got infected with a malware. Most likely a Trojan, but lately ransomware is being quite common. Ransomware is simply just a malicious software that encrypts all of your data on a system and asks for money or ransom, which is usually in crypto, in order for your data to be decrypted. Now, when it comes to malware, it can also be sometimes transferred through an exploit, which leads us to our next most common cyber threat, which are zero-day exploits. Now, why is it called a zero-day exploit? Well, zero-day exploits target vulnerabilities in software or hardware that are unknown to the vendor or to the public. Cybercriminals exploit these vulnerabilities before a patch or fix is developed, giving defenders pretty much 0 day to respond. Now, discovering zero-day exploits is a big thing, and it requires lots of exploit development knowledge to be able to do that. That is why, not so rarely, zero-day exploits are selling on the deep web market for over $100,000. Now, we mentioned Stuxnet in the last lecture, which was a worm that targeted Iran nuclear power plants. Stuxnet is believed to have used at least 4 zero-day vulnerabilities, making it an exceptional, sophisticated and targeted cyber weapon. The use of multiple zero-day exploits highlighted the level of sophistication and resources behind Stuxnet, suggesting the involvement of a well-funded and technically advanced entity, possibly a nation-state. The specific details regarding the zero-day vulnerabilities and their origins are often closely guarded due to the sensitive nature of cyber weapons and the potential for similar tactics to be employed in the future. However, it is important to mention that running an exploit attack does not necessarily mean that you need to be using a new zero-day exploit. Perhaps the target that you're attacking has not patched its system for years, and old exploits which were patched long ago still work on the target systems. That is a more common scenario in the world, as people rarely update their systems on time. Another very common cyber attack is actually a network or service attack, which is distributed denial of service, or also known as DDoS attack. Now, denial of service attacks aims to overwhelm a system, a network or website with a flood of traffic, which essentially makes it unavailable to other users. DDoS attacks involve multiple compromised computers forming a botnet to launch a coordinated attack. The goal is to disrupt services or cause downtime. These infected computers are also sometimes referred to as zombies. Now, another attack category which you might have encountered before, and that is spoofing. Spoofing is a technique through which a cybercriminal disguises themselves as a known or trusted source. In doing so, the adversary is able to engage with the target and access their systems or devices with the ultimate goal of stealing information, extorting money, or installing malware or other harmful software on the device. Spoofing can take many forms, as you can encounter domain spoofing, email spoofing, ARP spoofing, and spoofing IP or MAC address. Basically, it can come in many forms. For example, ARP spoofing is used in one of the most common network attacks out there, which is MITM or man-in-the-middle attack. Another attack category, which we should be familiar with, is identity-based attacks. Now, identity-driven attacks are extremely hard to detect. When a valid user credentials have been compromised and an adversary is masquerading as the user, it is often very difficult to differentiate between the user's typical behavior and that of the hacker who is using traditional security measures and tools. Identity-driven attacks include brute force attacks, password spraying, pass the hash attacks, and others. Okay, so we got two more which I want to talk about, which are first, code injection attacks. These mostly refer to website attacks, and they consist of an attacker injecting malicious code into a vulnerable computer, network, or a web page to change its course of action. There are multiple types of code injection attacks, but the two most common ones are SQL injection and cross-site scripting. And last attack that I want to mention are insider threats. Now, insider threats are internal actors such as current or former employees that pose danger to an organization because they have direct access to the company network, to its sensitive data, and intellectual property, as well as the knowledge of business processes, company policies, or other information that would help carry out such an attack. Now, internal actors that pose a threat to an organization tend to be malicious in nature. Some motivators include financial gains in exchange for selling confidential information on the dark web, or it could be some personal reasons such as perhaps the employee getting fired from their job or being mistreated on their job. Alright, these would be the most common categories of cyber attacks out there. You should be familiar with these, as we will actually be creating coding projects in Python that integrate AI technology in order to protect against some of these threats. Stay tuned for that. Whenever something is important, like for example cybersecurity, it is necessary to have certain policies or procedures, especially in large companies where there are thousands of devices inside the network. These policies and procedures should ideally help us to have better protection and also to more quickly and efficiently respond to a cyber threat if it happens. And trust me, if you are online on the internet, it is not a question if it will happen, but rather when it will happen to you. So now you understand that security policies and procedures are essential components of an organization's overall cybersecurity strategy. They provide a framework for maintaining the confidentiality, integrity, and availability of information and resources. Some of the policies that should be created or taken into consideration are access control policy, which governs the mechanism for granting or restricting access to systems, networks, and data. It outlines the procedures for user authentication, authorization, and the principle of least privilege to ensure that individuals have access only to the resources necessary for their roles. We should also consider data classification policy, and data classification policy simply defines how data should be classified based on sensitivity and importance. This policy helps determine the appropriate level of protection and handling for different types of information, as well as guiding employees on how to handle and share data. Also, in case an attack or incident occurs, which it most likely will at some point in time, we should also have incident response policy ready. This policy outlines the procedures to be followed when a security incident occurs. It includes steps for reporting incidents, assessing their severity, containing the incident, and conducting post-incident reviews to improve future response efforts. Now, of course, this policy gets updated very quickly after the incident, since usually it just falls in the water when you encounter something for the first time. That is why it is important that it is precisely defined what needs to be done and what has priorities in certain incidents. Another policy which you might have heard about before, which is Acceptable Use Policy, or AUP. Now, Acceptable Use Policy defines the acceptable ways in which employees, contractors, and other users may use the organization's information or resources. Now, don't confuse AUP with Access Control Policy. Access control policy mentions who can and who cannot access certain resources, while acceptable use policy refers to how these resources should be used. It often covers guidelines for internet and email usage, software installation, and the handling of sensitive information. Now, those would be some of the important policies, and some procedures, on the other hand, would include user account management procedures, patch management procedures, security awareness training procedures, and let's say backup and recovery procedures. Now, user account management procedure describes the process for creating, modifying, and deactivating user accounts. It includes steps for user authentication, password management, and periodic access reviews. Patch management procedure provides guidelines for keeping software and systems up to date with the latest security patches. This involves regularly reviewing and applying patches to address known vulnerabilities and reduce the risk of exploitation. Security awareness training describes the methods and frequency of security awareness training for employees. It covers topics such as recognizing phishing attempts, understanding security policies, and promoting a security-conscious culture within the organization. And the backup and recovery procedure details the process for regular data backups, offsite storage, and recovery in the event of data loss or system failure. This ensures that critical data can be stored efficiently in case of emergencies. Okay, these would be just some of the policies and procedures that an organization might implement. There are, of course, many other possible policies and procedures, but these are just the most common and, in many cases, the most important ones. Now that we got that out of the way, let us talk about most common cybersecurity tools in the next lecture. Okay, let us talk about some important cybersecurity tools which you might want to know about. So, before just listing them out and talking about what each tool is used for, it is important to note that cybersecurity can be both defensive and offensive. Just like there are black hat hackers who hack for bad and who hack in order to inflict some damage, same way there are white hat hackers or ethical hackers who hack for good. They are a part of cybersecurity as they hack in order to better protect the system or network. So we can first make the difference between defensive cybersecurity tools and offensive tools that ethical hackers use. First, let us talk about defensive tools. Most of them you have heard about already, but let us just quickly go over these and say what each of them is used for. First of all, we have firewalls. Firewalls act as a barrier between a trusted internal network and untrusted external networks, monitoring and controlling incoming and outgoing network traffic based on the predetermined security rules. There are many different types of firewalls, but the main division is network firewalls and host-based firewalls. Their name is self-explanatory. Network firewall can be a hardware or a software that is used to set filters or traffic rules for the network, while a host-based firewall is installed on the endpoint device, which could be a PC, and it only sets rules for that specific device in order to filter traffic on it. Another thing you not only know about, but most likely also use, which are antivirus softwares. Now, antivirus software detects, prevents, and removes malicious software from a computer or network. No need to explain much about that, we all know what antiviruses are used for. Now, some common terms in cybersecurity that you will also hear about are IDS and IPS. IDS and IPS stands for Intrusion Detection and Intrusion Prevention Systems. IDS monitors network or system activities for malicious actions or policy violations, while IPS goes a step further by actively preventing or blocking unauthorized access or malicious activities. Now, same way that there are host-based firewalls and network-based firewalls, there are also host-based intrusion detection and network-based intrusion detection systems. Same goes for intrusion prevention systems. There are host intrusion prevention systems and network intrusion prevention systems. These systems can have signature-based, anomaly-based, and behavioral-based detection and prevention. Alright, and one more important thing when it comes to defensive cybersecurity are SIEM systems. SIEM system stands for Security Information and Event Management. SIEM collects and analyzes log data from various systems across an organization to identify and respond to security threats. The primary goal of SIEM is to provide a comprehensive view of an organization's information security, enabling effective detection and response to security incidents. Some of the key components of SIEM systems include event correlation. SIEM tools correlate events from different sources to identify patterns and potential security incidents. They also perform log management, where SIEM systems collect and store log data from various sources such as network devices, servers, applications, and security appliances. SIEM systems also often incorporate UEBA to analyze and baseline normal behavior patterns for users and entities. Now, UEBA stands for User and Entity Behavior Analytics. SIEM tools integrate with external threat intelligence feeds to enhance the detection capabilities. They can be integrated with already previously mentioned tools such as IDS and IPS, and they can be used for incident responding since SIEM facilitates coordinated and efficient incident response process by providing a centralized platform for analyzing and managing security incidents. Alright, now these would be some of the SIEM system functions. SIEM can be used for many other things as well, but we will not be diving into that right now. We are left to discuss offensive tools in cybersecurity, so let's talk about the most widely used ones. We have Nmap. Nmap does not necessarily have to mean that it is used for offensive purposes, as it can be used by cybersecurity experts as well, and not just ethical hackers or penetration testers. Nmap stands for Network Mapper, and it is a widely used tool for scanning networks and systems for open ports and for services running on those open ports. Typically, this is done in the scanning phase of a penetration test, and it can provide some very valuable results about a network. It can figure out which devices are online, and it can see which ports on those devices inside the network are open or closed. Once it discovers open ports, it can check for versions of software running on those open ports. Now, in the advanced usage of Nmap, you can also run scripts which can be used to detect vulnerabilities inside the network. Another common tool that is widely used in the offensive part of cybersecurity is Metasploit framework. Now, Metasploit framework is an advanced open source framework for developing, testing, and executing exploit code. It comes with a large database of exploits, and it's widely used for penetration testing. With Metasploit, you can run exploits without even understanding or knowing how to code. This is both a good and a bad side, as anyone with a little bit of knowledge can run very dangerous exploits by just providing several options which they can Google. Alright, the next tool that we have, which is used for bug bounty hunting or website penetration testing, is a tool called burpsuit. Now, burpsuit helps find security vulnerabilities, and it is equipped with various tools for manual and automated testing. It offers a wide range of options, from being a simple proxy to filtering and intercepting each HTTP request and response, as well as manually or automatically altering the HTTP requests and responses in order to conduct various different attacks. These attacks can be anything from, let's say, brute force attacks on login web pages to injecting malicious codes into HTTP requests. And let's also mention one more common tool in penetration testing, and that is John the Ripper. Now, John the Ripper is a fast password cracker that supports a variety of password hash types. It is one of the go-to tools when it comes to password cracking, and some competitors would be a tool like, for example, Hashcat, which is also an advanced password cracking tool supporting various hashing algorithms. And we also have aircrack-ng, which is a password cracker for wireless networks. Okay, now you know some basic common tools used both by defensive and offensive side of security. Pretty interesting, right? Now, let us shift our focus to talking about some well-known cybersecurity certifications which you might consider taking if you decide to stay in this field. See you in the next lecture. Welcome back. In this lecture, we will focus on the most widely accepted cybersecurity certifications. Cybersecurity certifications play a crucial role in validating the skills and expertise of professionals in the ever-evolving field of cybersecurity. These certifications not only demonstrate a practitioner's knowledge, but also provide a standardized benchmark for employers to assess the competency of their cybersecurity workforce. There are many well-known certificates, but let us mention the basic ones that can boost your career and that are actually required by various different companies. So let's list them out. We have the entry-level certificates, like for example Security Plus, and Security Plus is an entry-level certification offered by CompTIA that provides a foundational understanding of cybersecurity principles and practices. It covers topics such as network security, compliance and operational security, threats and vulnerabilities, application data and host security, and identity management. Security Plus is a vendor neutral and serves as a stepping stone for more advanced certifications. Another one that ethical hackers get is CEH, or Certified Ethical Hacker Certificate. It is offered by the EC Council, and it is designed for professionals who want to understand and practice ethical hacking techniques. It covers areas such as footprinting and reconnaissance, scanning networks, enumeration, system hacking, and web application hacking. Now, CEH is widely recognized in the industry and is valuable for those interested in penetration testing and vulnerability assessment. Let us not forget about the CISP certificate, which stands for Certified Information Systems Security Professional, and it is a globally recognized certification that covers a broad range of cybersecurity topics. It is designed for professionals with significant experience in the field and focuses on security and risk management, asset security, security engineering, communication and network security, identity and access management, security assessment, and testing, as well as many other domains. Now, some additional known certificates include OSCP, which is offered by Offensive Security, and OSCP is well regarded in the penetration testing and ethical hacking community. It is a hands-on certification that requires candidates to complete a challenging 24-hour practical exam, demonstrating their ability to identify and exploit vulnerabilities in various systems. And there is also CISM, or Certified Information Security Manager, which is geared towards information security management. It focuses on governance, risk management, and incident management. Now, Certified Information Security Management is particularly beneficial for professionals in leadership roles within the cybersecurity domain. Now, these would be just some of the certificates that are important. But if you want to learn about others as well, or if you're wondering which ones are best ones to kickstart your career, you can take a look at these articles. This is the CompTIA article, which mentions what are the best cybersecurity certifications for 2023 and 2024. And this is Coursera article on 10 most popular cybersecurity certifications. So you can feel free to read both of these if you want. Nonetheless, we got one more lecture to cover inside of this section, and that is talking about cybersecurity practices for regular people like you and me to best protect themselves on the internet. See you in the next lecture. Alright, last lecture of this section, and perhaps the most important one for someone who just wants to stay safe on the internet. Let's talk about some of the best cybersecurity practices for a regular person to protect themselves from online threats. If you follow what we show in this lecture, you will be more secure than 99% of people out there. So let's start first with the most basic rule, and that is to always create strong passwords and never use the same passwords for different accounts. So some of the rules of creating a strong password would be that it should be complex, meaning it should consist of lowercase and uppercase letters, as well as have symbols and numbers included inside the password. The minimal length of a password should be 8 to 10 characters, but even more is recommended. Also, you want to avoid using easily guessable information such as birthdays or common words. If you're wondering why I mentioned first that you should have different passwords for all the accounts, well, imagine you create a really strong password, but you use it for both Netflix and your PayPal account. Now, imagine the Netflix database gets breached and now the hackers have your password. You wouldn't care because it is just Netflix account. But if they test the same credentials on other websites, including PayPal, the credentials will go through and they will successfully log in. Luckily, this is not so easy for them to do due to the cyber security practice that we always encourage anyone to have, and that is to enable multi-factor authentication. You always want to add an extra layer of security by enabling two-factor authentication whenever it's possible. This typically involves receiving a code on your mobile device or email that you must enter in addition to your password. This is really helpful as even if the hackers manage to get access to your account credentials, they still need an additional code which you receive over email, Authenticator app, or over phone number. But these are the things that regular people mostly follow nowadays. However, what most people do not do is they do not regularly update their operating system, devices, and applications. This is super important as not updating your software can leave it exposed to already existing vulnerabilities and can allow an easy access for the attacker by just exploiting that vulnerability. Remember what we said before. Exploitation is using a vulnerability to exploit a machine through that vulnerability. That is why patching is important. Same goes for patching your security software. Most of the time, threats come in the form of malware, usually a simple Trojan. And attackers make sure that these Trojans are regularly updated to bypass many security measures, including antiviruses. That is why it is important to regularly update security software to ensure it can defend against the latest threats, as well as use well-known antivirus and anti-malware software to protect against various forms of malicious software. But as we mentioned before, social engineering is a big part of hacking. You can have all the latest antivirus software, strong password, and multi-factor authentication, but if you open something that you shouldn't, it all falls to the water. That is why you should always be cautious when downloading something from the internet. Especially be cautious with emails, as they are the #1 target for phishing attack. You should always avoid opening emails from unknown or suspicious sources, and you should verify the legitimacy of unexpected emails, especially those requesting sensitive information. And if you can, stay up to date with latest attacks and be informed about the ways that you can be targeted. This step pretty much helps the most when it comes to cybersecurity. And of course, the last step or the last cybersecurity measure that you should include is having backup of all of your important data. That's right. Anyone can get hacked. Even if you follow all the previous steps, you might end up falling for something and getting hacked. That is why you should always be prepared for that to happen. An attacker could, for example, execute ransomware on your system and lock all of your files. So, in order to battle that, you should perform regular backups of critical data to minimize the impact of a potential ransomware attack or data loss. These backups, however, should also be stored in a safe location, which is preferably offline. Okay, these would be the steps to having higher security on the internet. Remember, half of the work is to always be cautious of what you're doing or downloading online. The other half is regularly keeping up and updating with the latest security software and operating system patches. Nonetheless, this section was a small introduction to cybersecurity for those of you who were new to it, and now let us shift our focus back on AI in cybersecurity. See you in the next lecture.
Wherever we go, we see a term called artificial intelligence. But if you ask more technical person, they will potentially tell you, instead of artificial intelligence, machine learning. So what is machine learning and what is the difference between AI and ML? Well, we'll talk about the main technical difference later down this module, but for now, let's consider them to be the same. The goal of any AI or machine learning is to get some information from data and try to use that information to predict new things coming its way. For example, new user comes to your platform, you want to recommend new things to that new user. So machine learning, when we talk about it, or AI, is a subset of computer science. And if you go to a certain college or a faculty, you'll potentially gonna have machine learning as a subject, as a part of curricula for computer science. Now, these days, people are breaking down machine learning to a lot of different smaller pieces and creating a program as itself, like a data science, machine learning, and AI. But overall, ML or AI is just a subset of computer science. So you're working with programming, you're working with computers to create some systems that are going to leverage the data, and we can call it experience because we are actually monitoring everything that happened in the past and encoding it in a data set or a data that we can use to predict new things later down the road. Now, when we talk about this and when we address machine learning as a kind of a way of programming computers, it's always a good question to see, okay, but what is the difference between that approach and traditional software engineering? Well, if you and I sit down in some office, for example, and they give us a task to program a system that will recognize this cat on the screen. First of all, we'll start to brainstorm of ideas. So what actually represents this cat? Now, of course, there are eyes, fur, there is a necklace with a name. There are many other features that we can start to notice or start to associate with this cat, because that's our task. And if you approach this as a kind of a traditional software engineering, you would approach it and write a set of functions to address these nuances or these features individually. Like, let's detect right ear, left ear, eyes, nose, necklace, and so on. Potentially a fur, a texture. Now, every single piece of this set of functions might be challenging or less challenging depending on what we try to detect. But overall, what happens if this comes to our system? They're still cats, but our checkers will fail for all of this. Now, on this image right here, ears and eyes are not the same shape. They are similar, but not as close to what we encoded before. And of course, none of these have necklace. So that check by itself will fail. So that's why you need something that will leverage the experience of seeing many different cats with different situations, like you see right here, to build such a system. And that's why we need machine learning or AI. These systems that we call AI will take tremendous amounts of data. Like in this image right here, we have 3 images, but some data sets have millions, if not billions of images. For example, ChatGPT was trained on billions of individual texts to have the performance that we are used to it. Now we are giving that as a kind of experience and telling the system, in this case, some machine learning model or AI model, to predict what's represented by this image. Now, because any AI system is not 100% correct, there is always some mistake or an error in the system. It will predict with a certain confidence about that prediction. In this case, it's predicting between cats and dogs. Now, in this case, 90% certain it's a cat. However, there is slight chance there is a dog in an image. Now, of course, it's going to choose the cats because it's a more confident inside of it. But any machine learning system will never be 100% certain. The great question is to ask ourselves, but why now? AI by itself is not new. AI existed from 50s actually as a term. And from the early on through 60s, 70s, 80s and 90s, we had a lot of ups and downs. 2 AI winters, which means basically 0 investments in AI or small investments in AI technology, and a lot of trials and errors between these winters to make something that works. Now, these days, wherever we turn, we see some kind of AI. But why is that? Well, there are 2 main reasons: data and computation. Now, here we are generating more data as a civilization than ever. And we need some kind of an approach, an algorithm that will leverage the data to process new data that comes. Because right now as civilization, we generate crazy amounts of data that we don't have resources to edit or to work with. And ML can recognize what are the opportunities there and help them predict us. Now, of course, because the data is a data, it's industry independent, which means that you can apply these approaches such as AI almost everywhere. And besides the data, there is hardware. Early on in the previous century, we had ideas on how to solve this. But unfortunately, even though we had some amount of data, we didn't have enough compute power to learn or compute power to make predictions by using these algorithms and these approaches. And that's why we have that now. And just to put you into perspective, we are generating this much bytes every single day. And of course, there is no human being or a company or algorithm right now that can use all of that data and process it in a way that it makes sense for companies or for computing power today. Now that we have a certain knowledge of what is machine learning and why now, let's touch upon on what machine learning exists out there, what are the types of machine learning, and discuss that in the next video. See you there. Based on the difference in definition of a problem or the data set that we have to represent that problem, there are different types of AI approaches or machine learning as we call it right now. So let's touch upon and understand what are the opportunities out there for you to understand more approaches in machine learning and potentially solve some difficult problems in your companies. So there are 4 distinct approaches in machine learning. Now, there are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. And each of these can be broken down into smaller categories or approaches, I would say, to handle different data points. Now, in supervised way, first of all, what is supervised way of learning or supervised learning in short? In these tasks, we have a data set that we collected, whatever that might be. It can be any source of data. It can be a tabular data, text, images, videos, audio, anything. But we already have a label associated with it, whatever that might be. So, for example, in this case right here, we collected a lot of images of a cat. Now, instead of just having an image of a cat, we actually manually went and labeled these images as a cat or a dog. Now, there is a mistake here, which is a dog, and we have it as a cat, which happens quite often when we are labeling manually. Now, unfortunately, in supervised learning, it requires that manual labeling before we can put it through machine learning or AI to make better predictions down the road. Unfortunately, because it takes time and money to do that, and especially money if you want a lot of samples with a high quality of labels. Sometimes you can't label all the data, of course, and that's why you're gonna go in a different direction of learning, which we're gonna take upon in a second. But supervised learning is just that. You have some data and you have labels associated with that. And with that information, you want to map that data to those kind of labels when a new piece of that information, piece of data, in this case image, comes to your system. Based on the label that you are associating with your data set, there are 2 approaches, regression and classification. The main difference is the type of the label. So regression is continuous number. For example, if you have information about hotels and you want to predict the price of per night, for example. So you would collect information such as number of rooms, star of a hotel, location maybe, even images of hotel rooms. And based on all of that information, you're giving a price, which is an estimate, of course. And it's in a real number, so it can go from 0 to maybe a couple of $1,000s per night. And that's called regression. Now, on the other hand, we have a classification, which is a distinct thing that we're trying to predict. For example, is it a cat or a dog? Is it a car or a truck? And that's the main difference between regression and classification. If you can represent your problem as a supervised learning, you will potentially win. So supervised learning is the easiest to solve, the most predictable, and everybody wants to do supervised learning if they can. The rest of the ways of learning that I'm gonna explain in a second are there to handle some approaches if you don't have supervised learning. If you have supervised learning, go with it because it's the best approach that we have today. On the other hand, we have unsupervised learning. Unsupervised learning, as the name suggests, the only difference is we don't have labels associated with our data. So we only have data, for example, images. We don't have any information what might be present in that image, for example, or how many different things are there. If we are labeling, we know that there are, for example, cats and a dog, but maybe we have much more. For example, humans, cars, trucks, trees, stuff like that. You don't really know. Now, if you only have data, you don't have labels with it, that's why you're going to use unsupervised learning. Now, of course, if you can label, go label dataset and bring back to supervised learning. But unsupervised learning is approach to handle if you don't have that information. And it's used in marketing really often for customer segmentation, for example, or fraud detection in banking. So you are trying to leverage the kind of a consistency in the data set to recognize what are the parts of the data set that are unique to those different segments of it in customer segmentation problem. In a fraud detection, you're using that consistency to see if there are some outliers or points that are not really consistent with the data set that you collected. And that's why you have anomaly detection or fraud detection. The third approach is called semi-supervised learning. Now, semi-supervised learning is a combination between supervised and unsupervised learning. You're using a partially labeled data set to train a machine learning algorithm that will be used to label the additional data points, which can be later checked and used to train better algorithm in the future. So you're kind of in a circle training better and better machine learning models or algorithms that will yield with the better results in the future. And finally, we have reinforcement learning. Reinforcement learning is, I would say, the most interesting thing to watch. The reinforcement learning is more and more complex than what we mentioned so far, and it's using an agent or algorithm that will interact with the real world. So that might be a game, for example, a car, and you're trying to imitate humans how they drive, so you're taking their actions in the system and interacting with the car to see how well that car might perform. That's where reinforcement learning comes in. You're kind of training a dog or a human being to function in the world. You are giving it a way to do whatever they want. You don't really specify what are the options out there. You don't really say, hey, dog, you can go to a toilet, you can walk, you can bark and stuff like that. Somehow those biological functions are always there present with the dog. Now, you want to accommodate with a certain behavior rhythm that you are setting as a kind of a rules of the environment that you are setting for the dog to live in. So don't go in toilet inside the house. Wait for us to go outside and stuff like that. Always sit before the lunch and all those things that you might feel need to control or to coordinate between you and an agent, in this case, a dog. Now, whenever you see some behavior points of a dog that you like, you're going to give some treats. Those treats are good dog treats, of course. Now, in the real world of reinforcement learning or a world of reinforcement learning, that environment is not you, not your house. It might be in the future, but not now. We are using some kind of a simulation or a game or something like that. Maybe even a system that is for cooling, for example. And the agent is our algorithm, so it's not visible to us. We are writing a code for an agent. And those rewards, now we don't have a good dog treats, unfortunately, but we have the zeros and ones. So if you perform some good activity, for example, if you're trading on a stock market and you win a decent price or decent difference on trades, then you receive 1 as a reward. Now, if you lose money, you basically get -1. But if you stay in that sum range, you get 0. So by defining these rewards and by repeating some actions many, many times, you are telling the agent what you prefer to see in the future. And the agent will try to accommodate that and to see how many times it's going to happen in the future. Okay, and that's it. Let's now talk about 3 different stages of AI, as we call it: artificial narrow intelligence, general intelligence, and super intelligence. So let's cover that in the next video. See you there. With the release of OpenAI's ChatGPT, everybody started talking about the term called artificial general intelligence and those labs that are supposedly working on AGI. Now, we are far from it, and we won't have the real AGI for a long time. We might have some versions of it in the near future after recording this course, but what actually AGI is, in the next 10 to 20 years, we might have some signals that it actually exists. But before that, not really. And it's more on an ANI sphere. But let's not talk about these terms in these vaguely terms that everybody's talking about. Let's actually see from a technical standpoint and from general standpoint what those terms are and how to use them and when to use them. So you will find the link to this write-up in the resources of this video. Now, there are three kind of stages of evolutions of AIs. We are currently living in a world of ANIs, which stands for Artificial Narrow Intelligence. And those are designed to perform a single task. Now, I'm going to touch upon that in a bit. But besides ANI, there are two different stages that are more advanced, supposedly. Artificial General Intelligence, which is there to kind of behave as a human, and there is, of course, Artificial Superintelligence, which is sci-fi movies stuff. Speaking of today's AI, which is ANI, every single artificial neural network or algorithm that we have, or a system, AI system that we have, is designed to perform a single specific task. Now, you might have a set of algorithms performing different scenarios and different tasks, but in reality, you are having one algorithm per task. Now, you might say, okay, cool, but what is OpenAI's ChatGPT? Is it actually AGI because it can talk about everything? Not really. AGI is there to behave as a human, to be actually a kind of a human and perform tasks in a different way. And of course, besides that part, it creates new pieces of information that we can use and learn from. Unfortunately, we are still in the ANI form, where it's trained to do one specific task. Now, ChatGPT, because it's working with text and it's versatile of the topics that it can cover, it sounds like AGI, but it's not really there. It doesn't understand the text, it doesn't understand what it actually generates. It understands the probabilities of a next word coming after the word that you give. Now, all LLMs, including GPT-4, is trained to perform one single task, which is predicting the next word in a sequence. So, for example, if I give you I, what is the most likely word after I? Well, for example, I love. And then when you say I love, what is the third word coming after this? That can be any word, of course, in English. So you are using the text that you trained your algorithms on, in this case GPT, to create a scene or to see how many times I love, for example, I don't know, computers, comes in your set of text that you provided. If it's the only way that you use I love computers, all the time that you type I love, the next word will be always computers, because that's the only combination of words that you saw when you trained your system. And that's why OpenAI's ChatGPT is narrow intelligence. It performs one single task really well, which is predicting next word in a sequence. Now, Google's Gemini and all the other multi-input neural networks, for example, Gemini, it works with inputs such as text, video, audio, and images. And you might now think, okay, but it's really close to AGI. Well, not really. It's only using 4 different input sizes or input scenarios, while the output is still predicting the next word. So it's still predicting only one single task, which is predicting the next word. And that's why it's ANI. Now, in artificial general intelligence, we're expecting humans. So it can grow, it can extrapolate new information, it can decide what they're gonna do, it can decide what it's gonna learn. what to do with that information, and so on. And the other specter, the far, far right, is artificial superintelligence, which is ASI. And that is smarter than us, and it can do anything better than us. And that's why we are in the region of sci-fi movies. We don't know how to make it, maybe in like 200 years from now, but before that, no. And yeah, that's it. Now that we covered the main parts of AI, let's talk about AI terminology in the next video and to recognize what are the terms everybody is throwing to you every single day. See you there. With the release of ChatGPT, most people heard about AI for the first time. And that's why they associate AI with ChatGPT, meaning that's all there is, nothing else than ChatGPT. Now, unfortunately, ChatGPT is only 5% of AI. There is so much more than ChatGPT alone. And I want to take this kind of a brief video to explain most terminologies that are thrown to you just to go from the high ground, which is AI, to something that is ChatGPT. Okay, so we have beyond this image something called data science. Now, data science is using AI as kind of a way of solving data problems. And data science is an umbrella term for every operation that we might use data in to perform some analysis or predictions on top of it. Now, AI is just a way to process the data, so we have so much more than AI in data science. Now, if we focus only our vectors to AI, the AI term will be there to recognize as everything happening today. And AI as a term was created in the 50s back then, and for automation purposes, for path planning algorithms, for finding a way through Google Maps, all those are considered AI. Now, in the previous video, we've spoken about ANI, AGI, and ASI. Besides that, we have ANI, which are narrow intelligence. And when we go deeper and deeper, the narrow intelligence is kind of an AI, and we can tell it that they're the same thing because we don't have AGI, we don't have ASI. Maybe we'll never have it, maybe in future, yes. But for now, everything that we have is artificial narrow intelligence, or ANI. Now, in the first video of this section, I mentioned that machine learning and AI are basically the same. And I didn't lie, they are basically the same. However, in artificial intelligence, or AI, there are a couple or more approaches that are not considered machine learning, such as planning. So planning might be finding a way from one dot in the map to another, which is traditionally solved in a different set of algorithms, not with machine learning. And those are used, for example, in maps, such as Google Maps. Now, machine learning, as we've spoken, is a way to give to algorithm like a large sum of data, and you want to extract information from that large sum of data. So you can extract that information and say, okay, this is what we are used to it. This is how we generate the data or use the data. And that's what we expect to happen in the future with our users as well. So machine learning has an option to get a lot of data inside of it, inside the algorithm, capture the essence of it, and apply that model of a data of the world through the data to new data that comes your way, such as user-generated data. Now, then we have a deep learning, and deep learning is just a set of algorithms under machine learning. And deep learning is a set of algorithms called deep neural network. And they are kind of a way of recognizing things such as human brains. But there is much more in machine learning than just deep learning. But deep learning is something that we use and have every single day, such as ChatGPT, Google Search, Google Maps, Google Images, Facebook feed, news feed, and stuff like that. Then under deep learning, we have classification for images, for text, for tabular data, for audio. And then on top of that, we have generative AI, which is just a small part of deep learning. You see how much I told you about deep learning that is not generative AI, for example, working with images, such as Tesla, which is computer vision. There is nothing to do with generative AI. Now, in generative AI, we have ChatGPT, GANs, diffusion models such as Stable Diffusion, Midjourney, and stuff like that. And under generative AI, you have many algorithms for working with text, with images, and other. And one part that works with text is called language model. And this language model can be large language model, which is determined by amount of parameters and data, or a small one. So it depends on how much data you have. Then under LLMs, you have many different types such as BERT, Roberta, and then you have something called transformer. And on top of transformer, you have GPT, which is standing for Generative Pre-trained Transformer. These GPTs is architectures, and they have Palm by Google, Llama by Meta, GPT 3.5 by OpenAI, and just one of them is called GPT-4. So right now, based on this graph, you see that there are many terms. You don't have to remember them all, and you will use this lecture as a kind of a reference to refresh it once you forget it, which is completely okay. But from this image alone, you see that what you have is so much greater than only ChatGPT. That's it for the terms of AI. See you in the next video.